You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at RudolfSteiner.podbean.com. Please consider becoming a patron. As well, there are two publishing houses, SteinerBooks.org in America and RudolfSteinerPress.com in England, which are the sole publishers of Steiner into English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works, Volume 324A, by Rudolf Steiner, entitled The Fourth Dimension, Sacred Geometry, Alchemy, and Mathematics, translated by Catherine Creeger. It is, I believe, notes and a 6-lecture course and some other lectures, so I don't have the exact number of items in this, and there are also questions and answers. This is the first lecture given in Berlin on March 24th, 1905. Because I will begin by discussing elementary aspects of the fourth dimension, what you hear today may disappoint you, but dealing with these issues in greater detail would require a thorough knowledge of the concepts of higher mathematics. I would first like to provide you with very general and elementary concepts. We must distinguish between the reality of four-dimensional space and the possibility of thinking about it. Four-dimensional space deals with a reality that goes far beyond ordinary sense-perceptible reality. When we enter that realm, we must transform our thinking and become familiar with the way in which mathematicians think. We must realize that at each step mathematicians take, they must account for its impact on their entire line of reasoning. When we concern ourselves with mathematics, however, we also must realize that even mathematicians cannot take a single step into four-dimensional reality. They can arrive at conclusions only from what can and cannot be thought. The subjects we will deal with are initially simple, but become more complicated as we approach the concept of the fourth dimension. We first must be clear about what we mean by dimensions. The best way to gain clarity is to check the dimensionality of various geometrical objects, which then will lead us to considerations that were first tackled in the 19th century by such great mathematicians as Bolyai, Gauss, and Riemann. The simplest geometrical object is the point. It has no size. It can only be imagined. It fixes a location in space. It has a dimension which equals 0. The first dimension is given by a line. A straight line has one dimension, length. When we move a line, which has no thickness, it leaves the first dimension and becomes a plane. A plane has two dimensions, length and breadth. When we move a plane, it leaves these two dimensions. The result is a solid body with three dimensions, height, breadth, and depth. See Figure 1. When you move a solid body, such as a cube, around in space, however, the result is still only a three-dimensional body. You cannot make it leave three-dimensional space by moving it. There are still a few more concepts we need to look at. Consider a straight line segment. It has two boundaries, two endpoints, point A and B, see Figure 2. Suppose we want to make point A and point B meet. To do this, we must bend the straight line segment. What happens then? It is impossible to make points A and B coincide if you stay within the one-dimensional straight line. To unite these 2 points, we must leave the straight line, that is, the first dimension, and enter the second dimension, the plane. When we make its endpoints coincide, the straight line segment becomes a closed curve, that is, in the simplest instance, a circle. See Figure 3. A line segment can be transformed into a circle only by leaving the first dimension. You can duplicate this process with a rectangular surface, but only if you do not remain in 2 dimensions. To transform the rectangle into a cylinder or tube, you must enter the 3rd dimension. This operation is performed in exactly the same way as the preceding one, in which we brought 2 points together by leaving the first dimension. In In the case of a rectangle which lies in a plane, we must move into the third dimension in order to make two of its boundaries coincide. See Figure 4. Is it conceivable to carry out a similar operation with an object that already has three dimensions? Think of two congruent cubes as the boundaries of a three-dimensional rectangular solid. You can slide one of these cubes into the other. Now imagine that one cube is red on one side and blue on the opposite side. The only way to make this cube coincide with the other one, which is geometrically identical, but whose red and blue sides are reversed, would be to turn one of the cubes around and then slide them together. See Figure 5. Let's consider another three-dimensional object. You cannot put a left-handed glove onto your right hand. But if you imagine a pair of gloves, which are symmetrical mirror images of each other, and then you consider the straight line segment with its endpoints A and B, you can see how the gloves belong together. They form a single three-dimensional figure with a boundary, the mirroring plane, in the middle. The same is true of the two symmetrical halves of a person's outer skin. How can two three-dimensional objects that are mirror images of each other be made to coincide? Only by leaving the third dimension, just as we left the first and second dimensions in the previous examples. A right or left-handed glove can be pulled over the left or right hand, respectively, by going through four-dimensional space. In building up depth, the third dimension of perceived space, we pull the image from our right eye over the image from our left eye. That is, we fuse the two images. Now, let's consider one of Zöllner's examples. Readers aside, Zöllner is spelled Z-O-L-L-N-E-R, Zöllner, end of readers aside. Here we have a circle, and outside it a point P. See Figure 6. How can we bring point P into the circle without cutting the circumference? We cannot do this if we remain within the plane. Just as we need to leave the second dimension and enter the third in order to make the transition from a square to a cube, we must also leave the second dimension in this example. Similarly, in the case of a sphere, it is impossible to get to the interior without either piercing the sphere's surface or leaving the third dimension. These are conceptual possibilities, but they are of immediate practical significance to epistemology, especially with regard to the epistemological problem of the objectivity of the contents of perception. We first must understand clearly how we actually perceive. How do we acquire knowledge about objects? Through our senses. We see a color. Without eyes, we would not perceive it. Physicists tell us that what is out there in space is not color, but purely spatial movement patterns that enter the eye and are then picked up by the visual nerve and conveyed to the brain, where the perception of the color red, for example, comes about. Next, we may wonder whether the color red is present when sensation is not. We could not perceive red if we had no eyes, or the sound of bells ringing if we had no ears. All of our sensations depend on movement patterns that are transformed by our psycho-physical apparatus. The issue becomes even more complicated, however, when we ask where that unique quality red is located. Is it on the object we perceive, or is it a vibrational process? A set of movements that originates outside us, enters the eye, and continues into the brain itself. Wherever we look, you find vibrational processes and nerve processes, but not the color red. You also will not find it by studying the eye itself. It is neither outside us nor in the brain. Red exists only when we ourselves, as subjects, intercept these movements. Is it impossible, then, to talk about how red comes to meet the eye or C-sharp the ear? The questions are, what is an internal mental image of this sort, and where does it arise? These questions pervade all of 19th century philosophy. Schopenhauer proposed the definition, quote, "The world is our mental image," close quote. But in this case, what is left for the external object? Just as a mental image of color can be, in quotes, created by movement, so too the perception of movement can come about within us as a result of something that is not moving. Suppose we glue 12 snapshots of a horse in motion to the inner surface of a cylinder equipped with 12 narrow slits between the images. When we look sideways at the turning cylinder, we get the impression that we are always seeing the same horse and that its feet are moving. Our bodily organization can induce the impression of movement when the object in question is really not moving at all. In this way, what we call movement dissolves into nothing. In that case, what is matter? If we strip matter of color, movement, shape, and all other qualities conveyed through sensory perception, nothing is left. If, in quotes, subjective sensations such as color, sound, warmth, taste, and smell, which arise in the consciousness of individuals as a result of environmental stimuli, must be sought within ourselves, so too must the primary objective sensations of shape and movement. The outer world vanishes completely. This state of affairs causes grave difficulties for epistemology. Assuming that all qualities of objects exist outside us, how do they enter us? Where is the point at which the outer is transformed into the inner? If we strip the outer world of all the contents of sensory perception, it no longer exists. Epistemology begins to look like Munchausen trying to pull himself up by his bootstraps. To explain sensations that arise within us, we must assume that the outer world exists. But how do aspects of this outer world get inside us and appear in the form of mental images? This question needs to be formulated differently. Let's consider several analogies that are necessary for discovering the connection between the outer world and internal sensation. Let's go back to the straight line segment with its endpoints A and B. To make these endpoints coincide, we must move beyond the first dimension and bend the line. See Figure 7. Now, imagine that we make the left endpoint A of this straight line segment coincide with the right endpoint B in such a way that they meet below the original line. We can then pass through the overlapping endpoints and return to our starting point. If the original line segment is short, the resulting circle is small. But if I bend ever longer line segments into circles, the point where their endpoints meet moves farther and farther away from the original line until it is infinitely distant. The curvature becomes increasingly slight until finally the naked eye can no longer distinguish the circumference of the circle from the straight line. See Figure 8. Similarly, when we walk on the earth, it appears to be a straight, flat surface, though it is actually round. When we imagine the two halves of the straight line segment extending to infinity, the circle really does coincide with the straight line. Thus, a straight line can be interpreted as a circle whose diameter is infinitely large. Now, we can imagine that if we move ever farther along the straight line, we will eventually pass through infinity and come back from the other side. Instead of a geometric line, envision a situation that we can associate with reality. Let's imagine that point C becomes progressively cooler as it moves along the circumference of the circle and becomes increasingly distant from its starting point. When it passes the lower boundary, A, B, and begins the return trip on the other side, the temperature starts to rise. See Figure 9. Thus, on its return trip, point C encounters conditions that are opposite to the ones it encountered on the first half of its journey. The warming trend continues until the original temperature is reached. This process remains the same no matter how large the circle. Warmth initially decreases and then increases again. With regard to a line that stretches to infinity, the temperature decreases on one side and increases on the other. This is an example of how we bring life and movement into the world and begin to understand the world in a higher sense. Here we have two mutually dependent activities. As far as sensory observation is concerned, the process that moves to the right has nothing to do with the process that returns from the left, and yet the two are mutually dependent. Now let's relate the objects of the outer world to the cooling stage, and our internal sensations to the warming stage. Although the outer world and our internal sensations are not linked directly by anything perceptible to the senses, they are interrelated and interdependent in the same way as the processes I just described. In support of their interrelationship, we also can apply the metaphor of seal and sealing wax. The seal leaves an exact impression or copy of itself in the sealing wax, even though it does not remain in contact with the wax, and there is no transfer of substance between them. The sealing wax retains a faithful impression of the seal. The connection between the outer world and our internal sensations is similar. Only the essential aspect is transmitted. One set of circumstances determines the other, but no transfer of substance occurs. Viewing the connection between the outer world and our own impressions in this way, we realize that geometric mirror images in space are like right and left-handed gloves. To make them coincide directly with a continuous motion, we need the help of a new dimension of space. If the relationship between the outer world and an internal impression is analogous to the relationship between figures that are geometric mirror images, the outer world and the internal impression also can be made to coincide directly only by means of an additional dimension. To establish a connection between the outer world and internal impressions, we must pass through a fourth dimension where we are still in the third. Only there, where we are united with the outer world and inner impressions, can we discover their commonalities. We can imagine mirror images floating in a sea in which they can be made to coincide. Thus we arrive, though initially purely on the level of thinking, at something that is real but transcends three-dimensional space. To do this, we need to enliven our ideas of space. Oscar Simonyi attempted to use models to depict enlivened spatial formations. As we have seen, we can move step by step from considering zero dimension to imagining four-dimensional space. Four-dimensional space can be recognized most easily with the help of mirror image figures or symmetrical relationships. Knotted curves and two-dimensional strips offer another method of studying the unique qualities of empirical three-dimensional space as it relates to four-dimensional space. What do we mean by symmetrical relationships? When we interlink spatial figures, certain complications arise. These complications are unique to three-dimensional space. They do not occur in four-dimensional space. Let's try a few practical thought exercises. When we cut along the middle of a cylindrical ring, we get two such rings. If we give a strip a 180-degree twist before gluing its ends, cutting it down the middle results in a single twisted ring that will not come apart. If we give the strip a 360-degree twist before gluing its ends, the ring falls apart into two twisted interlocking rings when we cut it. And finally, if we give the strip a 720-degree twist, cutting it results in a knot. Anyone who thinks about natural processes knows that such twists occur in nature. In reality, all such twisted spatial formations possess specific forces. Take, for example, the movement of the Earth around the Sun, and then the movement of the Moon around the Earth. We say that the Moon describes a circle around the Earth, but if we look more closely, we realize that it actually describes a line that is twisted around the circle of the Earth's orbit. That is, a spiral around a circle. And then we also have the Sun, which moves so quickly through space that the Moon makes an additional spiral movement around it. Thus, the force lines extending through space are very complex. We must realize that we are dealing with complicated spatial concepts that we can understand only if we do not try to pin them down, but instead allow them to remain fluid. Let's review what we discussed today. 0 dimension is the point, the first dimension is the line, the second dimension is the surface, and the third dimension is the solid body. How do these spatial concepts relate to one another? Imagine that you are a being who can move only along a straight line. What kind of spatial images do one-dimensional beings have? Such beings would be able to perceive only points, and not their own one-dimensionality, because when we attempt to draw something within a line, points are the only option. A two-dimensional being would be able to encounter lines and thus to distinguish one-dimensional beings. A three-dimensional being, such as a cube, would perceive two-dimensional beings. Human beings, however, can perceive 3 dimensions. If we draw the right conclusions, we must say that just as a one-dimensional being can perceive only points, a two-dimensional being only one dimension, and a three-dimensional being only 2 dimensions, a being that perceives 3 dimensions must be a 4-dimensional being. Because we can delineate external beings in 3 dimensions and manipulate 3-dimensional spaces, we must be 4-dimensional beings. Just as a cube can perceive only 2 dimensions and not its own 3rd dimension, it is also true that we human beings cannot perceive the 4th dimension in which we live. The end of Lecture 1. You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at RudolfSteiner.podbean.com. Please consider becoming a patron. As well, there are 2 publishing houses, SteinerBooks.org in America and RudolfSteinerPress.com in England, which are the sole publishers of Steiner into English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works Volume 324A, entitled The Fourth Dimension by Rudolf Steiner, Sacred Geometry, Alchemy, and Mathematics, translated by Catherine Creeger. This is the second lecture given in Berlin on March 31st, 1905. Today I will discuss elementary aspects of the idea of multi-dimensional space, with particular reference to the thoughts of Charles Hinton, a very wise man. As you recall, last time we began by considering the 0 dimension and moved on to multidimensional space. Let me briefly reiterate the ideas we developed about 2- and 3-dimensional space. What do we mean by a symmetrical relationship? How do I make 2 plane figures that are mirror images of each other, such as this red figure and this blue one, coincide? This is relatively easy to do with 2 half circles. I simply insert the red one into the blue one by rotating it. Figure 10. This is not so easy with the mirror image symmetry below. See Figure 11. No matter how I try to insert the red part into the blue part, I cannot make them coincide if I remain within the plane. There is a way to accomplish this, however, if we leave the board, that is the 2nd dimension, and use the 3rd dimension. In other words, if we lay the blue figure on top of the red by rotating it through space around the axis of reflection. The situation is similar with a pair of gloves. We cannot make the one coincide with the other without leaving three-dimensional space. We have to go through the fourth dimension. Last time I said that if we want to acquire an idea of the fourth dimension, we must allow relationships in space to remain fluid in order to produce circumstances similar to those present when we make the transition from the second to the third dimension. We created interlocking spatial figures with strips of paper and saw that interlocking brings about certain complications. This is not just a game, because such interlocking occurs everywhere in nature, especially in the intertwined motions of material objects. These motions include forces, so the forces also are intertwined. Take the Earth's movement around the Sun in connection with the Moon's movement around the Earth. The Moon describes a circle that winds around the Earth's orbit around the Sun. That is, the Moon describes a spiral around a circle. Because of the Sun's own movement, however, the Moon makes an additional spiral around it, resulting in very complicated lines of force that extend throughout space. The relationships of the heavenly bodies resemble Simonet's twisted strips of paper, which we looked at last time. We must realize, as I said earlier, that we are dealing with complicated spatial concepts that we can understand only if we do not allow them to become fixed. If we want to understand the nature of space, we will have to conceive of it as immobile initially, but then allow it to become fluid again. It is like going all the way to zero, where we find the living essence of a point. Let's visualize again how the dimensions are built up. A point is zero-dimensional, a line is one-dimensional, a surface two-dimensional, and a solid object is three-dimensional. Thus a cube has three dimensions: height, width, and depth. How do spatial figures of different dimensions relate to one another? Imagine being a straight line. You have only one dimension and can move only along a line. If such one-dimensional beings existed, what would their idea of space be? They would not be able to perceive their one-dimensionality. Wherever they went, they would be able to imagine only points, because points are all we can draw while remaining within a straight line. A two-dimensional being would encounter only lines. That is, it would perceive only one-dimensional beings. A three-dimensional being, such as a cube, would perceive two-dimensional beings, but not its own three dimensions. Human beings, however, can perceive their own three dimensions. If we draw the correct conclusion, we must realize that if a one-dimensional being can perceive only points, a two-dimensional being only straight lines, and a three-dimensional being only surfaces, a being who perceives three dimensions must be four-dimensional. The fact that we can delineate external beings in three dimensions and manipulate three-dimensional spaces means that we ourselves must be four-dimensional. Just as a cube would be able to perceive only two dimensions and not its own third dimension, it is clear that we cannot perceive the fourth dimension in which we ourselves live. Thus, you see that human beings must be four-dimensional beings. We float in the sea of the fourth dimension, like ice and water. Let's return to our discussion of mirror images, see Figure 11. This vertical line represents a cross-section formed by a mirror. The mirror reflects an image of the figure on the left side. The reflection process points beyond the second dimension into the third. In order to understand the direct, uninterrupted relationship of the mirror image to the original, we must assume that a third dimension exists in addition to the first and second. Now let's consider the relationship between external space and internal perception. A cube outside me appears as a perception inside me, see Figure 12. My idea of the cube relates to the cube itself, as a mirror image relates to the original. Our sensory apparatus develops a mental image of the cube. If we want to make this image coincide with the original cube, we must pass through the fourth dimension. Just as a two-dimensional mirroring process must pass through the third dimension, our sensory apparatus must be four-dimensional to be able to bring about a direct connection between a mental image and an outer object. If you were to visualize in two-dimension only, you would confront merely a dream image. You would have no idea that an actual object exists in the outer world. When we visualize an object, we spread our capacity for mental pictures directly over outer objects by means of four-dimensional space. In the astral state, during earlier periods of human evolution, human beings were only dreamers. The only images arising in their consciousness were dream images. Later, humans made the transition from the astral state to physical space. Having said this, we have defined the transition from astral to physical, material existence, in mathematical terms. Before this transition, astral humans were three-dimensional beings. Therefore, they could not extend their two-dimensional mental images to the objective, three-dimensional, physical, material world. When human beings themselves became physical, material beings, they acquired the fourth dimension, and therefore also could experience life in three dimensions. The unique structure of our sensory apparatus enables us to make our mental images coincide with outer objects. By relating our mental images to outer things, we pass through four-dimensional space, putting the mental image over the outer object. How would things look from the other side, if we could get inside them and see them from there? To do so, we would have to go through the fourth dimension. The astral world itself is not a world of four dimensions. Taken together with its reflection in the physical world, however, it is four-dimensional. When we are able to survey the astral and physical world simultaneously, we exist in four-dimensional space. The relationship of our physical world to the astral world is four-dimensional. We must learn to understand the difference between a point and a sphere. In reality, a point such as the one pictured here is not passive, but radiates light in all directions. See figure 13. What would the opposite of such a point be? Just as the opposite of a line running from left to right is a line running from right to left, a point radiating light also has its opposite. Imagine a gigantic sphere, an infinitely large sphere that radiates darkness inward from all sides. See figure 14. This sphere is the opposite of a point that radiates light. The true opposite of a light-radiating point is an infinite space that is not passively dark, but actively floods space with darkness from all directions. The source of darkness and the source of light are opposites. We know that a straight line that vanishes into infinity returns to the same point from the other side. Similarly, when a point radiates light in all directions, the light returns from infinity as its opposite, as darkness. Now, let's consider the opposite case. Take the point as a source of darkness. Its opposite is then a space that radiates light inward from all directions. As I explained in the previous lecture, a point moving on a line does not vanish into infinity. It returns from the other side. See figure 15. Analogously, a point that expands or radiates does not vanish into infinity. It returns from infinity as a sphere. The sphere is the opposite of the point. Space dwells within the point. The point is the opposite of space. What is the opposite of a cube? Nothing less than the totality of infinite space minus the part defined by the cube. We must imagine the total cube as infinite space plus its opposite. We cannot get by without polarities when we attempt to imagine the world in terms of dynamic forces. Only polarities give us access to the life inherent in objects. When occultists visualize a red cube, the rest of space is green, because red is the complementary color of green. Occultists do not have simple self-contained mental images. Their mental images are alive rather than abstract and dead. Our mental images are dead, while the objects in the world are alive. When we dwell in our abstract mental images, we do not dwell in the objects themselves. When we imagine a star that radiates light, we must also imagine its opposite, that is, infinite space, in the appropriate complementary color. When we do such exercises, we can train our thinking and gain confidence in imagining dimensions. You know that a square is a two-dimensional area. A square composed of two red and two blue smaller squares, see figure 16, is a surface that radiates in different directions in different ways. The ability to radiate in different directions is a three-dimensional ability. Thus we have here the three dimensions of length, width, and radiant ability. What we did here with a surface can also be done with a cube. Just as the square above is composed of 4 subsquares, we can imagine a cube composed of 8 subcubes, see figure 17. Initially, the cube has 3 dimensions, height, width, and depth. In addition, we must distinguish a specific light radiating capacity within each subcube. The result is another dimension, radiant ability, which must be added to height, width, and depth. If every one of the 8 subcubes has a different capacity to radiate, then, if I have just one cube with its one-sided capacity to radiate, and I want to get a cube that radiates in all directions, I have to add another one in all directions, double it with its opposites. I have to compose it out of 16 cubes. Next time we meet, we will learn ways of imagining higher dimensional space. The end of Lecture 2. You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at RudolfSteiner.podbean.com. Please consider becoming a patron. As well, there are 2 publishing houses, SteinerBooks.org in America and RudolfSteinerPress.com in England, which are the sole publishers of Steiner into English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works, Volume 324A by Rudolf Steiner, entitled The Fourth Dimension, Sacred Geometry, Alchemy, and Mathematics, Assorted Lectures, translated by Catherine Creeger. This is Lecture 3, given in Berlin on May 17, 1905. Today I will continue with the difficult subject we have undertaken to explore. We will need to refer back to the topics I mentioned in the last 2 lectures. After that, I would like to develop a few basic concepts so that in the 2 final lectures we will be able to use Mr. Schauten's models to fully grasp both the details of the geometric relationships and Theosophy's interesting practical perspectives. As you know, the reason we tried to envision the possibility of 4-dimensional space was to gain at least some idea of the so-called astral realm and still higher forms of existence. I have already pointed out that entering the astral world is initially quite confusing for students of esotericism. Without making a closer study of theosophy and esoteric subjects, at least on a theoretical level, it is extremely difficult to form any idea of the very different nature of the objects and beings that we encounter in the so-called astral world. Let me briefly sketch this difference to show you how great it is. In the simplest example I mentioned, we have to learn to read all numbers in reverse. Esoteric students who are accustomed to reading numbers only as they are read here in the physical world, will not be able to find their way through the labyrinth of the astral realm. In the astral world, a number such as 467 must be read 764. You must become used to reading each number symmetrically as its mirror image. This is the basic prerequisite. Applying this rule to spatial figures or numbers is easy enough, but it becomes more difficult when we begin to deal with relationships in time, which must also be interpreted symmetrically. That is, later events come first and earlier events appear later. Thus, when you observe astral events, you must be able to read them backward, from the end to the beginning. I can only suggest the character of these phenomena, which can seem totally grotesque if you have no idea of what is going on. In the astral realm, the son is there first and then the father. The egg is there first and the chicken follows. In the physical world, the sequence is different. Birth happens first, and birth means that something new emerges from something old. In the astral world, the reverse takes place. There, the old emerges from the new. In the astral realm, the fatherly or motherly element appears to engulf the son or daughter. Greek mythologies provide a lovely allegory. The three gods, Uranus, Kronos, and Zeus, symbolize the three worlds. Uranus represents the heavenly world, or Devachan, Kronos the astral world, and Zeus the physical world. It is said of Kronos that he devoured his children. In the astral realm, offspring are not born but devoured. The issue becomes even more complex when we consider morality on the astral plane. Morality too appears in reverse form, or as its own mirror image. You can imagine how greatly explanations of events there differ from our habitual explanations in the physical world. Imagine, for example, that we see a wild animal approaching us in the astral realm, and it strangles us. That is how it appears to someone who is used to interpreting external events. But we cannot interpret this event as we would in the physical world. In reality, the wild animal is an internal quality. An aspect of our own astral body is strangling us. The attacking strangler is a quality that is rooted in our own desires. If we have a vengeful thought, for example, the thought may appear in external form, tormenting us as the angel of death. In reality, everything in the astral world radiates from us. We must interpret everything that seems to approach us in the astral world as radiating outward from ourselves. See Figure 18. It comes back to us on all sides, as if from the periphery, from infinite space. In truth, however, we are confronting only what our own astral body has given off. We interpret the astral world correctly and discover its truth only when we are able to bring the periphery into the center, to construe the periphery as the central element. The astral world appears to bear down on you from all sides, but you must envision it as actually radiating outward from you in all directions. At this point, I would like to make you aware of a concept that is very important in esoteric schooling. It appears ghost-like in many different works on occult research, but seldom is it understood correctly. Once you have achieved a certain level of esoteric development, you must learn what your karma predisposes you to find in the astral world. What joys, sorrows, pain, and so forth can you expect to encounter? Correct theosophical thinking allows you to realize that in this day and age, your outer life and physical body are nothing more than the result or intersection of two streams that converge from opposite directions. Picture one stream coming from the past and one coming from the future. The result is two intermingling streams that join together at all these points. See Figure 19. Imagine a red stream flowing from one direction and a blue stream flowing from the other. Now picture four different points where the streams join together. At each of these 4 points, the red and blue streams interact. This is an image of the interaction of 4 successive incarnations. In each incarnation, we encounter something coming from one direction and something coming from the other. You might say that one stream always travels toward you, and that you bring the other stream along with you. Each human being is the confluence of 2 such streams. To gain an idea of this state of affairs, imagine in this way. As you sit here today, you have a certain sum of experiences. At the same time, tomorrow, the sum of these events will be different. Now imagine that the experiences you will possess tomorrow are already there. Becoming aware of them would be like seeing a panorama of events coming toward you in space. Imagine that the stream coming toward you from the future is bringing you the experiences you will have between today and tomorrow. You are supported by the past as the future comes to meet you. At any point in time, 2 streams flow together to form your life. One stream flows from the future toward the present, and the other from the present toward the future, and an interface occurs wherever they meet. Anything that still remains for us to experience in our life appears in the form of astral phenomena, which makes a tremendous impression on us. Imagine that students of esotericism reach the point in their development when they are meant to see into the astral world. Their senses are opened, and they perceive all their future experiences until the end of this time period as outer phenomena surrounding them in the astral world. This sight makes a great impression on each student. An important level in esoteric schooling is reached when students experience an astral panorama of everything they have yet to encounter up to the middle of the 6th root race, which is how long our incarnations will last. The way is opened to them. Without exception, students of esotericism experience all the remaining outer phenomena they will encounter from the near future to the 6th root race. When you reach this threshold, a question arises. Do you want to experience all this in the shortest possible time? That is the issue for initiation candidates. As you consider this question, your entire future life appears to you in a single moment in the external panorama characteristic of astral vision. Some people will decide not to set out into the astral realm, while others will feel that they must enter. At this point in esoteric development, which is known as the threshold or moment of decision, we experience ourselves along with everything we must still live through. This phenomenon, which is known as meeting the guardian of the threshold, is nothing more than facing our own future life. Our own future lies beyond the threshold. Another unique quality of the world of astral phenomena is initially quite impenetrable if that world is revealed suddenly through one of life's unforeseen events. When this happens, there is nothing more confusing than this terrible sight. It is good to know about it in case the astral world suddenly breaks in on you as the result of a pathological event, such as the loosening of the connection between the physical body and etheric body, or between the ether body and the astral body. Such events can reveal a view of the astral world to people who are quite unprepared for it. These people then report seeing apparitions that they cannot interpret, because they do not know that they must read them in reverse. For instance, they do not know that a wild animal attacking them must be interpreted as a reflection of an internal quality. In Kamaloka, a person's astral forces and passions appear in a great variety of animal forms. In Kamaloka, recently disembodied individuals who still possess all their passions, drives, wishes, and desires are not a pretty sight. Such people, though they are no longer in possession of physical and etheric bodies, still retain all the astral elements that bind them to the physical world, and that can be satisfied only through a physical body. Think of average modern citizens who never amounted to much in their lives and made no particular effort to achieve religious development. They may not have rejected religion in theory, but in practice, that is, as far as their own feelings were concerned, they threw it out the window. It was not a vital element in their lives. What do such people's astral bodies contain? They contain nothing but urges that can be satisfied only through the physical organism, such as the desire to enjoy tasty food, for example. Satisfying this desire, however, would require taste buds. Or the individual in question may long for other pleasures that can be satisfied only by moving the physical body. Suppose that such urges persist, living on in the astral body after the physical body is gone. We find ourselves in this situation if we die without first undergoing astral cleansing and purification. We still have the urge to enjoy tasty food and so on, but such urges are impossible to satisfy. They cause terrible torment in Kamaloka, where those who die without first purifying the astral body must lay their desires aside. The astral body is freed only when it learns to relinquish the desires and wishes that can no longer be satisfied. In the astral world, urges and passions take on animal shapes. As long as a human being is incarnated in a physical body, the shape of the astral body conforms, more or less, to the human physical body. When the material body is gone, however, the animal nature of urges, desires, and passions is revealed in the forms they assume. In the astral world, therefore, an individual is a reflection of his or her urges and passions. Because these astral beings can also make use of other bodies, it is dangerous to allow mediums to go into a trance without the presence of a clairvoyant who can ward off evil. In the physical world, the form of a lion expresses certain passions, while a tiger expresses other passions, and a cat still others. It is interesting to realize that each animal form is the expression of a specific passion or urge. In the astral world, in Kamaloka, we approximate the nature of animals through our passions. This fact is the source of a common misunderstanding with regard to the doctrine of transmigration of souls taught by Egyptian and Indian priests and teachers of wisdom. This doctrine, which teaches that we should live in ways that do not cause us to incarnate as animals, does not apply to physical life, but only to higher life. It is intended only to encourage people to live their earthly lives in ways that will not require them to assume animal forms after death, in Kamaloka. For example, someone who cultivates the character of a cat during earthly life appears in the form of a cat in Kamaloka. To allow individuals to appear in human form in Kamaloka is the goal of the doctrine of transmigration of souls. Scholars who fail to understand the true teachings have only an absurd idea of this doctrine. We saw that when we enter the astral realm of numbers, time, and morality, we are dealing with a complete mirror image of everything we customarily think and do here on the physical plane. We must acquire the habit of reading in reverse, a skill we will need when we enter the astral realm. Learning to read in reverse is easiest when we take up elementary mathematical ideas, such as those suggested in the previous lecture. In the discussions that follow, we will become more and more familiar with these ideas. I would like to begin with a very simple one, namely the idea of a square. Picture a square as you are accustomed to seeing it, see figure 20. I will draw each of its four sides in a different color. This is what a square looks like in the physical world. Now I will draw a square as it looks in Devachan. It is impossible to draw this figure precisely, but I want to give you at least an idea of what a square would look like on the mental plane. The mental equivalent of a square is something approximating a cross. See figure 21. Its main features are two intersecting perpendicular axes, or, if you will, two lines that cross each other. The physical counterpart is constructed by drawing lines perpendicular to each of these axes. The physical counterpart of a mental square can best be imagined as a stoppage in two intersecting streams. Let's imagine these perpendicular axes as streams or forces working outward from their point of intersection, with counter tendencies working in from the opposite direction, from the outside inward. See Figure 22. A square arises in the physical world when we imagine that these two types of streams or forces, one coming from within and one coming from outside, meet and hold each other at bay. Boundaries develop where a stoppage occurs in the streams of force. This image describes how everything on the mental plane relates to everything on the physical plane. You can construct the mental counterpart of any physical object in the same way. This square is only the simplest possible example. If for any given physical object you could construct a correlate that relates to that object in the same way that two intersecting perpendicular lines relate to a square, the result would be the image of the physical object in Devachan on the mental level. With objects other than a square, this process is much more complicated, of course. Now, instead of the square, imagine a cube. A cube is very similar to a square. A cube is a figure bounded by 6 squares. Mr. Schouten has made an extra model showing the 6 squares that delineate a cube. Instead of the 4 boundary lines in a square, imagine 6 surfaces forming the boundaries. Imagine that the boundary of the stopped forces consists of perpendicular surfaces instead of perpendicular lines, and assume that you have 3 instead of 2 perpendicular axes. You have just defined a cube. At this point, you probably also can imagine a cube's correlate on the mental level. Again, we have 2 figures that complement each other. A cube has 3 perpendicular axes in 3 different directions to its surfaces. We must imagine that stoppage occurs in these 3 surface directions. See Figure 23. The 3 directions of the axes and the 6 surfaces, like the square's 2 axes, directions, and 4 lines, can be imagined only as opposites of a particular sort. Anyone who thinks about this subject at all must conclude that in order to imagine these figures, we must first arrive at a concept of opposites that contrast activity and counteractivity, or stoppage. This concept of opposites must enter into our considerations. The examples we used are simple, but by practicing with geometric concepts, we will learn how to construct the mental counterparts of more complicated objects properly. This activity will show us the way to higher knowledge, to a certain extent. You already can imagine the monumental complexity of trying to find the mental counterpart of some other figures. Far greater complications emerge. Just imagine thinking about a human form and its mental counterpart, with all its different shapes and activity. You can conceive what a complicated mental structure this would be. My book, titled Theosophy, gives approximations of how mental counterparts would look. In the case of a cube, we have 3 extensions, or 3 axes. 2 planes, one on each side, are perpendicular to each axis. At this point, you need to understand clearly that each surface of a cube, like the human life I described earlier, comes about as the meeting of 2 streams. You can picture streams moving outward from the midpoint. Imagine one of these axial directions. Space streams outward from the midpoint in one direction and toward the midpoint from the other direction, from infinity. Now envision these streams in 2 different colors, one red and one blue. At the moment of their meeting, they flow together to create a surface. Thus we can see the surface of a cube as the meeting of 2 opposing streams in a surface. This visualization gives us a living idea of the nature of a cube. A cube is a section of three interacting streams. When you think of the totality of their interaction, you are dealing with 6 directions rather than 3: backward, forward, up, down, and right, left. There are actually 6 directions. The issue is complicated further by the existence of 2 types of streams, one moving outward from a point and another moving inward from infinity. This will give you a perspective on the practical applications of higher theoretical theosophy. Any direction in space must be interpreted as 2 opposing streams, and any physical shape must be imagined as their result. Let's call these 6 streams or directions A, B, C, D, E, and F. If you could visualize these 6 directions, and next time we will talk about how to cultivate such mental images, and then eliminate the first and last, A and F, 4 would remain. Please note that these remaining 4 are the ones you can perceive when you see only the astral world. I have attempted to provide you with some idea of the 3 ordinary dimensions and of 3 additional and opposite dimensions. Physical forms arise as a result of the opposing action of these dimensions. If you remove one dimension on the physical level and one on the mental level, however, you are left with the 4 dimensions that represent the astral world, which exists between the physical and mental worlds. The theosophical worldview must work with a higher geometry that transcends ordinary geometry. Ordinary geometrists describe a cube as delineated by 6 squares. We must conceive of a cube as the result of 6 interpenetrating streams, that is, as the result of a movement and its opposite, or as the consequence of interacting opposing forces. I would still like to give you an example from the natural world of a concept that embodies such a pair of opposites and shows us one of the profound mysteries of the world's evolution. In his title, The Green Snake and the Beautiful Lily, Goethe speaks of the, quote, revealed mystery, close quote, one of the truest and wisest phrases ever formulated. Nature does indeed contain unseen but quite tangible mysteries, including many inversion processes. Let me describe one of them. Let's compare a human being to a plant. This is not a game, though it looks like one. It points to a profound mystery. Which part of the plant is in the ground? It is the root. Up top, the plant develops stems, leaves, flowers, and fruit. The plant's head, its root, is in the ground, and its organs of reproduction develop above ground, closer to the sun. This can be called the chaste method of reproduction. Picture the whole plant inverted, with its root becoming the human head. There you have the human being, with the head above and the reproductive organs below, as the inverse of a plant. The animal occupies the middle and represents an interface. The result of inverting a plant is a human being. Esotericists throughout the ages have used 3 lines to symbolize this phenomenon. See Figure 24. One line symbolizes the plant, another represents the human being, and a third opposing line corresponds to the animal. 3 lines that together form a cross. The animal occupies the horizontal position. That is, it crosses what we humans have in common with plants. As you know, Plato speaks of a universal soul that is crucified on the body of the earth, bound to the cross of the earth. If you envision the world soul as plant, animal, and human being, the result is the cross. Since it lives in these 3 kingdoms, the world soul is bound to the cross they form. Here you find an extension of the concept of interfaced forces. The plant and the human being represent 2 complementary and divergent but intersecting streams, while the animal, which actually interjects itself into an upward and a downward stream, represents the interface that arises between them. Similarly, Kamaloka, or the astral sphere, stands between Devachan and the physical world. Between these two worlds, whose relationship is that of mirror images, an interface arises, the world of Kamaloka, whose outer expression is the animal kingdom. Strength is required to perceive this world, but those who already have the appropriate organs of perception will recognize what we see in the interrelationship of these three kingdoms. If you interpret the animal kingdom as emerging from an interface, you will discover the relationship between the plant and animal kingdoms and the animal and human kingdoms. The animal stands perpendicular to the direction of the two other kingdoms, which are complementary interpenetrating streams. Each lower kingdom serves the next higher one as food. This fact sheds light on the difference between the human-plant relationship and the animal-human relationship. Human beings who eat animals develop a relationship to a condition of interfacing. The real activity consists in the meeting of opposing streams. In making this statement, I am initiating a train of thought that will reappear later in a strange and very different guise. In summary, we have seen that a square comes about when two axes are cut by lines. A cube comes about when three axes are cut by surfaces. Can you imagine four axes being cut by something? The cube is the boundary of the spatial figure that comes about when four axes are cut. A square forms the boundary of a three-dimensional cube. Next time, we will see what figure results when a cube forms the boundary of a four-dimensional figure. That's the end of the lecture. Here are some short questions and answers. Question: what does it mean to imagine 6 streams and then eliminate 2, and so on? Steiner's answer: the 6 streams must be imagined as 2 times 3. 3 of them work from the center outward in the directions defined by the 3 axes, and the other 3 work in the opposite direction, coming from infinity. Thus, for each axial direction, there are 2 types, one going outward from the interior and the other moving inward from outside. If we call these 2 types positive and negative, plus and minus, the result is this. And there's 2 columns. On the left is plus A, plus B, plus C going down. On the right is minus A, minus B, minus C going down. To enter the astral realm, we must eliminate one entire direction of inward and outward streams, plus A and minus A, for example. That's the end of the questions and answers, the end of Lecture 3. You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at RudolfSteiner.podbean.com. Please consider becoming a patron. As well, there are 2 publishing houses, SteinerBooks.org in America and RudolfSteinerPress.com in England, which are the sole publishers of Steiner into English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works, Volume 324A by Rudolf Steiner, entitled The Fourth Dimension, translated by Catherine Creeger. This is Lecture 4, given in Berlin on May 24th, 1905. In a recent lecture, I attempted to develop a schematic idea of 4-dimensional space, which would be very difficult to do without using an analogy of sorts. The problem that confronts us is how to indicate a 4-dimensional figure here in 3-dimensional space, which is the only type of space initially accessible to us. To link the unfamiliar element of 4-dimensional space to something we know about, we must find ways to bring a 4-dimensional object into 3 dimensions, just as we brought a 3-dimensional object into 2 dimensions. I would like to use the method popularized by Mr. Hinton to demonstrate a solution to the problem of how to represent 4-dimensional space in 3 dimensions. Let me begin by showing how 3-dimensional space can be depicted in 2 dimensions. Our chalkboard here is a 2-dimensional surface. Adding depth to its dimensions of height and width would give us a 3-dimensional space. Now let's attempt to depict a three-dimensional figure here on the chalkboard. A cube is a three-dimensional figure because it has height, width, and depth. Let's try to bring a cube into two-dimensional space, that is, onto a plane. We can take a cube and unfold it so that its 6 square sides are spread out in a plane. See figure 25. In 2 dimensions, therefore, the surfaces defining a cube can be imagined as forming a cross. These 6 squares form a cube again when I fold them up so that squares 1 and 3 are opposite each other. Squares 2 and 4 are also opposite each other, as are 5 and 6. This is a simple way of transferring a three-dimensional figure to a plane. We cannot use this method directly when we want to draw the 4th dimension in three-dimensional space. For that we need a different analogy. We will need to use colors. I will color the edges of the 6 squares differently, so that opposite sets of squares are of the same colors. For squares 1 and 3, I will make one pair of edges red, dotted lines, and another blue, solid lines. I also will color all the horizontal edges of the other squares blue and all the verticals red. See figure 26. Look at these 2 squares, 1 and 3. Their 2 dimensions are represented by 2 colors, red and blue. For us, then, on the vertical board, where square 2 is flat against the board, red means height and blue means depth. Having consistently used red for height and blue for depth, let's add green dashed lines for width, the 3rd dimension, and complete our unfolded cube. Square 5 has blue and green sides, so square 6 must look the same. Now only squares 2 and 4 are left. When you imagine them unfolded, you find that their sides are red and green. Having visualized these colored edges, you realize that we have transformed the 3 dimensions into 3 colors. Instead of height, width, and depth, we now call them red dotted, green dashed, and blue solid. These 3 colors replace and represent the 3 dimensions of space. Now imagine the whole cube folded up again. You can explain the addition of the 3rd dimension by saying that the blue and red square has moved through green, that is, from left to right in figure 26. Moving through green, or disappearing into the dimension of the 3rd color, represents the transition through the 3rd dimension. Imagine that a green fog tints the red and blue squares, so that both edges, red and blue, appear colored. The blue edge becomes blue-green, and the red acquires a murky tint. Both edges reappear in their own color, only where the green stops. I could do the same thing with squares 2 and 4, by allowing a red and green square to move through a blue space. You could do the same with the 2 blue and green squares 5 and 6, moving one of them through red. In each case, the square disappears on one side, submerging into a different color that tints it until it emerges on the other side in its original coloration. Thus, the 3 colors positioned at right angles to each other are a symbolic representation of our cube. We simply have used colors for the 3 directions. To visualize the changes the cube's 3 pairs of surfaces undergo, we imagine them passing through green, red, and blue respectively. Instead of these colored lines, imagine squares, and instead of empty space, picture squares everywhere. Then I can draw the entire figure in a still different way, figure 27. The square through which the others pass is colored blue, and the 2 that pass through it, before and after they make the transition, are drawn flanking it. Here they are in red and green. In a second step, the blue and green squares pass through the red square, and in a third step, the 2 red and blue squares pass through the green. Here you see a different way of flattening out a cube. Of the 9 squares arranged here, only 6, the upper and lower rows, form the boundaries of the cube itself. Again, see figure 27. The other 3 squares in the middle row represent transitions. They simply signify that the other 2 colors disappear into a third. Thus, with regard to the movement of transition, we must always take 2 dimensions at once, because each of these squares in the upper and lower rows is made up of 2 colors and disappears into the color that does not contain it. We make these squares disappear into the third color in order to reappear on the other side. The red and blue squares pass through the green. The red and green squares have no blue sides, so they disappear into blue, while the green and blue squares pass through red. As you can see, we can thus construct our cube out of 2-dimensional, that is, bi-colored, squares that pass through a third dimension or color. The next obvious step is to imagine cubes in the place of squares, and to visualize these cubes as being composed of squares of 3 colors, dimensions, just as we constructed our squares out of lines of 2 colors. The 3 colors correspond to the 3 dimensions of space. If we want to proceed just as we did with the squares, we must add a 4th color, so that we can make each cube disappear through the color it lacks. We simply have 4 differently colored transition cubes, blue, white, green, and red, instead of 3 transition squares. Instead of squares passing through squares, we now have cubes passing through cubes. Mr. Schoutten's models use such colored cubes. Just as we made one square pass through a second square, we must now make one cube pass through a second cube of the remaining color. Thus the white, red, and green cube passes through a blue one. On one side it submerges in the 4th color. On the other side it reappears in its original color. See figure 28.1. Thus we have here one color or dimension that is bounded by 2 cubes whose surfaces are 3 different colors. Similarly, we must now make the green, blue, and red cube pass through the white cube, figure 28.2. The blue, red, and white cube passes through the green one, figure 28.3, and in the last figure, figure 28.4, the blue, green, and white cube has to pass through a red dimension. That is, each cube must disappear into the color it lacks and reappear on the other side in its original colors. These 4 cubes relate to each other in the same way as the 3 squares in our previous example. We needed 6 squares to delineate the boundaries of a cube. Similarly, we need 8 cubes to form the boundaries of the analogous 4-dimensional figure, the tesseract. In the case of a cube, we needed 3 accessory squares that simply signified disappearance through the remaining dimension. A tesseract requires a total of 12 cubes, which relate to one another in the same way as the 9 squares in a plane. We have now done to a cube what we did with squares in the earlier example. Each time we chose a new color, we added a new dimension. We used colors to represent the 4 directions incorporated by a 4-dimensional figure. Each of the cubes in this figure has 3 colors and passes through a 4th. The point in replacing dimensions with colors is that 3 dimensions as such cannot be incorporated into a 2-dimensional plane. Using 3 colors makes this possible. We do the same thing with 4 dimensions when we use 4 colors to create an image in 3-dimensional space. This is one way of introducing this otherwise complicated subject. Hinton used this method to solve the problem of how to represent 4-dimensional figures in 3 dimensions. Next, I would like to unfold the cube again and lay it down in the plane. I'll draw it on the board. For the moment, disregard the bottom square in figure 25 and imagine that you can see in 2 dimensions only. That is, you can see only what you can encounter on the surface of the board. In this instance, we have placed 5 cubes so that 1 square is in the middle. The interior area remains invisible, figure 29. You can go all the way around the outside, but since you can see only in 2 dimensions, you will never see square 5. Now, instead of taking 5 of the 6 square sides of a cube, let's do the same thing with 7 of the 8 cubes that form the boundaries of a tesseract, spreading our 4-dimensional figure out in space. The placement of the 7 cubes is analogous to that of the cube's surfaces, laid down in a plane on the board, but now we have cubes instead of squares. The resulting 3-dimensional figure is analogous in structure to the 2-dimensional cross made of squares, and is its equivalent in 3-dimensional space. The 7th cube, like one of the squares, is invisible from all sides. It cannot be seen by any being capable only of 3-dimensional sight, see figure 30. If we could fold up this figure, as we can do with the 6 unfolded squares in a cube, we could move from the 3rd into the 4th dimension. Transitions indicated by colors show us how this process can be visualized. We have demonstrated at least how we humans can visualize 4-dimensional space in spite of being able to perceive only 3 dimensions. At this point, since you also may wonder how we can gain an idea of real 4-dimensional space, I would like to make you aware of the so-called alchemical mystery, because a true view of 4-dimensional space is related to what the alchemists call transformation. Bracket first text variant, close bracket. If you want to acquire a true view of 4-dimensional space, we must do very specific exercises. First, we must cultivate a very clear and profound vision, not a mental image, of what we call water. Such vision is difficult to achieve and requires lengthy meditation. We must immerse ourselves in the nature of water with great precision. We must creep inside the nature of water, so to speak. As a second exercise, we must create a vision of the nature of light. Although light is familiar to us, we know it only in the form in which we receive it from outside. By meditating, we acquire the inner counterpart of outer light. We know where and how light arises. We ourselves become able to produce something like light. Through meditation, yogis or students of esotericism acquire the ability to produce light. When we truly meditate on pure concepts, when we allow these concepts to work on our souls during meditation or sense-free thinking, light arises out of the concepts. Our entire surroundings are revealed to us as streaming light. Esoteric students must, quote, chemically combine, close quote, the vision of water that they have cultivated with their vision of light. Water fully imbued with light is what the alchemists called mercury. In the language of alchemy, water plus light equals mercury. In the alchemical tradition, however, mercury is not simply ordinary quicksilver. After we awaken our own ability to create light out of our own work with pure concepts, mercury comes about as the mingling of this light with our vision of water. We take possession of this light-imbued power of water, which is one of the elements of the astral world. The second element arises when we cultivate a vision of air, just as we previously cultivated a vision of water. Through a spiritual process, we extract the power of air. Then, by concentrating the power of feeling in certain ways, feeling kindles fire. When you chemically combine, as it were, the power of air with the fire kindled by feeling, the result is, in quotes, fire air. As you may know, this fire-air is mentioned in Goethe's title Faust. It requires the inner participation of the human being. One component is extracted from an existing element, the air, while we ourselves produce the other, fire or warmth. Air plus fire yields what the alchemists called sulfur, or shining fire-air. The presence of this fire-air in a watery element is truly what is meant when the Bible says, quote, "And the Spirit of God brooded upon the face of the waters." Close quote. The third element comes about when we extract the power of the earth and combine it with the spiritual forces in sound. The result is what is called the Spirit of God. It also is called thunder. The active Spirit of God is thunder, earth plus sound. Thus the Spirit of God hovered over astral substance. The biblical, in quotes, waters are not ordinary water, but what we know as astral substance, which consists of 4 types of forces: water, air, light, and fire. The sequence of these 4 forces is revealed to astral vision as the 4 dimensions of astral space. That is what they really are. Astral space looks very different from our world. Many supposedly astral phenomena are simply projections of aspects of the astral world into physical space. As you can see, astral substance is half subjective, that is, passively given to the subject, and half water and air. Light and feeling, fire, on the other hand, are objective, that is, made to appear by the activity of the subject. Only one part of astral substance can be found outside, given to the subject in the environment. The other part must be added by subjective means, through personal activity. Conceptual and emotional forces allow us to extract the other aspect from what is given through active objectification. In the astral realm, therefore, we find subjective-objective substance. In Devachan, we would find only a completely subjective element. There is no longer any objectivity at all that is simply given to the subject. In the astral realm, therefore, we find an element that must be created by human beings. Everything we do here is simply a symbolic representation of the higher worlds, or Devachan. These worlds are real, as I have explained to you in these lectures. What lies within these higher worlds can be attained only by developing new possibilities for vision. Human beings must be active in order to reach these worlds. Bracket, second text variant. It says here, Vegelhan, in parentheses, and then close bracket. If we want to acquire a true view of 4-dimensional space, we must do very specific exercises. First, we must cultivate a clear and profound vision of water. Such vision cannot be achieved as a matter of course. We must immerse ourselves in the nature of water with great precision. We must creep inside water, so to speak. Second, we must create a vision of the nature of light. Although light is familiar to us, we know it only in the form in which we receive it from outside. By meditating, we acquire the inner counterpart of outer light. We learn where light comes from. So we ourselves become able to produce light. We can do this by truly allowing these concepts to work on our souls during meditation or sense-free thinking. Our entire surroundings are revealed to us as streaming light. Then we must, in quotes, chemically combine the mental image of water that we have cultivated with that of light. Water fully imbued with light is what the alchemists called mercury. In the language of alchemy, water plus light equals mercury. This alchemical mercury, however, is not simply ordinary quicksilver. We must first awaken our own ability to create mercury out of the concept of light. We then take possession of Mercury, the light-imbued power of water, which is one element of the astral world. The second element arises when we cultivate a vivid mental image of air, and then extract the power of air through a spiritual process, combining it with feeling inside us to kindle the concept of warmth or fire. One element is extracted, while we ourselves produce the other. These two, air plus fire, yield what the alchemists called sulfur, or shining fire air. The watery element is truly the substance referred to in the biblical statement, quote, "The Spirit of God brooded upon the face of the waters," close quote. The third element is, in quotes, spirit God, or earth combined with sound. It comes about when we extract the power of the earth and combine it with sound. The biblical, in quotes, waters are not ordinary water, but what we know as astral substance, which consists of 4 types of forces: water, air, light, and fire. These 4 forces constitute the 4 dimensions of astral space. As you can see, astral substance is half subjective. Only one part of astral substance can be acquired from the environment. The other part is acquired through objectification from conceptual and emotional forces. In Devachan, we would find only a completely subjective element. There is no objectivity there. Everything we do here is simply a symbolic representation of the world of Devachan. What lies within the higher worlds can be reached only by developing in ourselves new ways of perceiving. Human beings must be active in order to reach these worlds. The end of Lecture 4. You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at RudolfSteiner.podbean.com. Please consider becoming a patron. As well, there are 2 publishing houses, SteinerBooks.org in America and RudolfSteinerPress.com in England, which are the sole publishers of Steiner into English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works Volume 324A by Rudolf Steiner, entitled The Fourth Dimension, translated by Catherine Creeger. This is Lecture 5, given in Berlin on May 31st, 1905. Last time we attempted to visualize a 4-dimensional spatial figure by reducing it to 3 dimensions. First, we converted a 3-dimensional figure into a 2-dimensional one. We substituted colors for dimensions, constructing our image using 3 colors to represent the 3 dimensions of a cube. Then we unfolded the cube so that all of its surfaces lay in a plane, resulting in 6 squares whose differently colored edges represented the 3 dimensions in 2-dimensional space. We then envisioned transferring each square of the cube's surface into the 3rd dimension as moving the square through a colored fog and allowing it to reappear on the other side. We imagined all the surface squares moving through and being tinted by transition squares. Thus we used colors to attempt to picture a 3-dimensional cube in 2 dimensions. To represent squares in 1 dimension, we used 2 different colors for their edge pairs. To represent a cube in 2 dimensions, we used 3 colors. Depicting a 4-dimensional figure in 3-dimensional space required a 4th color. Then we imagined a cube with 3 different surface colors as analogous to our square with 2 different edge colors. Each such cube moved through a cube of the 4th color. That is, it disappeared into the 4th dimension or color. In accordance with Hinton's analogy, we made each boundary cube move through the new 4th color and reappear on the other side in its own original color. Now, I would like to give you another analogy. We will begin once again by reducing 3 dimensions to 2 in preparation for reducing 4 dimensions to 3. We must envision constructing our cube out of its 6 square sides, but instead of leaving all 6 squares attached when we spread them out, we will arrange them differently, as shown here, see figure 31. As you see, we have split the cube into 2 groups of 3 squares each. Both groups lie in the same plane. We must understand the location of each group when we reassemble the cube. To complete the cube, I must place one group above the other, so that square 6 lies over square 5. Once square 5 is in position, I must fold squares 1 and 2 upward, while squares 3 and 4 must be folded downward, see figure 32. The corresponding pairs of line segments, that is, the ones of the same color, here with the same number and weight of slashes as shown in figure 31, will then coincide. These lines that are spread out in 2-dimensional space coincide when we make the transition to 3-dimensional space. A square consists of 4 edges, a cube of 6 squares, and a 4-dimensional figure of 8 cubes. Hinton calls this 4-dimensional figure a tesseract. Our task is not simply to put these 8 cubes together into a single cube, but to do so by making each one pass through the 4th dimension. When I do to a tesseract what I just did to a cube, I must observe the same law. We must use the analogy of the relationship of a 3-dimensional figure to its 2-dimensional counterpart to discover the relationship of a 4-dimensional figure to its 3-dimensional counterpart. In the case of an unfolded cube, I have 2 groups of 3 squares. Similarly, unfolding a 4-dimensional tesseract in 3-dimensional space results in 2 groups of 4 cubes, which look like this, see figure 33. This 8-cube method is very ingenious. We must handle these 4 cubes in 3-dimensional space exactly as we handled the squares in 2-dimensional space. Look closely at what I have done here. Unfolding a cube so that it lies flat in 2-dimensional space results in a grouping of 6 squares. Performing the corresponding operation on a tesseract results in a system of 8 cubes, see figure 34. We have transferred our reflections on 3-dimensional space to 4-dimensional space. Folding up the squares and making their edges coincide in 3-dimensional space corresponds to folding up the cubes and making their surfaces coincide in 4-dimensional space. Laying the cube flat in 2-dimensional space resulted in corresponding lines that coincided when we reconstructed the cube. Something similar happens to the surfaces of individual cubes in the tesseract. Laying out a tesseract in 3-dimensional space results in corresponding surfaces that will later coincide. Thus, in a tesseract, the upper horizontal surface of a cube 1 lies in the same plane as the front surface of cube 5 when we move into the 4th dimension. Similarly, the right surface of cube 1 coincides with the front surface of cube 4. The left square in cube 1 coincides with the front square in cube 3. And the lower square in cube 1 coincides with the front square in cube 6. Similar correspondences exist between the remaining surfaces. When the operation is completed, the cube that remains is cube 7, the interior cube that was surrounded by the other 6. As you see, we are concerned once more with finding analogies between the 3rd and 4th dimensions. As we saw in one of the illustrations from the last lecture, see figure 49, just as a 5th square, surrounded by 4 others, remains invisible to any being who can see only in 2 dimensions, the same applies to the 7th cube in this instance. It remains hidden from 3-dimensional vision. In a tesseract, this 7th cube corresponds to an 8th cube, its counterpart in the 4th dimension. All of these analogies serve to prepare us for the 4th dimension, since nothing in our ordinary view of space forces us to add other dimensions to the three familiar ones. Following Hinton's example, we might also use colors here and think of cubes put together so that the corresponding colors coincide. Other than through such analogies, it is almost impossible to give any guidance in how to conceive of a four-dimensional figure. I would now like to talk about another way of representing four-dimensional bodies in three-dimensional space that may make it easier for you to understand what is actually at issue. Here we have an octahedron, which has 8 triangular surfaces that meet in obtuse angles, see figure 35. Please imagine this figure, and then follow this train of thought with me. You see, these edges are where two surfaces intersect. Two intersect at AB, for example, and two at EB. The only difference between an octahedron and a cube is the angle at which the surfaces intersect. Whenever surfaces intersect at right angles, as they do in a cube, the figure that is formed must be a cube. But when they intersect at an obtuse angle, as they do here, an octahedron is formed. By making the surfaces intersect at different angles, we construct different geometric figures. Next, envision a different way of making the surfaces of an octahedron intersect. Picture that one of these surfaces here, such as AEB, is extended on all sides, and that the lower surface, BCF, and the surfaces ADF and EDC at the back of the figure are similarly extended. These extended surfaces must also intersect. There is a twofold symmetry at this line of reflection, also called, quote, half-turn symmetry, close quote. When these surfaces are extended, the other four original surfaces of the octahedron, ABF, EBC, EAD, and DCF, are eliminated. Out of 8 original surfaces, 4 remain, and these 4 form a tetrahedron, which also can be called half an octahedron because it causes half of the surfaces of the octahedron to intersect. It is not half an octahedron in the sense of cutting the octahedron in half in the middle. When the other 4 surfaces of the octahedron are extended until they intersect, they also form a tetrahedron. The original octahedron is the intersection of these 2 tetrahedrons. In stereometry, or geometric crystallography, what is called half a figure is the result of having the number of surfaces rather than of dividing the original figure in 2. This is very easy to visualize in the case of an octahedron. If you imagine a cube halved in the same way, by making one surface intersect with another surface, you will always get a cube. Half of a cube is always another cube. There is an important conclusion to be drawn from this phenomenon, but first I would like to use another example. Here we have a rhombic dodecahedron, figure 37. As you see, its surfaces meet at specific angles. Here we also have a system of 4 wires, I will call them axial wires, that run in different directions. That is, they are diagonals connecting specific opposite corners of the rhombic dodecahedron. These wires represent the system of axes in the rhombic dodecahedron, similar to the system of axes you can imagine in a cube. In a system of 3 perpendicular axes, a cube results when stoppage occurs in each of these axes, producing intersecting surfaces. Causing the axes to intersect at different angles results in different geometric solids. The axes of a rhombic dodecahedron, for example, intersect at angles that are not right angles. Having a cube results in a cube. This is true only of a cube. When the number of surfaces in a rhombic dodecahedron is halved, a totally different geometrical figure results. Now let's consider how an octahedron relates to a tetrahedron. Let me show you what I mean. The relationship is clearly apparent if we gradually transform a tetrahedron into an octahedron. For this purpose, let's take a tetrahedron and cut off its vertices, as shown here, see figure 38. We continue to cut off larger portions until the cut surfaces meet on the edges of the tetrahedron. The form that remains is an octahedron. By cutting off the vertices at the appropriate angle, we have transformed a spatial figure, bounded by 4 planes, into an 8-sided figure. What I have just done to a tetrahedron cannot be done to a cube. A cube is unique in that it is the counterpart of 3-dimensional space. Imagine that all the space in the universe is structured by 3 axes that are perpendicular to each other. Inserting planes perpendicular to these 3 axes always produces a cube, see figure 39. Thus, whenever we use the term cube to mean a theoretical cube rather than a specific one, we are talking about the cube as the counterpart of 3-dimensional space. Just as the tetrahedron can be shown to be the counterpart of an octahedron by extending half of the octahedron's sides until they intersect, an individual cube is also the counterpart of all of space. If you imagine all of space as positive, the cube is negative. The cube is the polar opposite of space in its entirety. The physical cube is the geometric figure that actually corresponds to all of space. Suppose that instead of a 3-dimensional space, bounded by 2-dimensional planes, we have a space bounded by 6 spheres, which are 3-dimensional figures. I start by defining a 2-dimensional space with 4 intersecting circles, that is, 2-dimensional figures. Now imagine these circles growing bigger and bigger. That is, the radius grows ever longer, and the midpoint becomes increasingly distant. With time, the circles will be transformed into straight lines. See figure 40. Then, instead of 4 circles, we have 4 intersecting straight lines and a square. Now, instead of circles, imagine 6 spheres, forming a mulberry-like shape, figure 41. Picture the spheres growing ever larger, just as the circles did. Ultimately, these spheres will become the planes defining a cube, just as the circles became the lines defining a square. This cube is the result of 6 spheres that have become flat. The cube, therefore, is only a special instance of the intersection of 6 spheres, just as the square is simply a special instance of 4 intersecting circles. When you clearly realize that these 6 spheres flattening into planes correspond to the squares we used earlier to define a cube, that is, when you visualize a spherical figure being transformed into a flat one, the result is the simplest possible 3-dimensional figure. A cube can be imagined as the result of flattened 6 intersecting spheres. We can say that a point on a circle must pass through the 2nd dimension to get to another point on the circle. But if the circle has become so large that it forms a straight line, any point on the circle can get to any other point by moving only through the 1st dimension. Let's consider a square that is bounded by 2-dimensional figures. As long as the 4 figures defining a square are circles, they are 2-dimensional. Once they become straight lines, however, they are 1-dimensional. The planes defining a cube develop out of 3-dimensional figures, spheres, when 1 dimension is removed from each of the 6 spheres. These defining surfaces come about by being bent straight, through reducing their dimensions from 3 to 2. They have sacrificed a dimension. They enter the 2nd dimension by sacrificing the dimension of depth. Thus we could say that each dimension of space comes about by sacrificing the next higher dimension. If we have a 3-dimensional form with 2-dimensional boundaries, and so reduce 3-dimensional forms to 2 dimensions, You must conclude from this that if we consider three-dimensional space, we have to think of each direction as the flattened version of an infinite circle. Then if we move in one direction, we would ultimately return to the same point from the opposite direction. Thus each ordinary dimension of space has come about through the loss of the next higher dimension. A triaxial system is inherent in our three-dimensional space. Each of its three perpendicular axes has sacrificed the next dimension to become straight. In this way we achieve three-dimensional space by straightening each of its three axial directions. Reversing the process, each element of space also could be curved again, resulting in this train of thought. When you curve a one-dimensional figure, the resulting figure is two-dimensional. A curved two-dimensional figure becomes three-dimensional. And finally, curving a three-dimensional figure produces a four-dimensional figure. Thus, four-dimensional space can be imagined as curved three-dimensional space. At this point, we can make the transition from the dead to the living. In this bending, you can find spatial figures that reveal this transition from death to life. At the transition to three-dimensionality, we find a special instance of four-dimensional space. It has become flat. To human consciousness, death is nothing more than bending three dimensions into four dimensions. With regard to the physical body taken by itself, the opposite is true. Death is the flattening of four dimensions into three. That is the end of Lecture 5. You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at RudolfSteiner.podbean.com. Please consider becoming a patron. As well, there are two publishing houses, SteinerBooks.org in America and RudolfSteinerPress.com in England, which are the sole publishers of Steiner into English, and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works, Volume 324A by Rudolf Steiner, entitled The Fourth Dimension, translated by Catherine Creeger. This is Lecture 6, given in Berlin on June 7th, 1905. Today I must conclude these lectures on the fourth dimension of space, though I actually would like to present a complicated system in greater detail, which would require demonstrating many more of Hinton's models. All I can do is refer you to his 3 thorough and insightful books. Of course, no one who is unwilling to use analogies, such as those presented in the previous lectures, will be able to acquire a mental image of four-dimensional space. A new way of developing thoughts is needed. Now, I would like to develop a real image, parallel projection, of a tesseract. We saw that a square in two-dimensional space has 4 edges. Its counterpart in 3 dimensions is the cube, which has 6 square sides. See Figure 42. The 4-dimensional counterpart is the tesseract, which is bounded by 8 cubes. Consequently, the projection of a tesseract into 3-dimensional space consists of 8 interpenetrating cubes. We saw how these 8 cubes can coincide in 3-dimensional space. I will now construct a different projection of a tesseract. Imagine holding a cube up to the light so that it casts a shadow on the board. We can then trace the shadow with chalk. See Figure 43. As you see, the result is a hexagon. If you imagine the cube as transparent, you can see that in its projection onto a plane, the 3 front faces coincide with the 3 rear faces to form the hexagonal figure. To get a projection that we can apply to a tesseract, please imagine that the cube in front of you is positioned so that the front point A exactly covers the rear point C. If you then eliminate the 3rd dimension, the result is once again a hexagonal shadow. Let me draw this for you. See Figure 44. When you imagine the cube in this position, you see only its 3 front faces. The three other faces are concealed behind them. The faces of the cube appear foreshortened, and its angles no longer look like right angles. Seen from this perspective, the cube looks like a regular hexagon. Thus we have created an image of a three-dimensional cube in two-dimensional space. Because this projection shortens the edges and alters the angles, we must imagine the 6 square faces of the cube as rhombuses. Now, let's repeat the operation of projecting a three-dimensional cube onto a plane with a four-dimensional figure that we project into three-dimensional space. We will use parallel projection to depict a tesseract, a figure composed of 8 cubes in the third dimension. Performing this operation on a cube results in 3 visible and 3 invisible edges. In reality, they jut into space and do not lie flat in the plane of projection. Now imagine a cube distorted into a rhombic parallelepiped. If you take 8 such figures, you can assemble the structures defining a tesseract so that they interpenetrate and doubly coincide with the rhombic cubes in a rhombic dodecahedron. See Figure 45. This figure has one more axis than a three-dimensional cube. Naturally, a four-dimensional figure has 4 axes. Even when its components interpenetrate, 4 axes remain. Thus, this projection contains 8 interpenetrating cubes, shown as rhombic cubes. A rhombic dodecahedron is a symmetrical image or shadow of a tesseract projected into three-dimensional space. Although we have arrived at these relationships by analogy, the analogy is totally valid. Just as a cube can be projected onto a plane, a tesseract also can be depicted by projecting it into three-dimensional space. The resulting projection is to the tesseract as the cube's shadow is to the cube. I believe this operation is readily understandable. I would like to link what we have just done to the wonderful image supplied by Plato and Schopenhauer in the metaphor of the cave. Plato asks us to imagine people chained in a cave so that they cannot turn their heads and can see only the rear wall. Behind them, other people carry various objects past the mouth of the cave. These people and objects are three-dimensional, but the prisoners see only shadows cast on the wall. Everything in this room, for example, would appear only as two-dimensional shadow images on the opposite wall. Then Plato tells us that our situation in the world is similar. We are the people chained in the cave. Although we ourselves are four-dimensional, as is everything else, all that we see appears only in the form of images in three-dimensional space. According to Plato, we are dependent on seeing only the three-dimensional shadow images of things instead of their realities. I see my own hand only as a shadow image. In reality, it is four-dimensional. We see only images of four-dimensional reality, images like that of the tesseract that I showed you. In ancient Greece, Plato attempted to explain that the bodies we know are actually four-dimensional, and that we see only their shadow images in three-dimensional space. The statement is not completely arbitrary, as I will explain shortly. Initially, of course, we can say that it is mere speculation. How can we possibly imagine that there is any reality to these figures that appear on the wall? But now, imagine yourself sitting here in a row, unable to move. Suddenly the shadows begin moving. You cannot possibly conclude that the images on the wall could move without leaving the second dimension. When an image moves on the wall, something must have caused movement of the actual object, which is not on the wall. Objects in three-dimensional space can move past each other, something their two-dimensional shadow images cannot do if you imagine them as impenetrable, that is, as consisting of substance. If we imagine these images to be substantial, they cannot move past each other without leaving the second dimension. As long as the images on the wall remain motionless, I have no reason to conclude that anything is happening away from the wall, outside the realm of two-dimensional shadow images. As soon as they begin to move, however, I am forced to investigate the source of the movement, and to conclude that the change can originate only in a movement outside the wall, in a third dimension. Thus the change in the images has informed us that there is a third dimension in addition to the second. Although a mere image possesses a certain reality and very specific attributes, it is essentially different from the real object. A mirror image, too, is undeniably a mirror image. Readers aside, that last one is M-E-R-E. In other words, a mirror image, too, is undeniably a mirror image, M-E-R-E. End of readers aside. You see yourself in the mirror, but you are also present out here. Without the presence of a third element, that is, a being that moves, you cannot really know which one is you. The mirror image makes the same movements as the original. It has no ability to move itself, but is dependent on the real object, the being. In this way we can distinguish between an image and a being, by saying that only a being can produce change or movement out of itself. I realize that the shadow images on the wall cannot make themselves move. Therefore, they are not beings. I must transcend the images in order to discover the beings. Now apply this train of thought to the world in general. The world is three-dimensional. But if you consider it by itself, grasping it in thought, you will discover that it is essentially immobile. Even if you imagine it frozen at a certain point in time, however, the world is still three-dimensional. In reality, the world is not the same at any 2 points in time. It changes. Now imagine the absence of these different moments. What is, remains. If there were no time, the world would never change. But even without time or changes, it would still be three-dimensional. Similarly, the images on the wall remain two-dimensional, but the fact that they change suggests the existence of a third dimension. That the world is constantly changing, but would remain three-dimensional even without change, suggests that we need to look for the change in a fourth dimension. The reason for change, the cause of change, the activity of change, must be sought outside the third dimension. At this point you grasp the existence of the fourth dimension and the justification for Plato's metaphor. We can understand the entire three-dimensional world as the shadow projection of a four-dimensional world. The only question is how to grasp the reality of this fourth dimension. Of course, we must understand that it is impossible for the fourth dimension to enter the third directly. It cannot. The fourth dimension cannot simply fall into the third dimension. Now, I would like to show you how to acquire a concept of transcending the third dimension. In one of my earlier lectures here, I attempted to awaken a similar idea in you. Imagine that we have a circle. If you picture this circle getting bigger and bigger, so that any specific segment becomes flatter and flatter, the diameter eventually becomes so large that the circle is transformed into a straight line. A line has only one dimension, but a circle has two. How do we get back into 2 dimensions? By bending the straight line to form a circle again. When you imagine curving a circular surface, it first becomes a bowl, and eventually, if you continue to curve it, a sphere. A curved line acquires a second dimension, and a curved plane a third. And if you could still make a cube curve, it would have to curve into the fourth dimension, and the result would be a spherical tesseract. A spherical surface can be considered a curved two-dimensional figure. In nature, the sphere appears in the form of the cell, the smallest living being. The boundaries of a cell are spherical. Here we have the difference between the living and the lifeless. Minerals in their crystalline form are always bounded by planes, by flat surfaces, while life is built up out of cells and bounded by spherical surfaces. Just as crystals are built up out of flattened spheres or planes, life is built up out of cells or abutting spheres. The difference between the living and the lifeless lies in the character of their boundaries. An octahedron is bounded by 8 triangles. When we imagine its 8 sides as spheres, the result is an 8-celled living thing. When you, in quotes, curve a cube, which is a 3-dimensional figure, the result is a 4-dimensional figure, the spherical tesseract. But if you curve all of space, the resulting figure relates to 3-dimensional space as a sphere relates to a plane. As a 3-dimensional object, a cube, like any crystal, is bounded by planes. The essence of a crystal is that it is constructed of flat boundary planes. The essence of life is that it is constructed of curved surfaces, namely cells, while a figure on a still higher level of existence would be bounded by 4-dimensional structures. A 3-dimensional figure is bounded by 2-dimensional figures. A 4-dimensional being, that is, a living thing, is bounded by 3-dimensional beings, namely spheres and cells. A 5-dimensional being is bounded by 4-dimensional beings, namely spherical tesseracts. Thus we see the need to move from 3-dimensional beings to 4-dimensional and then 5-dimensional beings. What needs to happen with a 4-dimensional being? A change must take place within the 3rd dimension. In other words, when you hang pictures, which are 2-dimensional, on the wall, they generally remain immobile. When you see 2-dimensional images moving, you must conclude that the cause of the movement can lie only outside the surface of the wall. That is, that the 3rd dimension of space prompts the change. When you find changes taking place within the 3rd dimension, you must conclude that a 4th dimension has an effect on beings who experience changes within their 3 dimensions of space. We have not truly recognized a plant when we know it only in its 3 dimensions. Plants are constantly changing. Change is an essential aspect of plants, a token of a higher form of existence. A cube remains the same. Its form changes only when you break it. A plant changes shape by itself, which means that the change must be caused by some factor that exists outside the 3rd dimension and is expressed in the 4th dimension. What is this factor? You see, if you draw this cube at different points in time, you will find that it always remains the same. But when you draw a plant and compare the original to your copy 3 weeks later, the original will have changed. Our analogy, therefore, is fully valid. Every living thing points to a higher element in which its true being dwells, and time is the expression of this higher element. Time is the symptomatic expression or manifestation of life, or the 4th dimension, in the 3 dimensions of physical space. In other words, all beings for whom time is intrinsically meaningful are images of 4-dimensional beings. After 3 years or 6 years, this cube will still be the same. A lily seedling changes, however, because time has real meaning for it. What we see in the lily is merely the 3-dimensional image of the 4-dimensional lily being. Time is an image or projection of the 4th dimension, of organic life, into the 3 spatial dimensions of the physical world. To clarify how each successive dimension relates to the preceding one, please follow this line of thought. A cube has 3 dimensions. To imagine the 3rd, you tell yourself that it is perpendicular to the 2nd and that the 2nd is perpendicular to the 1st. It is characteristic of the 3 dimensions that they are perpendicular to each other. We also can conceive of the 3rd dimension as arising out of the next dimension, the 4th. Envision coloring the faces of a cube and manipulating the colors in a specific way, as Hinton did. The changes you induce correspond exactly to the change undergone by a three-dimensional being when it develops over time, thus passing into the fourth dimension. When you cut through a four-dimensional being at any point, that is, when you take away its fourth dimension, you destroy the being. Doing this to a plant is just like taking an impression of the plant and casting it in plaster. You hold it fast by destroying its fourth dimension, the time factor, and the result is a three-dimensional figure. When time, the fourth dimension, is critically important to any three-dimensional being, that being must be alive. And now we come to the fifth dimension. You might say that this dimension must have another boundary that is perpendicular to the fourth dimension. We saw that the relationship between the fourth dimension and the third is similar to the relationship between the third and second dimensions. It is more difficult to imagine the fifth dimension, but once again, we can use an analogy to give us some idea about it. How does any dimension come about? When you draw a line, no further dimensions emerge as long as the line simply continues in the same direction. Another dimension is added only when you imagine two opposing directions or forces that meet and neutralize at a point. The new dimension arises only as an expression of the neutralization of forces. We must be able to see the new dimension as the addition of a line in which two streams of forces are neutralized. We can imagine the dimension as coming either from the right or from the left, as positive in the first instance and negative in the second. Thus I grasp each independent dimension as a polar stream of forces with both a positive and a negative component. The neutralization of the polar component forces is the new dimension. Taking this as our starting point, let's develop a mental image of the fifth dimension. We must first imagine positive and negative aspects of the fourth dimension, which we know is the expression of time. Let's picture a collision between two beings for whom time is meaningful. The result will have to be similar to the neutralization of opposing forces that we talked about earlier. When two four-dimensional beings connect, the result is their fifth dimension. The fifth dimension is the result or consequence of an exchange or neutralization of polar forces, in that two living things who influence each other produce something that they do not have in common, either in the three ordinary dimensions of space or in the fourth dimension, in time. This new element has its boundaries outside these dimensions. It is what we called empathy or sensory activity, the capacity that informs one being about another. It is the recognition of the inner soul spiritual aspect of another being. Without the addition of the higher fifth dimension, that is, without entering the realm of sensory activity, no being would ever be able to know about any aspects of another being that lie outside time and space. Of course, in this sense, we understand sensory activity simply as the fifth dimension's projection or expression in the physical world. It would be too difficult to build up the sixth dimension in the same way, so for now I will simply tell you what it is. If we continued along the same line of thinking, we would find that the expression of the sixth dimension in the three-dimensional world is self-awareness. As three-dimensional beings, we humans share our image character with other three-dimensional beings. Plants possess an additional dimension, the fourth. For this reason, you will never discover the ultimate being of the plant in the three dimensions of space. You must ascend to a fourth dimension, to the astral sphere. If you want to understand a being that possesses sensory ability, you must ascend to the fifth dimension, lower Devachan, or the Rupa sphere, and to understand a being with self-awareness, namely the human being, you must ascend to the sixth dimension, upper Devakan, or the Arupa sphere. The human beings we encounter at present are really six-dimensional beings. What we have called sensory ability, or empathy, and self-awareness are projections of the fifth and sixth dimensions, respectively, into ordinary three-dimensional space. Albeit unconsciously for the most part, human beings extend all the way into these spiritual spheres. Only there can their essential nature be recognized. As six-dimensional beings, we understand the higher worlds only when we attempt to relinquish the characteristic attributes of lower dimensions. I cannot do more than suggest why we believe the world to be merely three-dimensional. Our view is based on seeing the world as a reflection of higher factors. The most you can see in a mirror is a mirror image of yourself. In fact, the three dimensions of our physical space are reflections, material images of three higher, causal, creative dimensions. Thus, our material world has a polar, spiritual counterpart in the group of the three next higher dimensions, that is, in the fourth, fifth, and sixth. Similarly, the fourth through sixth dimensions have their polar counterparts in still more distant spiritual worlds, in dimensions that remain a matter of conjecture for us. Consider water, and water that has been allowed to freeze. In both cases, the substance is the same, but water and ice are very different in form. You can imagine a similar process taking place with regard to the three higher human dimensions. When you imagine human beings as purely spiritual beings, you must envision them as possessing only the three higher dimensions of self-awareness, feeling, and time, and that these dimensions are reflected in the three ordinary dimensions in the physical world. When yogis, students of esotericism, want to ascend to knowledge of the higher worlds, they must gradually replace reflections with realities. For example, when they consider a plant, they must learn to replace the lower dimensions with the higher ones. Learning to disregard one of a plant's spatial dimensions and substitute the corresponding higher dimension, namely time, enables them to understand a two-dimensional being that is moving. What must students of esotericism do to make this being correspond to reality, rather than remaining a mere image? If they were simply to disregard the third dimension and add the fourth, the result would be something imaginary. The following thought will help us move toward an answer. By filming a living being, even though we subtract the third dimension from events that were originally three-dimensional, the succession of images adds the dimension of time. When we then add sensory ability to this animated image, we perform an operation similar to the one I described as curving a three-dimensional figure into the fourth dimension. The result of this operation is a four-dimensional figure, whose dimensions include two of our spatial dimensions and two higher ones, namely time and sensory ability. Such beings do indeed exist, and now that I have come to the real conclusion of our study of the dimensions, I would like to name them for you. Imagine two spatial dimensions, that is, a plane, and suppose that this plane is endowed with movement. Picture it curving to become a sensate being, pushing a two-dimensional surface in front of it. Such a being is very dissimilar to and acts very differently from a three-dimensional being in our space. The surface being that we have constructed is completely open in one direction. It looks two-dimensional, it comes toward you, and you cannot get around it. This being is a radiant being. It is nothing other than openness in a particular direction. Through such a being, initiates then become familiar with other beings whom they describe as divine messengers, approaching them in flames of fire. The description of Moses receiving the 10 Commandments on Mount Sinai shows simply that he was approached by such a being and could perceive its dimensions. This being, which resembled a human being minus the third dimension, was active in sensation and time. The abstract images in religious documents are more than mere outer symbols. They are mighty realities that we can learn about by taking possession of what we have been attempting to understand through analogies. The more diligently and energetically you ponder such analogies, the more eagerly you submerge yourself in them, the more they work on your spirit to release higher capacities. This applies, for example, to the explanation of the analogy between the relationship of a cube to a hexagon and that of a tesseract to a rhombic dodecahedron. The latter is the projection of a tesseract into the three-dimensional physical world. By visualizing these figures as if they possessed independent life, that is, by allowing a cube to grow out of its projection, the hexagon, and the tesseract to develop out of its projection, the rhombic dodecahedron, your lower mental body learns to grasp the beings I just described. When you not only have followed my suggestions, but also have made this operation come alive, as esoteric students do, in full waking consciousness, you will notice that four-dimensional figures begin to appear in your dreams. At that point, you no longer have far to go to be able to bring them into your waking consciousness. You then will be able to see the fourth dimension in every four-dimensional being. The astral sphere is the fourth dimension. Devachan up to Rupa is the fifth dimension. Devachan up to Arupa is the sixth dimension. These three worlds, physical, astral, and heavenly, Devachan, encompass 6 dimensions. The still higher worlds are the polar opposites of these dimensions. So now we have a chart. I'll give my best here. At the top of the chart are 4 columns: mineral, plant, animal, human. And on the left, we have a column that is Arupa, Rupa, astral plane, physical plane. Intersecting Arupa and mineral, self-awareness. Intersecting mineral Rupa is sensory ability. Intersecting plant and Rupa is self-awareness. Intersecting mineral with astral plane is life. Intersecting plant with astral plane is sensory ability. Intersecting animal with astral plane is self-awareness. Back to mineral, intersecting with physical plane, you get form. Plant with physical plane, you get life. Animal with physical plane, you get sensory activity. Human with physical plane, you get self-awareness. End of Lecture 6. You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at RudolfSteiner.podbean.com. Please consider becoming a patron. As well, there are 2 publishing houses, SteinerBooks.org in America and RudolfSteinerPress.com in England, which are the sole publishers of Steiner in English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works Volume 324A by Rudolf Steiner, titled The Fourth Dimension. This is now a couple of extra lectures. I'm still calling this Lecture 7. It's entitled Four-Dimensional Space, given in Berlin on November 7th, 1905. Translated by Catherine Creeger. Our ordinary space has 3 dimensions: length, width, and height. A line has only 1 dimension, length. This blackboard is a plane, that is, it has 2 dimensions, length and width. A solid object encompasses 3 dimensions. How does a 3-dimensional figure arise? Imagine a figure with no dimensionality at all, namely the point. It has 0 dimensions. When a point moves in a constant direction, a straight line or one-dimensional figure results. Now visualize the line moving. The result is a plane, which has length and width. And finally, a moving plane describes a three-dimensional figure. We cannot continue this process, however. We cannot use movement to create a four-dimensional figure or a fourth dimension from a three-dimensional object. How can we use images to develop a concept of the fourth dimension? Some mathematicians and scientists, Zöllner, for example, have felt tempted to bring the spiritual world into harmony with our sense-perceptible world by assuming that the spiritual world exists in four-dimensional space. Imagine a circle, a completely closed figure lying in a plane. Suppose that someone asks us to move a coin into the circle from outside. We must either cross the circumference of the circle, see figure 46, or if we are not allowed to touch the circumference, pick up the coin, lift it into space, and place it inside the circle, which requires leaving the second dimension and entering the third. To move a coin magically into a cube or a sphere, we must leave the third dimension and pass through the fourth. In this lifetime, I first began to grasp the nature of space when I began to study modern synthetic projective geometry and understood the significance of transforming a circle into a line. See figure 47. The world is revealed in the soul's subtlest thoughts. Now let's imagine a circle. We can trace its circumference all the way around and return to our original starting point. Let's picture the circle growing bigger and bigger, while a tangent line remains constant. Since the circle is growing increasingly flat, it will eventually become a straight line. When I trace these successively larger circles, I always go down on one side and come back up on the other, before returning to my starting point. Ultimately, I move in one direction, let's say to the right, until I reach infinity. Thus I must return from infinity on the other side, from the left, since the sequence of points in a straight line behaves just like a circle. So we see that space has no end, just as a straight line has no end, since its points are arranged just like those in a closed circle. Correspondingly, we must imagine the infinite expanse of space as self-contained, like the surface of a sphere. We have now depicted infinite space in terms of circles or spheres. This concept will help us conceive the reality of space. Instead of imagining ourselves proceeding mindlessly toward infinity and returning unchanged from the other direction, let's imagine that we carry a light. As seen from a constant point on the line, this light becomes ever weaker as we carry it away and ever stronger as we return with it from infinity. If we then picture the changes in the intensity of the light as positive and negative, we have positive on one side where the light grows stronger and negative on the other. We find these two poles, which are simply the opposite effects of space, in all effects in the natural world. This thought leads us to the concept of space as possessing force. The forces at work in space are simply manifestations of force itself. We will no longer doubt the possibility of discovering a force that works from within in three-dimensional space, and we will realize that all spatial phenomena are based on actual relationships in space. One such relationship is the intertwining of two dimensions. To make two closed rings interlock, you must open one of them in order to insert the other. I will now convince myself of the inherent manifoldness of space by twisting this figure, a rectangular strip of paper, twice. That is, I secure one end while rotating the other end 360 degrees. I then hold the two ends together, securing the strip with pins. Cutting this twisted ring in half lengthwise results in two interlocking rings that cannot be separated without breaking one of them. Simply twisting the strip made it possible to perform an operation in 3 dimensions that can otherwise be carried out only by entering the fourth dimension. This is not just a game. It is cosmic reality. Here we have the Sun, the Earth's orbit around the Sun, and the Moon's orbit around the Earth. See Figure 48. Because the Earth moves around the Sun, the orbits of the Moon and Earth are just as intertwined as our two rings of paper. In the course of Earth's evolution, the Moon broke away from the Earth. This separation occurred in the same way as the interlocking of our two rings of paper. When we look at space in this way, it becomes inherently alive. Next, consider a square. Imagine it moving through space until a cube has been described. The square's movement must be perpendicular to its original location. A cube consists of 6 squares that form its surface. To give you an overview of a cube, I can lay the 6 squares down beside each other in a plane. See Figure 49. I can reconstruct the cube by folding these squares upward, moving them into the third dimension. The 6th cube lies on top. To form this cross-shaped figure, I broke the cube down into 2 dimensions. Unfolding a 3-dimensional figure transforms it into a 2-dimensional figure. As you see, the boundaries of a cube are squares. A 3-dimensional cube is always bounded by 2-dimensional squares. Let's look at a single square. It is 2-dimensional and bounded by 4 1-dimensional line segments. I can lay these 4 line segments out in single dimension. See Figure 50. The edges defining one of the square's dimensions are colored red solid lines, and the other dimension is colored blue dotted lines. Instead of saying length and width, I can talk about the red and blue dimensions. I can reconstruct a cube from 6 squares. That is, I go beyond the number 4, the number of line segments forming the edges of a square, to the number 6, the number of planes forming the sides of a cube. Taking this process one step further, I move from 6 to 8, the number of cubes forming the sides, in quotes, of a 4-dimensional figure. I arrange the 8 cubes to form the 3-dimensional counterpart of the earlier figure, which consisted of 6 squares in the 2-dimensional plane. See Figure 51. Now, imagine that I can turn this figure inside out, fold it up, and put it together so that the 8th cube closes off the entire figure. I use 8 cubes to create a 4-dimensional figure in 4-dimensional space. Hinton calls this figure a tesseract. Its boundaries consist of 8 cubes, just as the boundaries of an ordinary cube consist of 6 squares. Thus, a 4-dimensional tesseract is bounded by 8 3-dimensional cubes. Envision a being that can see only in 2 dimensions. When this being looks at the unfolded squares of a cube, it sees only squares 1, 2, 3, 4, and 6, but never square 5. The shaded square in the middle, see Figure 52. Something similar is true when you yourself look at an unfolded 4-dimensional object. Since you can see only 3-dimensional objects, you can never see the hidden cube in the middle. Picture drawing a cube on the board like this, so that the outline of a regular hexagon appears. The rest of it is hidden behind. What you see is a shadow image of sorts, a projection of the 3-dimensional cube into 2-dimensional space. See Figure 53. The cube's 2-dimensional shadow image consists of rhombuses, or equilateral parallelepipeds. If you imagine the cube made of wire, you can also see the rhombuses in the back. This projection shows 6 overlapping rhombuses. In this way, you can project the entire cube into 2-dimensional space. Now imagine our tesseract in 4-dimensional space. Projecting this figure into 3-dimensional space must yield 4 oblique cubes, parallelepipeds, that do not interpenetrate. One of these rhombic oblique cubes would be drawn like this. See figure 54. 8 such oblique rhombic cubes, however, must interpenetrate in order to yield a complete three-dimensional image of a four-dimensional tesseract in three-dimensional space. We can depict the complete three-dimensional shadow of a tesseract with the help of 8 suitably interpenetrating rhombic cubes. The resulting spatial figure is a rhombic dodecahedron with 4 diagonals. See figure 55. In a rhombic projection of a cube, 3 adjacent rhombuses coincide with the other 3, so that only 3 of the 6 surface cubes are visible. Similarly, in the rhombic dodecahedron projection of a tesseract, only 4 non-interpenetrating rhombic cubes are visible as the projections of the tesseract's 8 boundary cubes, since 4 adjacent rhombic cubes completely cover the remaining 4. Thus we can construct a tesseract's three-dimensional shadow, though not the four-dimensional object itself. Similarly, we ourselves are shadows of four-dimensional beings. When we move from the physical to the astral plane, we must cultivate our capacity to form mental images. Picture a two-dimensional being repeatedly attempting to imagine vividly such a three-dimensional shadow image. Mentally constructing the relationship of the third dimension to the fourth fosters inner forces that will permit you to see into real, not mathematical, four-dimensional space. We will always remain powerless in the higher world if we do not develop faculties that permit us to see in the higher world here in the world of ordinary consciousness. The eyes we use for seeing in the physical, sense-perceptible world develop when we are still in the womb. Similarly, we must develop supersensory organs when we are still in the womb of the earth, so that we can be born into the higher world as seers. The development of physical eyes in utero is an example that illuminates this process. A cube must be constructed by using the dimensions of length, width, and height. A tesseract must be constructed by using the same dimensions with the addition of a fourth. Because it grows, a plant breaks out of three-dimensional space. Any being that lives in time frees itself from the 3 ordinary dimensions. Time is the 4th dimension. It remains invisible within the 3 dimensions of ordinary space and can be perceived only with clairvoyant powers. A moving point creates a line, a moving line creates a plane, and a moving plane creates a 3-dimensional figure. When 3-dimensional space moves, the result is growth and development. There we have 4-dimensional space or time projected into 3-dimensional space as movement, growth, and development. You will find that our geometric thoughts on building up the 3 ordinary dimensions continue into real life. Time is perpendicular to the 3 dimensions and constitutes the 4th dimension. It grows. When time is enlivened within a being, sensory ability arises. When time is multiplied internally within a being, so that self-movement takes place, the result is a sensate animal being. In reality, such a being has 5 dimensions, while a human being has 6. We have 4 dimensions in the ether realm, astral plane, 5 dimensions in the astral realm, lower Devakan, and 6 dimensions in upper Devakan. Thus the various manifestations of the Spirit emerge in you. When Devakan casts its shadow into astral space, the result is our astral body. When the astral realm casts its shadow into etheric space, the result is our ether body, and so on. The natural world dies when time moves in one direction and is re-enlivened when it moves in the other. The 2 points where these streams meet are birth and death. The future is constantly coming to meet us. If life moved in one direction only, nothing new would ever arise. Human beings also possess genius. That is, their future, their intuition, streaming toward them. The past that has been worked on is the stream coming from the other side. It determines the being as it has evolved up to the present time. The end of Lecture 7. You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at RudolfSteiner.podbean.com. Please consider becoming a patron. As well, there are two publishing houses, SteinerBooks.org in America and RudolfSteinerPress.com in England, which are the sole publishers of Steiner into English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works Volume 324A by Rudolf Steiner, entitled The Fourth Dimension. This is what we're calling the 8th lecture in the series. It's entitled On Higher Dimensional Space, given in Berlin on October 22nd, 1908, translated by Catherine Creeger. Today's subject will present us with a variety of difficulties, and this lecture you requested must be seen as one in a series. A profound understanding of the subject, even on a merely formal level, requires previous mathematical knowledge. Grasping the reality of the subject, however, requires deeper insight into esotericism. We will be able to address this aspect only very superficially today, providing stimulus for further thought. It is very difficult to talk about higher dimensions at all, because in order to picture any dimensions beyond the ordinary three, we must enter abstract realms, where we fall into an abyss if our concepts are not very precisely and strictly formulated. This has been the fate of many people we know, both friends and foes. The concept of higher dimensional space is not as foreign to mathematics as we generally believe. Mathematicians are already performing calculations involving higher dimensional operations. Of course, mathematicians can speak about higher dimensional space only to a very limited extent. Essentially, they can discuss only the possibility that it exists. Determining whether or not such space is real must be left to those who actually can see into it. Here we are dealing with pure concepts that, if precisely formulated, will truly clarify our concept of space. What is space? We usually say that space is all around us, that we walk around in space, and so on. To gain a clearer idea of space, we must accept a higher level of abstraction. We call the space we move around in three-dimensional. It extends upward and downward, to the right and to the left, and forward and backward. It has length, width, and height. When we look at objects, we see them as occupying three-dimensional space, that is, as possessing a certain length, width, and height. We must deal with the details of the concepts of space, however, if we wish to achieve greater clarity. Let's look at the simplest solid shape, the cube, as the clearest example of length, width, and height. The length and width of a cube's lower surface are equal. When we raise this lower surface until its height above its original location is the same as its width or length, we get a cube, that is, a three-dimensional figure. When we examine the boundaries of a cube, we find that they consist of plane surfaces, which are bounded in turn by sides of equal length. A cube has 6 such plane surfaces. What is a plane surface? At this point, those incapable of very keen abstractions will begin to go astray. For example, it is impossible to cut off one of the boundaries of a wax cube in the form of a very thin layer of wax, because we would always get a layer with a certain thickness, that is, a solid object. We can never arrive at the boundary of the cube in this way. Its real boundary has only length and width, but no height, that is, no thickness. Thus we arrive at a formula. A plane surface is one boundary of a three-dimensional figure and has one less dimension, then what is the boundary of a plane surface, such as a square? Again, the definition requires a high degree of abstraction. The boundary of a plane figure is a line, which has only one dimension, length. Width has been eliminated. What is the boundary of a line segment? It is a point which has 0 dimensions. Thus we always eliminate one dimension to find the boundary of a geometric figure. Let's follow the train of thought of many mathematicians, including Riemann, who has done exceptionally good work. Let's consider a point which has 0 dimensions, a line which has 1, a plane which has 2, and a solid object which has 3. On a purely technical level, mathematicians ask whether it is possible to add a 4th dimension. If so, the boundary of a 4-dimensional figure would have to be a 3-dimensional figure, just as a plane is the boundary of a solid body, a line the boundary of a plane, and a point the boundary of a line segment. Of course, mathematicians can then proceed to consider figures with 5, 6, 7, or even n dimensions, where n is a positive integer. At this point, a certain lack of clarity enters in when we say that a point has 0 dimensions, a line 1, a plane 2, and a solid object 3. We can make solid objects, such as cubes, out of any number of materials, wax, silver, gold, and so on. Their materials are different, but if we make them all the same size, each one occupies the same amount of space. If we then eliminate all the matter these cubes contain, we are left with only specific segments of space, the spatial images of the cubes. These segments of space are the same size for all the cubes, regardless of the material of which they were made, and they all have length, width, and height. We can imagine such cubical spaces extending to infinity, resulting in an infinite 3-dimensional space. The material object is only a segment of this space. The next question is, can we extend our conceptual considerations, which took space as their point of departure, to higher realities? For mathematicians, such considerations include only calculations involving numbers. Is this permissible? As I will now show you, using numbers to calculate the size of spaces results in great confusion. Why is this so? A single example will suffice. Imagine you have a square figure. This plane figure can be made broader and broader on both sides until eventually we have a plane figure that extends to infinity between 2 lines. See figure 56. Because this plane figure is infinitely wide, its size is infinity. Now suppose other people hear that the area between these 2 lines is infinitely large. Naturally, these people think of infinity. But if you mention infinity, they may get a totally incorrect idea of what you mean. Suppose I add another square to each of the existing ones. That is a second row of infinitely many squares. The result is, again, infinity, but a different infinity that is exactly twice as great as the first. See figure 57. Consequently, infinity equals 2 times infinity. In the same way, I could also arrive at infinity equals 3 times infinity. In calculating with numbers, infinity can be used just as easily as any finite number. It is true in the first case that the space is infinite, but it is just as true in the latter instances that it is 2 infinities, 3 infinities, and so on. That's what happens when we calculate using numbers. You see, as long as the concept of infinite space is linked to a numerical reckoning, it makes it impossible to penetrate more deeply into higher realities. Numbers actually have no relationship to space. Like p's or any other objects, numbers are totally neutral with regard to space. As you know, numerical calculations in no way change the reality of the situation. If we have 3 p's, multiplication cannot change that fact, even if we multiply correctly. Calculating that 3 times 3 equals 9 will not produce 9 p's. Merely thinking about something changes nothing in such cases, and numerical calculations are mere thinking. We are left with 3 p's, not 9, even if we performed the multiplication correctly. Similarly, although mathematicians perform calculations pertaining to 2, 3, 4, or 5 dimensions, the space that confronts us is still 3-dimensional. I'm sure you can experience the temptation of such mathematical considerations, but they prove only that it is possible to perform calculations concerning higher dimensional space. Mathematics cannot prove that higher dimensional space actually exists. It cannot prove that the concept is valid in reality. We must be rigorously clear on this point. Let's consider some of the other very astute thoughts mathematicians have had on this subject. We human beings think, hear, feel, and so on in 3-dimensional space. Let's imagine beings capable of perceiving only in 2-dimensional space. Their bodily organization would force them to remain in a plane, so they would be unable to leave the 2nd dimension. They would be able to move and perceive only to the right and left and forward and backward. They would have no idea of anything that exists above or below them. Our situation in 3-dimensional space, however, may be similar. Our bodily organization may be so adapted to 3 dimensions that we cannot perceive the 4th dimension, but can only deduce it, just as 2-dimensional beings would have to deduce the existence of the 3rd dimension. Mathematicians say that it is indeed possible to think of human beings as being limited in this particular way. Of course, it is certainly possible to say that even though this conclusion might be true, it might also simply be a misinterpretation. Here, again, a more exact approach is required, though the issue is not as simple as the first example, where we tried to use numbers to understand the infinity of space. I will deliberately restrict myself to simple explanations today. The situation with this conclusion is not the same as with the first purely technical, arithmetical line of reasoning. In this instance, there is really something to take hold of. It is true enough that a being might exist who could perceive only objects that move in a plane. Such a being would be totally unaware of anything existing above or below. Imagine that a point within the plane becomes visible to the being. Of course, the point is visible only because it lies within the plane. As long as the point moves within the plane, it remains visible. But as soon as it moves out of the plane, it becomes invisible. It disappears, as far as the plane being is concerned. Now, let's suppose that the point appears later somewhere else. It becomes visible again, disappears again, and so on. When the point moves out of the plane being cannot follow it, but may say, quote, "In the meantime, the point is somewhere where I cannot see it," close quote. Let's slip into the mind of the plane being and consider its 2 options. On the one hand, it might say, quote, "There is a 3rd dimension, and that object disappeared into it, and later reappeared," close quote. Or it could also say, quote, "Only stupid beings talk about a 3rd dimension. The object simply disappeared, and each time it reappeared, it was created anew." In the latter, close quote. In the latter case, we would have to say that the plane being violates the laws of reason. If it does not want to assume that the object repeatedly disintegrates and is recreated, it must acknowledge that the object disappears into a space that plane beings cannot see. When a comet disappears, it passes through 4-dimensional space. Now, we see what must be added in a mathematical consideration of this issue. We would have to find something in our field of observation that repeatedly appears and disappears. No clairvoyant abilities are needed. If the plane being were clairvoyant, it would know from experience that there is a 3rd dimension and would not have to deduce its existence. Something similar is true of human beings. Anyone who is not clairvoyant is forced to say, quote, I myself am restricted to 3 dimensions, but as soon as I observe something that disappears and reappears periodically, I am justified in saying that a 4th dimension is involved. Close quote. Everything that has been said thus far is completely incontestable, and its confirmation is so simple that it is unlikely to occur to us in our modern state of blindness. The answer to the question, quote, does something exist that repeatedly disappears and reappears, close quote, is very easy. Just think of the pleasure that sometimes rises in you and then disappears again, so that no one who is not clairvoyant can still perceive it. Then the same feeling reappears because of some other event. In this case, you, like the plane being, can behave in one of 2 ways. Either you can say that the feeling has disappeared into a space where you cannot follow it, or you can insist that the feeling vanishes and is created anew each time it reappears. It is true, however, that any thought that disappears into the unconscious is evidence of something that can disappear and then reappear. If this idea seems plausible to you, the next step is to attempt to formulate all the possible objections that could be raised from the materialistic viewpoint. I will mention the most pertinent objection now. All the others are very easy to refute. People may claim to explain this phenomenon in purely materialistic terms. I want to give you an example of something that disappears and reappears in the context of material processes. Imagine a steam piston in action. As long as force is applied to the piston, we perceive its motion. Now, suppose we counteract its motion with an identical piston working in the opposite direction. The movement stops, and the machines are motionless. The movement disappears. Similarly, people might claim that the sensation of pleasure is nothing more than molecules moving in the brain. As long as the molecules are moving, I experience pleasure. Let's assume that some other factor causes an opposite movement of molecules. The pleasure disappears. Anyone who does not pursue this line of thought very far might indeed find it a very significant argument against the ideas presented earlier. But let's take a closer look at this objection. Just as the movement of a piston disappears as a result of an opposite movement, a feeling that is based on molecular movement is said to be eliminated by an opposing molecular movement. What happens when one piston movement counteracts another? Both the first and the second movement disappear. The second movement cannot eliminate the first without eliminating itself too. The result is a total absence of movement. No movement remains. Thus, no feeling that exists in my consciousness could ever eliminate another without also eliminating itself. The assumption that one feeling can eliminate another is therefore totally false. In that case, no feeling would be left, and a total absence of feeling would result. The most that can still be said is that the first feeling might drive the second into the subconscious. Having said this, however, we admit the existence of something that persists, yet evades our direct observation. Today we have been speaking only about purely mathematical ideas, without considering clairvoyant perception at all. Now that we have admitted the possibility that a four-dimensional world exists, we may wonder whether we can observe a four-dimensional object without being clairvoyant. A projection of sorts allows us to do so. We can turn a plane figure until the shadow it casts is a line. Similarly, the shadow of a line can be a point, and the shadow image of a solid three-dimensional object is a two-dimensional plane figure. Thus, once we are convinced of the existence of a fourth dimension, it is only natural to say that three-dimensional figures are the shadow images of four-dimensional figures. This is one purely geometric way of imagining four-dimensional space. But there is also a different way of visualizing it with the help of geometry. Imagine a square which has 2 dimensions. Now, picture the 4 line segments that form its boundaries straightened out to form a single line. You have just straightened out the boundaries of a 2-dimensional figure so that they lie in 1 dimension. See figure 58. Let's take this process one step further. Imagine a line segment. We proceed just as we did with the square, removing 1 dimension, so that the boundaries of the figure fall in 2 points. We have just depicted the boundaries of a 1-dimensional figure in 0 dimensions. We can also unfold a cube, flattening it into 6 squares. See figure 59. We unfold the boundaries of a cube so that it lies in a plane. In this way we can say that a line can be depicted as 2 points, a square as 4 line segments, and a cube as 6 squares. Note the sequence of numbers, 2, 4, 6. Next we take 8 cubes. Just as the previous examples consist of the unfolded boundaries of geometric figures, the 8 cubes form the boundaries of a 4-dimensional figure. See figure 60. Laying them out results in a double cross that represents the boundaries of a regular 4-dimensional figure. Hinton calls this 4-dimensional cube a tesseract. This exercise gives us a mental image of the boundaries of a tesseract. Our idea of this 4-dimensional figure is comparable to the idea of a cube that 2-dimensional beings can develop by flattening a cube's boundaries, that is, by unfolding them. That is the end of Lecture 8. You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at RudolfSteiner.podbean.com. Please consider becoming a patron. As well, there are 2 publishing houses, steinerbooks.org in America and RudolfSteinerPress.com in England, which are the sole publishers of Steiner into English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works, Volume 324A by Rudolf Steiner, entitled The Fourth Dimension, Sacred Geometry, Alchemy, and Mathematics, translated by Catherine Creeger. I am on the second part of the book, which is a whole bunch of sets of questions and answers. I'm going to go through a multiple set each time. I'm going to call it Lecture 9 and Lecture 10 and Lecture 11 as I go through each chunk. But they're not. They're just collated question and answers. As it says here, questions and answers from 1904 to 1922. Editor's note: in the original German publication, the first question and answer is from 1904 in Berlin. There is no recorded question, only that it was asked by a Mr. Schouten, and the answer is simply a reply from Steiner that he would be giving a lecture shortly on the 4th dimension. Question and answers, Stuttgart, September 2nd, 1906. A question about the work of the eye, capital. The eye works on the astral body, the ether body, and the physical body. All human beings work on the astral body through moral self-education. But even when a person begins the process of initiation or esoteric schooling, much work remains to be done on the astral body. Initiation marks the beginning of more intensive work on the ether body through the cultivation of aesthetic taste and religion. Initiates work consciously on the ether body. In a certain respect, astral consciousness is 4-dimensional. To give you an approximate idea of it, let me say that anything dead tends to remain within the 3 ordinary dimensions, while anything living constantly transcends them. Through its movement, any growing thing incorporates the 4th dimension within the 3. If we move in a circle that is growing ever larger, we eventually arrive at a straight line. See figure 61. If we continue moving along this line, however, we will no longer be able to return to our starting point because our space is 3-dimensional. In astral space, which is closed off on all sides, we would return. In astral space, it is impossible to continue to infinity. Physical space is open to the fourth dimension. Height and width are two dimensions, and the third dimension is the lifting out and entering into the fourth dimension. A different geometry prevails in astral space. Questions and Answers, Nuremberg, June 28, 1908. Question: since time had a beginning, it is obvious to assume that space also has limits. What is the reality of the situation? That's a very difficult question, because the faculties needed to understand the answer cannot be developed by most people of today. For now you will have to simply take the answer at face value, but a time will come when it will be understood completely. The physical world's space with its three dimensions, as we human beings conceive of it, is a very illusory concept. We usually think that space either must reach to infinity or have boundaries where it is somehow boarded up and comes to an end. Kant put forward these two concepts of the infinity and the finiteness or limitedness of space, and showed that there is something to be said for and against both of them. We cannot judge the issue so simply, however. Since all matter exists in space and all matter is a condensed part of spirit, it becomes evident that we can achieve clarity on the question of space only by ascending from the ordinary physical world to the astral world. Our non-clairvoyant mathematicians already have sensed the existence of a strange and related phenomenon. When we imagine a straight line, it seems to reach to infinity in both directions in our ordinary space. But when we follow the same line in astral space, we see that it is curved. When we move along it in one direction, we eventually return from the other side, as if we were moving around the circumference of a circle. As the circle becomes larger, the time needed to go around it grows longer. Ultimately, the circle becomes so huge that any given section seems almost like a straight line, because there is so little difference between the circle's very slightly curved circumference and a straight line. On the physical plane, it is impossible to return from the other side as we would do on the astral plane. While the directions of space are straight in the physical world, space is curved in the astral world. When we enter the astral realm, we must deal with totally different spatial relationships. Consequently, we can say that space is not the illusory structure we think it to be, but a self-contained sphere. And what appears to human beings as physical space is only an imprint or copy of self-contained space. Although we cannot say that space has limits where it is boarded up, we can say that space is self-contained, because we always return to our starting point. Questions and Answers, Düsseldorf, April 21, 1909. Question: does the concept of three-dimensionality apply to the spiritual hierarchies, since we speak of their, in quotes, areas of dominion? Steiner: we can say that a human being's essence is realized in space. Space itself, however, from the esoteric perspective, must be seen as something produced as a result of creative activity. Its creation precedes the work and activity of the highest hierarchies. So we can presuppose the existence of space. We should not imagine the highest Trinity in spatial terms, however, because space is a creation of the Trinity. We must imagine spiritual beings without space, because space is a creation. The effects of the hierarchies within our world, however, have spatial limits, as do those of human beings. The other hierarchies move within space. Question: does time apply to spiritual processes? Steiner: certainly, but the highest spiritual processes in the human being lead to the concept that they run their course timelessly. The activities of the hierarchies are timeless. It is difficult to talk about how time came about, because the concept of time is implicit in the words "to come about." Instead, we would have to talk about the essence or being of time, which is not easy to discuss. No time would exist if all beings were at the same level of development. Time arises through the interaction between a number of higher beings and a number of lower beings. In timelessness, various levels of development are possible, but their interaction makes time possible. Question: what is space? Steiner: we must imagine the Trinity without space, because space is a creation of the Trinity. As such, space is a creation and belongs to our world. Space is significant only for beings that develop within earthly existence. Between birth and death, human beings are cut off from the spirit in space and time in the same way that a worm lives beneath the earth's surface. As for time, the highest states accessible to human beings are timeless. Because of the subtleties that come into play, it is not easy to speak about the concept of time coming into existence or about the essence or being of time. Time has had meaning only since the separation of the ancient moon from the sun. Everything external exists in space, and everything internal runs its course in time. We are circumscribed by both space and time. There would be no time if all beings in the universe were at the same level of development. In timelessness, we can imagine evolutionary levels that are equivalent. The concept of time emerges when these levels begin to differ and to interact. Even the divinity evolves. As evolution continues, even the concept of evolution itself evolves. Questions and Answers, Düsseldorf, April 22nd, 1909. The wording of the question has not been preserved. Steiner's answer: we are able to visualize three-dimensional space. An important theorem of the Platonic school is, quote, God geometrizes, close quote. Basic geometrical concepts awaken clairvoyant abilities. Positional geometry proves that the same point is everywhere on the circumference. The infinitely distant point on the right is the same as the starting point on the left. Thus, ultimately, the universe is a sphere, and we return to our starting point. Whenever I use geometric theorems, they turn into concepts at the borderline of normal conceptuality. Here, three-dimensional space returns us to our starting point. That is how in astral space point A can work on point B without any connection between them. We introduce materialism into theosophy when we make the mistake of assuming that matter becomes increasingly less dense as we move toward the spirit. This kind of thinking does not lead to the spirit, but ideas about the connection between point A and point B allow us to visualize the fourth dimension. As an example, we can think of the narrow waist of the gall wasp, see figure 63. What if the physical connection in the middle were absent, and the two parts moved around together, connected only by astral activity? Now extend this concept to many spheres of activity, see picture 64, in higher dimensional space. Question and Answer, Berlin, November 2nd, 1910. The wording of the question has not been preserved. Steiner's answer: plants have four dimensions. In the direction of the fourth dimension, a force works from below upward, counteracting the force of gravity so that the sap can flow upward. This rising direction, in conjunction with the fact that the two horizontal directions are unimportant to the leaves, results in the spiral arrangement of the leaves. In plants, therefore, the downward direction or the direction of gravity is nullified by the fourth dimension. As a result, plants can move freely in one direction in space. Animals have 5 dimensions. Their fourth and fifth dimensions counteract two of the other dimensions. Because two dimensions are nullified in animals, animals can move freely in two directions. Human beings are six-dimensional beings. Dimensions 4 through 6 counteract the other three dimensions. Consequently, three dimensions are nullified in humans. As a result, human beings possess three spatial dimensions and can move in three directions. Questions and answers, Basel, October 1st, 1911. Question: what is electricity? Steiner's answer: electricity is light in the sub-material state, light compressed to the greatest possible extent. We must also attribute inwardness to light. Light is itself at every point. Warmth can expand into space in three directions. But in the case of light, we must speak of a fourth direction. It expands in four directions, with inwardness as the fourth. Questions and answers, Munich, November 25th, 1912. Question: has spiritual science achieved anything with regard to the fourth and higher dimensions? Steiner's answer: it is not easy to make the answer to your question understandable. We human beings start from what we know from the physical, sense-perceptible world, where space has three dimensions. At least on a theoretical level, mathematicians formulate ideas about a fourth dimension and higher dimensions by analytically expanding their ideas on three-dimensional space through variables. At least in the context of mathematical thought, therefore, it is possible to speak of higher manifolds. For those familiar with these issues, that is, for those who put heart and soul into the question and also have the necessary mathematical knowledge, many things come to light. Let me mention simony in Vienna as an example. Readers aside, simony, I'm pronouncing it that way, is Simony, end of readers aside. Initially, higher dimensions exist only in ideas. Actually seeing them begins when we enter the spiritual world, where we are immediately forced to come to grips with more than three dimensions. There, any image presented to us, that is, anything that still possesses intrinsic characteristics of three-dimensionality, is nothing more than a reflection of our own soul processes. In the higher worlds, very different spatial relationships prevail, if indeed we still want to call them spatial relationships. The same is true with regard to time. There are always many people who argue, how can we be sure that all your claims are not based on hallucinations? Such people need to consider the situation with regard to time, because they disregard the fact that the field of spiritual science works with phenomena that are totally different from hallucinations. Your question provides an opportunity to supplement what I said in the lecture, because it is never possible to say everything, and today's lecture was very long. Let me still point out the changes that take place with regard to time and space when we enter the spiritual world. The return of the images that we have banished to Hades, as it were, makes sense only when approached in terms of higher dimensions. There, however, this is just as natural and self-evident as three-dimensionality is in the sense-perceptible world. That is why ordinary geometry is a poor match for the beings and events of the spiritual world. On behalf of mathematicians, it must be said that their speculations about the fourth dimension acquire real value when we enter the spiritual world. Usually, however, their conclusions about higher dimensional space are only generalizations, based on Euclidean three-dimensional perceived space rather than on reality, to which their conclusions do not fully correspond. We would need still better mathematics in order to perform calculations regarding the beings and events that spiritual researchers investigate. And yet the answer to your question is yes. Correlations to a supra-sensible world, and also mathematical ideas about infinity, become a reality especially certain subjects from the fringes of mathematics. Here is an example that I myself experienced many years ago. I know that I had a sudden flash of insight into an extremely important attribute of astral space when I was studying modern synthetic projective geometry and analytical mechanics at the university. There is a relationship here to the concept that on a straight line extending to infinity, the infinitely distant point on the left is identical to the infinitely distant point on the right. That a straight line, with regard to the arrangements of its points, is really a circle. If we do not get winded and continue in a straight line long enough, we return from the other side. We may understand this, but we should not draw conclusions from it, since conclusions lead nowhere in spiritual research. Instead, allowing phenomena to work on us leads to knowledge of the supersensible world. It is important not to overestimate mathematics when dealing with the supersensible world. Mathematics is useful only on a purely formal level. It cannot possibly grasp the reality of the situation. Like spiritual science, however, mathematics can be understood by means of forces inherent in the soul itself and is equally true for everyone. That is what mathematics and spiritual science have in common. Questions and Answers, Berlin, February 13th, 1913. Question: Is the golden section based on occult laws? Steiner's answer: because it is founded upon the effect of what exists in space, the golden section is indeed based on an occult law. Goethe said of this law that what is most hidden is most revealed, and vice versa, namely, the law that is intimately related to our human constitution, the law of repetition and varied repetition. If you look at Buddha's talks, for example, you find that the same content is always repeated with slight variations that must not be omitted, because the content is not the only important factor. The golden section is not simply a matter of repetition. We repeatedly discover the same proportion, since there are actually only three components. The self-contained character of a repetition, which, however, is not self-formed, is what makes the golden section so appealing to us. Questions and Answers, Berlin, November 27, 1913. Question: Do human beings between death and rebirth have the same perception of time as those incarnated in bodies? Steiner's answer: My lecture on March 19, 1914, on the human being between death and rebirth, will supply more information on this subject. For today, let me just say that life after death means leaving the relationships of the sense-perceptible physical world and entering totally different relationships of space and time. With the theory of relativity, we are beginning to develop different concepts of time. We can make the transition from the factors in the formula for movement into the circumstances of the spiritual world only when we use these factors in the form C equals S divided by T. Because S and T, as we know them, belong to the sense-perceptible world, while C, parenthesis, or V for velocity, close parenthesis, actually belongs to the domain of inner experience, even with regard to an inorganic object. Thus, when we want to understand time in the spiritual world, we must first speak of the quantum of speed that the being in question has. Then, through comparison, we as outsiders can determine something about temporal relationships. Through a comparison of sorts, for example, we can discover that speed is 3 times as great in life in Kamaloka. Such investigations give us an impression of the relationship between time in spiritual life and time in the life of the senses. In the spiritual world, different principles of time prevail. In comparison with those of the sense-perceptible world, these principles are internalized and variable. Because the time we experience there is dependent on inner developmental processes, It cannot be compared in clear mathematical terms with periods of time in the physical world. Question and Answers, Stuttgart, 1919. The wording of the question has not been preserved. Steiner's answer. Mathematics is an abstraction of the sum total of forces working in space. When we say that mathematical theorems are valid a priori, this statement is based on the fact that human beings exist within the same lines of force as other beings, and that we are able to abstract this from everything not belonging to the pattern of space, etc. Questions and Answers, Stuttgart, March 7th, 1920. First question. Is the law of the absolute propagation of light correct? Second question. Is there any reality to the relativity of time assumed by Einstein? Steiner's answer. I assume that your first question deals with whether light in absolute space travels at a constant speed. As you know, we cannot really talk about the propagation of light in absolute space because absolute space does not exist. What basis do we actually have for talking about absolute space? You said, and rightly so, that you assume the propagation of light is infinitely great, and that light derives its actual propagation from the resistance of the medium. Now, I ask you, in your view, is it altogether possible to speak of the speed of light in the same sense that we speak of the speed at which any other body travels? Reply from Hermann von Baraval. Absolutely not. Steiner continues. If we do not hypothetically equate light with any other body, we cannot measure its speed in the same way as that of any other body. Let's assume that an ordinary body, a material object, is flying through space at a certain speed. This object is at a specific place at a specific moment in time, and our entire method of measuring speed depends on considering the difference in the object's location from its point of departure at two different times. This method of measurement remains possible only if the moving material body completely leaves the points on the line in which it is moving. Let's assume that it does not leave these points, but leaves traces behind. Applying this method of measurement immediately becomes impossible if the object moving through a given space does not leave that space, but continues to occupy the line of movement, not because we cannot measure the differences, but because the propelling speed constantly modifies the propelled object. I cannot apply my ordinary method of measurement when, instead of dealing with matter that leaves the space empty behind it, I am dealing with an entity that does not completely vacate the space, but leaves traces behind. Thus we cannot speak of a constant speed of light in the same sense that we speak of the speed of a material object, because we cannot formulate an equation based on differences in location, which of course provide a basis for calculating speed. Thus, when we are dealing with the propagation of light, we find ourselves compelled to speak only about the speed of the outer propagation of light. But if we speak about the speed of the propagation of light, we should be obliged to go back constantly to the source of the spreading light in order to measure its speed. In the case of the sun, for example, we would be obliged to go back to the origin of the spreading light. We would have to begin measuring where the spread of light began, and we would have to assume hypothetically that the light continues to replicate indefinitely. This assumption is not justified, however, because the frontal plane in which the light is spreading, instead of always simply growing larger, becomes subject to a certain law of elasticity and reverses direction when it achieves a certain size. At that point, we are no longer dealing simply with spreading light, but with returning light, with light retracing the same path in reverse. On an ongoing basis, therefore, I am not dealing with a single location that I assume to exist in light-filled space, that is, with something that is spreading from one point to another, but with an encounter between two entities, one of which is coming from the center and the other from the periphery. Thus I cannot avoid asking the fundamental question, are we really dealing with speeds in the ordinary sense when we consider the transmission of light? I don't know whether or not I have made myself understood. I am not dealing with speed of propagation in the ordinary sense. And when I take the step from ordinary speeds to speeds of light, I must find formulas based on formulas for elasticity. If I may use the image of material movement, such formulas must reflect how elastically related portions of space behave in a closed elastic system with a fixed sphere as its boundary. Therefore, I cannot use an ordinary formula when I shift to describing the behavior of light. For this reason, I see a fundamental error in Einstein's work, namely that he applies ordinary mechanical formulas, for that is what they are, to the spreading of light, and assumes hypothetically that light can be measured in the same way as any material body flying through space. He does not take into account that spreading light does not consist of material cosmic particles speeding away. Light is an event in space that leaves a radiant trace behind. So that when I measure it, reference to drawing that it has not been preserved, I cannot simply measure as if the object comes this far and leaves nothing behind. When light is transmitted, however, there is always a trace here, and I cannot say that it is transmitted at a specific speed. Only the frontal plane is transmitted. That is the main point. I am dealing with a specific entity in space that has been subsumed by the spreading element. And then I see a second error that has to do with the first, namely that Einstein applies principles to the whole cosmos that actually apply to mechanical systems of points that approach each other, thus disregarding the fact that the cosmos as a whole system cannot be merely a summation of mechanical processes. For example, if the cosmos were an organism, we could not assume that its processes are mechanical. When a mechanical process takes place in my hand, it is not essentially determined merely by the closed mechanical system, because my entire body begins to react. Is it acceptable to apply a formula for other movements to the movement of light? Or is the reaction of the entire cosmos involved? A universe without light is even more difficult to imagine, without the reaction of the entire universe. And this reaction works very differently from speeds in a closed mechanical system. It seems to me that these are Einstein's two principal errors. I have studied his theory only briefly, and we all know that mathematical derivations can indeed coincide with empirical results. The fact that starlight that has passed the sun, for example, coincides with theoretical predictions does not verify Einstein's theory once and for all. These two principal underlying factors are why Einstein's way of thinking is always so paradoxical and abstract. The situation here is somewhat similar to the example from Wilhelm Busch that you used earlier, where an arm is raised forcefully and you almost have the feeling that you are going to be slapped on the face. It's a bit like that when Einstein draws conclusions from what would happen if a clock sped away at the speed of light and then returned. I ask you, is there any reality to this notion? I absolutely cannot complete the thought, because I am forced to wonder what happens to the clock. If you are accustomed to restricting your thoughts to reality, you cannot carry thoughts such as this through to completion. The passages where Einstein presents such thoughts show that his conclusions are based on fundamental errors such as the one I just mentioned. That was my first comment. On the subject of time, we would need to begin basing our thoughts on elastic formulas rather than ordinary mechanical formulas. We would need to borrow from the theory of elasticity. By extension, any distribution or spreading that forms a frontal plane cannot be imagined as an entity that continues to spread out to infinity. It always reaches a certain sphere where it turns back in on itself. If we want to address the reality of the situation, we cannot say that the sun radiates light that vanishes into infinity. That is never the case. There is always a boundary where the spreading force of elasticity is exhausted and turns back in on itself. There is no such thing as an infinite system that meets the criteria of spreading out and disappearing into nothingness. Any spreading entity reaches a boundary where it turns around, somewhat as if it were obeying the law that governs elastic bodies. When we speak of light, we are never dealing with something that continues to spread indefinitely in all directions. Instead, we always find a situation comparable to standing waves. That is where we must look for the formulas, not in ordinary mechanics. Then there is still the question of time itself. In fact, time does not go through all these transformations, does it? Here in the realm of mechanics, time as such is not a reality. Take the very simplest formula, S equals C times T. According to the ordinary law of multiplication, S must be essentially identical to C. Otherwise, the space S would be identical to the time, which is impossible. In this formula, I can think of space only as somehow mathematically identical to C. We cannot apply apples and pears, can we? We have to put one in terms of the other. In mathematical formulas, time can only be a number, which, however, does not mean that the reality of time is a number. We can write the formula like this only when we assume that we are dealing with an unnamed number. The formula C equals S divided by T is a different matter. Here we have a space S of a certain size as it relates to the size of the number T. The result is the speed C. This is the reality of the situation regardless of whether I imagine atoms, molecules, or matter that occupies a specific perceivable amount of space. I must imagine that anything I confront empirically has a specific speed. Any further conclusions are just abstractions. Time is something that I derive from the divisor, and the distance traveled is something I derive from the dividend. But these are abstractions. The reality, and this applies only to mechanical systems, is the immanent speed of each body. For example, when physicists accept atomic theory for other reasons, they must not assume that atoms exist without immanent speed. Speed is a true reality. Thus we must say that we abstract time, as such, from events and processes. It is actually an abstraction from events. Only the speeds of what we encounter can be seen as realities. When we understand this completely, we can no longer avoid concluding that what I call time appears as a result of phenomena. It plays a collaborative role in phenomena, and we must not disregard it as a relative. The collaboration of this abstracted factor yields a specific real and fundamental concept of an organism's lifespan. For example, the lifespan of an organism cannot be measured externally. Its course is immanent. Any given organism has a specific inherent lifespan that is integrated into and results from all the processes taking place in the organism. The same is true of an organism's size. It is intrinsic to the organism and is not to be measured in relationship to anything else. The fitting conclusion is that such concepts of lifespan and size are not valid in the same way that we ordinarily assume. Human beings are a specific size. Now, let me hypothetically assume that very small human beings exist in our ordinary universe. For all other purposes, the size of human beings relative to other objects is not important. Their typical size is important to human beings, however, because this size is intrinsic. This point is important. Imagining that human beings can be arbitrarily larger or smaller is an offense against the entire universe. For example, certain scientific thinkers wonder what life would be like in a solar system that is infinitely large or small compared with ours. This question is nonsense. Both the sizes and the lifespans of the real entities we encounter are matters of inner necessity. At this point, I must state that any entity that can be considered a totality essentially carries its own time within it. I can look at a piece of an inorganic object independent of anything else, but I cannot do the same with a leaf, because its continued existence depends on the tree. Thus I must consider whether or not the entity I am observing is a totality, a whole, self-contained system. Any totality that I observe, however, incorporates time as an immanent factor. Consequently, I do not think much of the idea of an abstract time that exists outside objects, and in addition to the time that is inherent in each object or event. Looking at time that is supposed to run from beginning to end is a bit like developing the abstract concept horse on the basis of individual horses. Individual horses exist in the external reality of space, but the concept requires something more. The same is true of time. Whether time is inherently changeable or not is essentially an empty question, because each total system in its own immanent existence has its own time and its own speed. The speed of any inorganic or vital process points back to this immanent time. For this reason, instead of a theory of relativity that always assumes we can relate one axial coordinate system to another, I would prefer to establish a theory of absolutes to discover where total systems exist that can be addressed in the same way we address an organism as a totality. We cannot talk about the totality of the Silurian period in the Earth's evolution, for example, because the Silurian period must be united with other evolutionary periods to form a system that is a totality. It is equally impossible to speak about the human head as a totality, because the rest of the body belongs with it. We describe geologic periods independently of each other, as if that were the reality of the situation. It is not. One period is a reality only in connection with the entire evolution of the Earth, just as a living organism is a reality from which nothing can be removed. Instead of relating our processes to coordinate systems, it would be much more pertinent to relate them to our own inherent reality, so that we could see the whole systems or totalities. At that moment, we would have to return to a certain type of monadism. We would overcome the theory of relativity and arrive at a theory of absolutes. We would then truly see that Einstein's theory is the last expression of the striving for abstraction. Einstein functions in abstractions that sometimes become intolerable when his assumptions are applied to very elementary matters. For example, how does sound work when I myself am moving at the speed of sound? If I do that, of course, I never hear real sounds, because the sound is traveling with me. To anyone who thinks in real terms, in terms of totalities, such a concept cannot be implemented, because any being that can hear would fall apart if it moved at the speed of sound. Such concepts are not rooted in observations of the real world. The same is true when I ask whether time is inherently changeable. Of course, it is impossible to confirm any changes in abstract or absolute time, which must be imagined a priori. When we talk about changes in time, however, we must grasp the reality of time, which we cannot do without considering how temporal processes are intrinsically linked to total systems that exist in the world. Questions and Answers, Stuttgart, March 7, 1920. Question. According to Einstein's theory, there is a tremendous amount of energy stored in 1 kilogram of matter. Is it possible to tap a new source of energy by breaking matter apart? That is, by spiritualizing it? Steiner's answer. The issues you raise are not related directly to the part of Einstein's theory that we discussed today. It certainly would be possible to release energy through the fission of matter. The theoretical aspects present no particular difficulties. The only question is whether we have the technology to utilize this energy. Would we be able to put to use the gigantic forces that would be released? We would not. If they destroy the motor they are meant to run. We first would have to develop mechanical systems capable of harnessing this energy. From a purely theoretical perspective, releasing large amounts of radiant energy for use in a mechanical system requires a substance that can resist the energy. Releasing the energy is quite possible and much easier than utilizing it. Question. Would it be possible to eliminate matter altogether, so that only energy or radiation is left? Steiner's answer. In a certain respect, matter is eliminated, as in what happens in vacuum tubes. Only a flow of electricity remains. Only speed remains, and speed is the determining factor in the mathematical formulas that refer to this phenomena. The question is, does the formula E equals mc squared, in which energy and mass appear at the same time, sufficiently consider the fact that mass as such is different from energy? Or, when I write this formula, am I very abstractly separating two things that are actually one and the same? Is this formula justifiable? It is justifiable only for potential energy, in which case Einstein's formula, E equals mc squared, is simply the old formula for potential energy in a new disguise. Question. Can't we take P times S as our starting point? Steiner's answer. A difficulty arises here, simply because when I relate two members of one system of magnitude to something that belongs to another system, for example, if I relate the time it takes two people to do a certain job to a factor supplied by the sun's setting, the process in the whole system, because it can truly be applied to all members of the system, very easily assumes the character of something that does not belong to any system, but can stand on its own. You must not assume that an abstraction such as a year that is derived from the solar system is also valid in another system. For example, if you confirm how much a human heart changes in 5 years, you can then describe the condition of a person's heart as it was 5 years ago in comparison to what it is now. But by simply continuing the same arithmetical process, you also can ask what that person's heart was like 150 years ago, or what it will be like 300 years from now. This is what astronomers do when they start from the present state of the Earth. They neatly calculate changes over periods of time that make as little sense with regard to present conditions on Earth as our calculations about the state of a human heart in 300 years. We always forget that a conclusion that is valid with regard to the imminent time of a process ceases to have meaning when the process comes to an end. Thus I cannot transcend the organism as a currently living total system. The total system allows me to keep my concepts within the system, and I immediately violate the system when I step outside its bounds. The appearance of validity is evoked because we are accustomed to relating to systems of magnitude in the sense of total systems, and then make absolutes out of factors that apply only within such systems of magnitude. That is the end of Lecture 9 or Section 9. You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at rudolfsteiner.podbean.com. Please consider becoming a patron. As well, there are two publishing houses, steinerbooks.org in America and rudolfsteinerpress.com in England, which are the sole publishers of Steiner into English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works, Volume 324A by Rudolf Steiner, The Fourth Dimension. This is section, or I'm calling it a lecture 10, which is a collection of questions and answers that Steiner gave around the fourth dimension. Questions and Answers, Stuttgart, March 11th, 1920. First question. Does my attempt to define the hyper-imaginary through relationships of points on curved surfaces or manifolds correspond to reality? Second question. Is it possible to acquire an enlivened view of the realm of imaginary numbers, and do actual entities underlie this realm? Third question. Which aspects of modern mathematics, and which formal aspects in particular, need to be developed further along spiritual scientific lines? Rudolf Steiner's answer. Let me begin with your second question. The answer is not easy to formulate, because in order to do so, we must leave the realm of visualization to a very great extent. When I answered Dr. Mueller's question several days ago, you saw that in order to provide a concrete correlate for a mathematical case, I had to turn to the transition from long bones to head bones, and yet the graphic example was still valid. At least in that case we were still able to visualize the objects, and hence the transition from one to another. When we attempt to look at the domain of imaginary numbers as a spiritual reality, we find that we need to shift from positive to negative, as I recently demonstrated in these lectures on physics. This shift makes our ideas true to reality when we attempt to understand certain relationships between so-called ponderable matter and so-called imponderables. But even when we visualize very ordinary domains, we can see the need to transcend customary ways of illustrating them. Let me mention just one example. On a plane drawing of the ordinary spectrum, we can draw a straight line from red through green to violet. Such a drawing, however, does not symbolize all the relevant aspects, which are encompassed only when we draw a curve, more or less in this plane. Reference to a drawing that has not been preserved. To symbolize the red. Then, to depict the violet, we go to the board, and behind the board, so that the red as seen from above lies in front of the violet. I would have to move out of the plane for the red and back into it for the violet, in order to characterize the violet as moving inward toward chemical activity, and the red as moving outward toward warmth. Thus I am forced to expand the straight line here and to see my ordinary drawing as a projection of what I actually ought to draw. To achieve clarity concerning certain phenomena of higher reality, it is not enough to shift from the positive material aspect to the negative. That is just as unsatisfactory as moving in a straight line from red through green to violet. When we move from the spatial realm to the non-spatial, as symbolized by positive and negative respectively, we must shift to a higher form of spatial and non-spatial. This process is like moving along a spiral, instead of moving around a circle and returning to our starting point. Just as elsewhere 2 different types may be summed up in a union that contains both, we also can imagine the existence of something that is both spatial and non-spatial. We must seek this third element. In the domain of higher reality, if we describe physical reality as positive, we are obliged to describe the etheric realm, where we leave space and begin to enter spirit, as negative. When we take the step into the astral realm, however, space and negative space are no longer enough. We must turn to a third element that relates to positive and negative space in exactly the same way that imaginary numbers relate to positive and negative numbers in formal mathematics. And if we then take the step from the astral realm to the true being of the I capital, we need a concept that is hyper-imaginary in relationship to the imaginary. For this reason, I have never been happy with academic antipathy to the concept of hyper-imaginary numbers, because this concept is truly needed when we ascend to the level of the I, and cannot be omitted unless we want our mathematical formulations to leave the realm of reality. This issue is simply how to use the concept correctly in purely formal mathematics. Someone I met today discussed the problem of probability, a question that very clearly demonstrates the great difficulty of relating a mathematical procedure to reality. Insurance companies can calculate when a person is likely to die, and their figures are very accurate when applied to groups. It is impossible, however, to conclude from actuarial figures that any individual is going to die exactly in the year that is predicted. Consequently, these calculations lack reality. The results of calculations are often correct in a formal respect, yet do not correspond to reality. We also might have to rectify the formal aspects of mathematics in some instances to accord with such results of hyper-empirical reality. For example, is it correct to state that A times B equals 0 is true only when one of the factors is 0? When either A or B is equal to 0, their product certainly is 0. But is it possible for the product to equal 0 when neither of the 2 factors is 0? Indeed, this might be possible if the reality of the situation forced us to turn to hyper-imaginary numbers, which are the correlates of hyper-empirical reality. We must indeed attempt to clarify the relationship of real to imaginary numbers and the relationship of hyper-imaginary numbers to imaginary and real numbers. But we also may have to modify the rules governing calculations. With regard to your first question, in the human being we can distinguish only what lies above a certain level and below a certain level. I explain this to almost everyone I think will be able to understand it. To anyone who looks at the wooden sculpture in Dornach of Christ in the center as the representative of humanity, with Ahriman and Lucifer on either side, I explain that we truly must imagine the human beings we encounter as existing in a state of balance. On one side is the supra-sensible, on the other the sub-sensible. Each human being always represents only the state of balance between the supersensible and the subsensible. Of course, the human being is a microcosm of sorts, and as such is related to the macrocosm. Therefore, we must be able to express the connection between each detail of the human being and a corresponding phenomenon in the macrocosm. Let me illustrate it like this. If this is the plane of balance, reference to a drawing that has not been preserved, and I imagine the subsensible element in the human being as a closed curve, and the suprasensible element, or what human beings have in their consciousness, as an open curve, the resulting form is knotted below and opens outward above. This also represents how the human being is incorporated into the macrocosm. This lower knob-like area pulls us out of the macrocosm, while the open curve of this upper surface incorporates us into the macrocosm. Here is the approximate location of freely willed human decisions. Above the level of free will, human forces are allowed to move out into the macrocosm. Everything below this level encloses macrocosmic forces, so that we can assume a specific form. Within the plane figures formed by this curve, let's note a series of data that I will call X, representing the cosmic thoughts that we can survey. Here we have the cosmic forces that can be surveyed, and here the cosmic movements. If I formulate a function involving these numbers up here, the result corresponds to what is down here in the human being. We need a function of factors x, y, and z. When I attempt to find numbers that express this relationship, however, I cannot find them in the domain of the number system that is available on this plane. In order to connect the supersensible and the subsensible human being, I must resort to equations containing numbers that belong to systems lying on curved surfaces. These surfaces can be more precisely defined as the surfaces lying on paraboloids of revolution. Surfaces that emerge when cones rotate in such a way that each rotating point constantly changes speed. There are also more complicated rotational paraboloids whose points, instead of maintaining fixed relationships among each other, are able to change within the limits of certain laws. Thus the surfaces that serve my purpose are enlivened rotational paraboloids. The relationship I am describing is extremely difficult. To date, certain individuals have imagined it, and the need for it has been discovered. But formal calculations will become possible only once esoteric or spiritual science is able to collaborate with mathematics. The path you have outlined for us today constitutes a beginning, a possible initial response to the challenge to discover what corresponds to the association of related functions that refer to number systems on the surfaces of two rotational paraboloids, one that is closed below and one that is open above, whose vertices meet in one point. As I have described, we would simply need to find the numbers lying on these surfaces, which do indeed correspond to a real situation. With regard to the future development of formal mathematics, I must admit that it seems that much remains to be done and that much is possible. My next comment may do formal mathematics an injustice, since I have been less able to keep up with it in recent years. It has been a long time since I was fully aware of what is going on in this field, and things may have changed. Before the turn of the century, however, I always had the feeling that the papers published in the field of formal mathematics were terribly unconcerned about whether their calculations and operations were actually possible at all, or whether they would need to be modified at a certain point in accordance with some real situation. For example, we can ask what happens when we multiply a one-dimensional manifold by a two-dimensional manifold. Although it is possible to answer such questions, we must nonetheless wonder whether an operation like this corresponds to any reality at all, or even to anything we can imagine. In order to get somewhere, it may be necessary to define clearly the concept of, quote, only calculable, close quote. As an example, a long time ago I attempted to prove the Pythagorean theorem in purely numerical terms, without resorting to visual aids. It will be important to formulate the purely arithmetical element so strictly that we do not unwittingly stray into geometry. When we calculate with numbers, as long as we stay with ordinary numbers, They are just numbers, and there is no need to talk about number systems in specific domains of space. When we talk about other numbers, however, imaginary numbers, complex numbers, hyper-complex numbers, hyper-imaginary numbers, we do have to talk about a higher domain of space. You have seen that this is possible, but we have to leave our ordinary space. That is why I feel that before purely formal mathematics sets up numbers that can only be symbolized, and in a certain sense applying additional corresponding points to specific domains of space is symbolization, we must investigate how such higher numbers can be imagined without the help of geometry. That is, in the sense that I can represent a linear function through a series of numbers. We would have to answer the question of how to imagine the relationship of positive and negative numbers on a purely elementary level. Although I cannot provide a definitive answer, because I have not concerned myself with the subject and do not know enough about it, Gauss's solution, namely to assume that the difference between positive and negative is purely conceptual, seems inadequate to me. Düring's interpretation of negative numbers as nothing more than subtraction without the minuend seems equally inadequate. Düring accounts for the imaginary number, the square root of a -1, in a similar way, but this number is nothing more than an attempt to perform an operation that cannot be carried out in reality, though the notation for it exists. If I have 3 and nothing I can subtract from it, 3 remains. The notation for the operation exists, but nothing changes. In Düring's view, the differential quotient is only a notated operation that does not correspond to anything else. To me, Düring's approach also seems one-sided, and the solution probably lies in the middle. We will get nowhere in formal mathematics, however, until these problems are solved. Questions and answers, Stuttgart, March 11, 1920. First question. The question is, does such an understanding correspond to reality? Since what we did in simple geometry also would have to be possible in all domains of mathematics, could understanding mathematical objects as intermediary links between archetype and physical image perhaps serve as a foundation for the types of calculations needed to support the physics presented in this lecture? Second question. Might this be a path to the so-called hyper-empirical realm that we reach by controlling and enhancing our thinking? Steiner's answer. If I understand your first question correctly, you are asking whether we can approach the realm of mathematics as an intermediary stage between archetype and physical image. Let's look at the domains of mathematics from a purely spiritual and empirical perspective. What are the spatial and geometric domains of mathematics? Or were you thinking of arithmetic as well? Answer from Alexander Strakosch. I was thinking of geometry. During this lecture series, I have already suggested, parenthetically, how we arrive at ordinary geometrical figures. We do not discover them by abstracting from empirical ideas. Initially, mathematical and geometric figures are an intuition of sorts. They are derived from the will nature of the human being. So we can say that when we experience mathematical figures, it is always possible for us to be active and to relate to reality in the mathematical domain. Thus, such figures, even on an empirical level, already represent a type of intermediate stage between external realities, which we can possess only in image form, and the direct contents of being, which we experience inwardly. A spiritually empirical perspective would show that when we understand geometry, we grasp an intermediate stage between archetype and physical image. However, there is something we must still do in order to verify this train of thought. If geometric and mathematical figures are indeed intermediate states between archetype and image, they must have a certain non-material ideal attribute that images do not have, though it only becomes so non-material in the sphere of images. An image also can be a combination. It does not necessarily correspond to its archetype. Any mere image that we confront need not correspond to an archetype. But if we have an intermediate state that incorporates a certain amount of reality, we need to be able to discover a corresponding, specific field of reality, and we cannot combine such domains arbitrarily. We can never combine archetypes in a living way. We must seek them out in their own domains, where they are present as distinct experiences. Thus, in order to grasp this middle domain in the right way, what you call the domain of the perceived lawfulness of mathematical objects, we also must understand its construction as an intermediate state between absolute fixed archetypes and a boundless number of images. That is, we would have to interpret all of mathematics, and especially geometry, as inherently mobile, as existing at least in latent form in all of reality. For example, we could not imagine a triangle as immobile, but would have to visualize the full scope of the concept. What is a triangle? A triangle is an area bounded by straight lines, and the sum of its angles is 180 degrees. We would have to imagine the lengths of its three sides as being infinitely variable, and our definition would yield an infinite number of triangles, or a triangle in flux. This way of looking at things would result in a fluid geometry. We would have to be able to prove that this fluid geometry has some significance for the natural kingdom, that it corresponds to an aspect of the law of crystallization, for example. So the answer to your question is yes. This view is indeed based on an idea that corresponds to reality. But a great deal remains to be done to make the entire concept clear. I must still touch on another subject that plays into all this. You see, in recent times, people have made a habit of taking refuge in higher dimensions when they want to enter higher domains of reality. That was not always the case in the formalism that formed the basis of our conceptions of the occult. In earlier times, people said that while we must conceive of ordinary physical figures as three-dimensional, figures belonging to astral space must be seen in the context of a two-dimensional plane. Note that I am now talking about the spheres or planes of existence, and therefore the term astral is used in a sense different from the one I used when talking with Mr. Blumel and describing the steps between the physical body and the I, capital. We must imagine the next level, the Rupa plane, as one-dimensional in scope, and when we imagine the Arupa plane, we arrive at a point. In this way we can say that as we move toward more spiritual ideas, the number of dimensions must decrease rather than increase. We are subject to this phenomenon when we move from above to below, as we do, for example, when we attempt the following train of thought. We can distinguish quite well among spirit, soul, and body, but what is the spiritual element in a human being walking around on earth? We must say that this spiritual element is present in an extremely filtered form. We humans owe our abstract thinking to the spirit. It is the spiritual element in us. On its own, it tends to perceive only sense-perceptible objects and events. But the means of perceiving is spiritual. When we trace the spirituality of thinking down into the bodily element, we find that it has an expression in the human physical body, while the more comprehensive spiritual element has no such expression. Crudely speaking, 1/3 of the spiritual world in which we humans take part has an expression in the physical human body. Moving on to the soul, 2/3 of the spiritual world in which humans take part achieve expression in the physical human body. And when we move on to the physical body, 3/3 has achieved expression. As we move from above to below, we must imagine that in the progression from the archetype to its image, the archetype easily leaves aspects of its being behind. And this phenomenon provides the essential characteristic of our physical aspect. In contrast, as we move upward, we discover new elements that have not been incorporated into the image. As we move downward, however, what we encounter is not merely an image. Reality plays into it. It is not true that at night, when the physical and ether bodies are lying in bed, the astral body and I simply pull out of the body and leave it empty. Higher forces enter the physical and ether bodies and enliven them, while the astral body and I are gone. Similarly, an image contains elements that do not originate only in its archetype. These elements enter when the image becomes an image, when it belongs to the entity. Then the interesting question arises: how does a merely imaginatively combined image become a real image? That is when the other subject I mentioned enters in. Let me still comment that when we consider 2 dimensions, our initial train of thought leads directly to a second that can illuminate the first. All 2-dimensional figures can be drawn in 2 dimensions, but figures that occupy 3-dimensional space cannot. Suppose, however, that I begin to sketch a picture using colors instead of drawing in perspective or the like. That is, I copy colors. I supply images of colors. Anyone will admit that I am then incorporating space directly into the plane to form the image. At this point I may ask, does what expresses color in this image lie in any of the 3 dimensions of space? Is it possible to use colors to suggest something that can replace the 3 dimensions? Once we have an overview of the element of color, we can arrange colors in a specific way that creates an image of 3-dimensionality in 2 dimensions. Anyone can see that all blues tend to recede, while reds and yellows advance. Thus, simply by supplying color, we express 3 dimensions. By using the intensive aspect of color to express the extensive aspect of 3-dimensionality, we can compress 3-dimensionality into 2 dimensions. By linking other thoughts to this train of thought, we arrive at fluid geometry. And we may indeed be able to expand geometry to incorporate considerations such as this. In mathematics, we can construct congruent triangles A and B. But could we not also discover an expanded mathematical connection between red and blue triangles drawn in a plane? Is it really permissible for me to simply draw the simple lines that form a red triangle in the same way that I draw a blue triangle? Would I not have to state expressly that when I draw a red triangle and a blue one in the same plane, the red one would have to be small just because it is to represent red, while the blue one would have to be large simply because it is blue? Now the question arises, is it possible to incorporate an intensity factor into our geometry so that we can perform calculations with intensities? This would reveal the full significance of how our right and left eyes work together. Stereoscopic vision depends on both eyes working together. In the domain of optics, this phenomenon is the same as grasping my left hand with the right. A being that could never touch one part of its body with another would be physically incapable of conceiving of the I capital. This conception depends on being able to touch one part of my being with another. I can experience myself as an I in space only because of a phenomenon that is slightly hidden by ordinary empiricism, namely the fact that my right and left vision crosses. This fact, though it does not encompass the reality of the I, allows us to form a correct conception of the I. Now, imagine how our physical ability to conceive of the I would be affected if our eyes were strongly asymmetrical instead of more or less symmetrical. What if your left eye, for example, was significantly smaller than the right, making your left and right stereoscopic images very different? Your left eye would produce a smaller image that it would constantly attempt to enlarge, while your right eye would have to attempt the opposite, namely to reduce the size of its image. These efforts would add an enlivened form of vision to your static stereoscopic vision. Real enlivened vision, however, must be achieved as soon as you even begin to approach imaginative perception. This perception results from constantly having to adapt asymmetrical elements to each other. The central figure in the Dornach sculpture had to be depicted as strongly asymmetrical in order to show that it is ascending to the spirit. It also suggests that every aspect of the human being, for example our stereoscopic vision, is basically a state of balance that constantly deviates toward one or the other pole. We are human because we must continually create a state of balance between above and below, forward and back, and left and right. Questions and answers, Dornach, March 30th, 1920. Question: how will anthroposophy affect the further evolution of chemistry? Steiner's answer: assuming that we undertake the type of phenomenology described by Dr. Kalisko, this question is so all-encompassing that the answer can only be hinted at. First and foremost, we must realize that we would have to develop an appropriate phenomenology. Phenomenology is not simply an arbitrary assemblage of phenomena or experimental results. Real phenomenology is a systematization of phenomena, such as that attempted by Goethe in his theory of color. It derives the complicated from the simple, leading back to the foundations where the basic elements of phenomena appear. Of course, I am quite aware that some truly intelligent people will argue that a sophisticated presentation of the connection between qualitative phenomena and archetypal phenomena is not comparable to the way in which complicated geometric relationships are mathematically derived from axioms. This is because geometric relationships are systematized on the basis of intrinsic structure. We experience the further development of mathematics from these axioms as an inherently necessary continuation of the mathematical process, while, on the other hand, we must depend on observing a physical state of affairs when we systematize phenomena and archetypal phenomena. This argument, though it enjoys widespread support, is not valid and is simply the result of an incorrect epistemology, specifically a confused mingling of the concept of experience with other concepts. This confusion results in part from failure to consider that human subjects shape their own experience. It is impossible to develop a concept of experience without imagining the connection of an object to a human subject. Suppose I confront a Goethean archetypal image. When I make it more complicated, the result is a derivative phenomenon, and I seem to depend on outer experience to support my conclusion. Is there any difference in principle between this subject-object relationship and what happens when I demonstrate mathematically that the sum of the three angles in a triangle is 180 degrees, or when I prove the Pythagorean theorem empirically? Is there really any difference? In fact, there is no difference, as became evident from studies by very gifted 19th and 20th century mathematicians who realized that mathematics ultimately also rests on experience in the sense in which the so-called empirical sciences use the term. These mathematicians developed non-Euclidean geometries that initially merely supplemented Euclidean geometry. Theoretically, the geometric thought that the three angles of a triangle add up to 380 degrees is indeed possible, though admittedly we must presuppose that space has a different rate of curvature. Our ordinary space has regular Euclidean measurements, dimensions, and a rate of curvature of 0. Simply by imagining that space curves more, that is, that its rate of curvature is greater than 1, we arrive at statements such as the sum of the three angles of a triangle is greater than 180 degrees. Interesting experiments have been conducted in this field, such as those of Oscar Simony, who has studied the subject in greater detail. Such efforts show that from a certain perspective, it is already necessary to say that conclusions we state in mathematical or geometric theorems need empirical verification as much as any phenomenological conclusions. And that is the end of section 10, or lecture 10 as I've called it. You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at rudolfsteiner.podbean.com. Please consider becoming a patron. As well, there are two publishing houses, steinerbooks.org in America and rudolfsteinerpress.com in England, which are the sole publishers of Steiner into English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works, Volume 324A, by Rudolf Steiner, entitled The Fourth Dimension, translated by Catherine Creeger. This is section or lecture 11. It's a compilation of questions and answers concerning the fourth dimension. Questions and answers, Dornach, March 31st, 1920. Question. Ordinary mathematics encompasses the forms, surfaces, and lines of force of solids, liquids, and gases. How would you imagine a mathematics of the domains of warmth, chemistry, and life? Steiner's answer. First of all, the field of mathematics as such would need to be appropriately expanded if we want to describe higher realms in a way that is analogous, but no more than analogous, to mathematics. As you may know, the need to expand mathematics became evident already in the 19th century. Let me just mention a point I have discussed on other occasions, including yesterday, I believe. In the late 19th century, it became apparent that a non-Euclidean geometry was needed to supplement Euclidean geometry, and to make it possible to carry out calculations involving higher dimensions. Mathematicians of that time were suggesting that mathematics needed to be expanded. In contrast, as long as we are considering ordinary, ponderable matter, there is no appropriate use for dimensions other than the three ordinary Euclidean dimensions. Mathematicians today, however, are so disinclined to explore appropriate views of the domains of warmth, chemical effects, and the elements of life, that extending mathematical thinking into these areas is really very problematic. The views mathematicians propound today certainly do not create a counterbalance to the professed inability of physics to grasp the essential nature of matter. And to be consistent, physicists would have to admit that physics does not deal with the essential nature of light, but only with what Goethe calls the image of light. Of course, sensible physicists will refuse to delve into the essential nature of things in the pursuit of their profession. Admittedly, the result is an unfortunate state of affairs. Physicists refuse to deal with the essential nature of things on any level, and those who concoct philosophies from the conventional material views of physics not only refuse to inquire into the essential nature of things, but even claim that it is impossible to do so. As a result, our view of the earth today is very one-sided, because in fact physics is never simply a matter of geology, but deals with the sum total of what such a specialized field can yield for general knowledge. Thus we face the adverse consequences of the mechanistic, non-mathematical worldview that physics has developed over time. What Goethe meant when he said that we should not talk about the being or nature of light, but rather should attempt to become familiar with the facts about it, with its deeds and sufferings, which yield a complete description of the nature of light, is by no means the same as refusing on principle to consider the question of the nature of light. Goethe's statement simply points out that true phenomenology, structured in the way we discussed here yesterday, ultimately does provide an image of the being in question. To the extent that physics is or intends to be real phenomenology, it does provide, at least with respect to mechanics, an image of the essential nature of phenomena. It can be said, therefore, that when we are not dealing with merely mechanical aspects of the phenomena of physics, that is, when we are dealing with fields other than mechanics, a mechanistic view hinders our ability to recognize the essential nature of things. To this extent, then, we do need to emphasize the radical difference between Goethe's intended phenomenology, which can be cultivated in Goetheanism, and any system whose principles rule out the possibility of approaching the true nature of things. This has nothing to do with the advantages of mechanistic methods for our urge to control nature. It is quite understandable that the field of technology and mechanics, which has produced the greatest triumphs of the last few centuries, and its mechanistic basis for understanding nature, should satisfy our urge to control nature to a certain extent. But to what extent has this drive to understand and control nature fallen behind in other fields, because they refused to press on toward the type of knowledge to which technology aspired? The difference between technology or mechanics and the fields of study beginning with physics and continuing through chemistry to biology is not that these higher fields deal only with qualitative properties or the like. The difference is simply that mechanics and mechanistic physiology are very elementary and easy to grasp aspects, and have therefore managed to satisfy our desire for control, at least to a certain extent. At this point, however, the question arises: how do we satisfy our urge to control when we move on to higher, less mechanistic fields? In the future, we will have to count on being at least somewhat able to dominate nature in ways that go beyond mere technology. Even in the technological field, we can very easily experience failures to understand and control nature. If someone builds a bridge without adequate knowledge of the laws of mechanics that apply to railways, the bridge eventually will collapse, carrying the train with it. We react immediately to inadequate control due to faulty information. The proof is not always so easy, however, when control is based on more complicated domains that are derived not from mechanics, but from the process of developing a phenomenology. It is fairly safe to say that a bridge that collapses when the third train crosses it must have been built by someone inadequately motivated to understand the mechanics involved. In the case of a physician whose patient dies, it is not so easy to confirm a similar connection between the practitioner's desire to understand and his or her control over nature. It is easier for us to say that an engineer designed a faulty bridge than that a doctor cured the disease but killed the patient. In short, we should be somewhat less hasty to emphasize the importance of our urge to control nature simply because our mechanistic view of nature has proved capable of satisfying this urge only in the domain of mechanistic technology. Other ways of looking at nature will be able to very differently satisfy our urge to control. let me point again to something that I believe I mentioned yesterday from a different perspective. We can never bridge the gap between the mechanistic view of the world and the human being except by applying a true phenomenological approach. Goethe's color theory not only presents the physical and physiological phenomena of color, but also makes the whole subject humanly relevant by exploring the sensory and moral effects of color. In our spiritual scientific work, we can move from the effects of colors, pointed out by Goethe, to the broader subject of understanding the entire human being, and then to the still broader subject of understanding all of nature. In some ways, it may be beneficial to draw people's attention repeatedly to the fact that a large part of the decadence we experience today in Western culture is related to satisfying our urge to control only from the mechanistic perspective. In this regard, we have done very well. We not only have developed railways, telegraphs, and telephones, and even wireless and multiple telegraphy, but we also have paved over and destroyed large parts of this continent. Thoroughly satisfying our urge to control has led to destruction. Following the straight line of development that began with our purely technological urge to control has led to destruction. This destructive aspect will be eliminated completely when we replace our pathologically expanded mechanistic view of the phenomena of physics with a view that does not eradicate the specifics of physical phenomena simply by blanketing them in mechanistic ideas. We will move away from the mechanistic view, which admittedly has produced very good physiological explanations, to the specifics of the phenomena of physics. Our new view, which cannot be discussed down to its last consequences in 1 hour, also will lead to an expansion of mathematics that is based on reality. We must realize that in the past 30 to 50 years, confused mechanistic ideas have made possible all kinds of opinions about the so-called ether. After much effort, the physicist Planck, whom I mentioned earlier in a different context, arrived at this formulation. If we want to speak about the ether in physics at all, we cannot attribute any material properties to it. We must not imagine it in material terms. Planck forced physics to refrain from attributing material properties to the ether. The errors inherent in ideas and concepts about the ether are not due to having done too little mathematics or anything of that sort. They arose because proponents of the ether hypothesis were completely consumed by the trend that attempted to expand mathematics to cover the specifics of physics. Their mathematics was faulty because they behaved as if they were dealing with ponderable matter when they inserted numbers into formulas in which ether effects played a role. As soon as we realize that when we enter the domain of the ether, we can no longer insert ordinary numbers into mathematical formulas, we also will feel the need to look for a true extension of mathematics itself. There are only 2 points that need to be made in this regard. The physicist Planck says that if we want to talk about the ether in physics, we must at least refrain from attributing material properties to it. And Einstein's theory of relativity, or any other theory of relativity for that matter, forces us to eliminate the ether completely. In reality, we need not eliminate it. I can give only a brief indication here, but the main point is simply that when we shift to the ether, we must insert negative numbers into the formulas of physics, that is, mathematical formulas that are applied to phenomena in physics. These numbers must be negative, because when we move from positive matter through zero to the other side, as when we move from positive to negative numbers in formal physics, what we encounter in the ether is neither nothing, as Einstein believes, nor a pure negative, as Planck says, but something that we must imagine as possessing properties that are the opposites of the properties of matter, just as negative numbers are the opposite of positive numbers. Although we may debate what negative numbers are, the purely mathematical extension of the number line into negative numbers becomes significant for reality, even before we clearly understand the character of negative numbers. Of course, I am well aware of the significant mathematical debate in the 19th century between those who saw qualitative aspects in plus and minus signs, and those who saw the minus sign only as a subtrahend, lacking a negative minuend. This debate is not especially important, but it is important to note that when physics shifts from ponderable effects to etheric effects, it is forced to take the same route that we take in formal mathematics when we move from positive to negative numbers. We should check the results of the formulas when we decide to handle the numbers in this way. Much good work has been done in formal mathematics to justify the concept of formal imaginary numbers. In physics, too, we are obliged at a certain point to substitute imaginary numbers for positive and negative numbers. At this point, we begin to interact with numbers relevant to nature. I know that I have sketched all this very briefly and summed it up in only a few words, but I must make you aware of the possibilities. As we move from ponderable matter to the forces of life, we must insert negative numbers into our formulas to signify the inverse of the quantitative aspect of matter. And as soon as we transcend life, we must shift from negative numbers to imaginary numbers, which are not mere formal numbers, but numbers with properties derived not from positive or negative matter, but from the substantial aspect that is related, qualitatively and intrinsically, to both the etheric aspect, or negative matter, and the ponderable aspect, or positive matter, in the same way that the imaginary number line relates to the real number line of positive and negative numbers. Thus there is indeed a connection between formal mathematics and certain domains of reality. It would be highly regrettable if attempts to make our ideas approximate reality or to immerse our ideas in reality were to fail because of the trivial notion that the offerings of truly rational, rather than merely mechanistic, physics and physiology would be less effective in satisfying the human urge to control nature. In fact, they would be more effective than applying the mechanistic worldview to the technology that we have glorified to such an extent. This mechanistic technology has certainly produced great results for humanity's cultural development. But people who constantly talk about the glorious progress of the natural sciences as a result of the conventional calculations of physics should keep in mind that other areas may have suffered as a result of turning our attention totally to the technological domain. To escape from the decadence brought on by our merely technical understanding and control of nature, we would do well to turn to a physiology and physics that, unlike our mechanical and mechanistic knowledge, cannot refuse to acknowledge the essential nature of things. You see, this mechanical domain can easily dismiss the essential nature of things, precisely because this essential nature is available, spread out in space all around us. It is somewhat more difficult for the entire field of physics to progress in the way that the field of mechanics has progressed. This is the reason for all of this talk of refusing to acknowledge the essential nature of things. When physicists choose to think in purely mechanical terms, they can easily refuse to understand beings. There is no being behind the formulas that are used today to express mechanics in mathematical terms. Beings begin only when we no longer simply apply these formulas, but delve into the essential nature of mathematics itself. I hope this addresses the question of how to extend the field of mathematics to cover imponderables. Questions and answers. Dornach, October 15, 1920. A question about Copernicus's third law. It is impossible to speak about Copernicus's third law in such a short time, so let me simply comment on its history. If you look at Copernicus's basic work, which severely shook the old Ptolemaic system and revolutionized our view of the heavenly bodies, you will find that it encompasses 3 laws. The first of these 3 laws speaks about Earth's annual movement around the Sun in an eccentric circle. The second about the Earth's rotation around its axis, and the third about the Earth's movement around the Sun in relationship to the seasons and precession. As astronomy progressed, it failed to consider this third Copernican law in its entirety. In fact, Copernicus's successors effectively eliminated it. That is all I can say about this law without doing extensive drawings, which would keep us here until midnight. On the basis of the phenomena available to him, Copernicus first calculated the daily changes caused by the Earth's circular movement around the Sun, disregarding the seasonal, yearly, and longer-term changes encompassed by his third law. He then concluded that if we consider the daily changes, and those dependent on the Earth's circular movement around the Sun in the Earth's position with regard to the other heavenly bodies, the result is a view of the Earth revolving around the Sun. This view is opposed by other phenomena, such as the seasons and precession, which actually nullify the assumption that the Earth revolves around the Sun. For the sake of being able to quantify and calculate the interactions between the Earth and the other heavenly bodies, we make it easy for ourselves and disregard any changes that can be observed only over a year or over centuries, because these changes complicate the daily changes that depend on the Earth's circular movement around the Sun. Calculating the daily changes on the basis of the assumptions expressed by Copernicus in his first and second law results in the Earth's yearly revolution around the Sun. As Copernicus himself said, if we include the third law in our calculations, it counteracts the factor contained in the first law, which we calculated into the daily movement and which yields the Earth's yearly movement, and almost eliminates any such yearly movement. In any case, the third Copernican law has been disregarded. People preferred the easy assumption that the Earth rotates around its axis in 24 hours, progressing all the while so as to move around the Sun in the course of 1 year. This solution was simple, as long as we clung dogmatically to the Copernican assumption that the Sun does not move at all. We were forced to abandon this assumption a long time ago, however, and the third Copernican law had to be reinstated. I can summarize this subject only briefly. As I said, a detailed mathematical and geometric explanation would take hours. But if we take the third Copernican law seriously, it does not result in movement of the Earth around the Sun. The Sun moves. It would outrun the Earth if the Earth simply revolved around the Sun. The Earth cannot revolve around the Sun because meanwhile the Sun would move away from it. In reality, the Sun moves on, and the Earth and the other planets follow it. We have a line, like the thread of a screw, with the Sun at one point and the Earth at the other end. Our dual focus on the Earth and Sun, and on their progressive screw-like movement, creates the illusion that the Earth is revolving around the Sun. The interesting point in all this is that Copernicus was more advanced than we are today. We have simply omitted his third law from astronomy's post-Copernican development. Our astronomy has been developed without this third law, which states that other phenomena negate the yearly movements around the Sun that we calculate for the Earth. To do full justice to Copernicus, this law must be reintroduced. This subject does not attract much interest. because if we were to apply a true phenomenological approach to astronomy, we would have to realize first and foremost that, as Dr. Freda already mentioned, we are dealing with extremely complicated movements, and that the ordinary geometrical constructions we use in attempting to describe these movements are suited only to descriptions of simple geometrical processes. Because the heavenly bodies do not obey such simple processes, disturbances always appear, and we are forced to compensate by adding more hypotheses. When we get beyond such hypotheses, astronomy will look completely different. This will happen only when we progress to a form of natural science that truly includes the human being and observes phenomena within the human being. Taking these phenomena into account will allow us to develop a view of the events and processes of cosmic space. As Dr. Unger also mentioned, the human being actually has been ousted from today's science, which disregards the human element. Ideas such as the theory of relativity, which certainly do not correspond to reality, are able to take hold only because modern science is so utterly estranged from reality that it deals with everything outside human beings, but nothing that happens inside them. To think in ways that correspond to reality is a skill that humanity will have to relearn. If you have a stone lying here, reference to a drawing that has not been preserved, you will see it as leading an independent existence, at least to a certain extent. It all depends on your presuppositions. We can say that when we consider what we see within the boundaries of the stone, we develop a certain view of the stone. But now assume that instead of a stone, we are considering a rose that I have picked. It is not possible to ascribe reality to the rose in the same way that we ascribed reality to the stone within its boundaries, because a plucked rose cannot exist in isolation. It must develop in connection with something else. We are forced to say that while the stone within its described limits possesses a certain real existence, the rose does not, because it can exist only in association with its root stock. If I separate it from its roots, the prerequisites for its existence are no longer present, and it cannot persist. We must relearn the skill of submerging our thinking in things and taking the things themselves into account. Only when we have acquired this skill will we have a healthy form of astronomy, for example, as a matter of course. We will be spared the terrible abstraction of such ideas as the theory of relativity. Essentially, the theory of relativity is based on ideas that are not true realities. The ordinary formula S equals v times t, parenthesis distance equals speed multiplied by time, close parenthesis, is quite illuminating. When I am describing a reality, I can write only this: v equals s over t. Speed multiplied equals distance divided by time. When we grasp a reality by means of abstraction, I can calculate everything that is in a real object. Because it is possible to grasp many different things on an abstract level, we can perform many different calculations, while remaining within the abstract. We must not believe, however, that these abstractions are realities. In the inorganic world, only speeds are realities, and both time and space are mere abstractions. Thus, when we begin to perform calculations involving time and space, we enter the domain of unreality. And once we begin thinking in unreal terms, we can no longer return to reality. These issues, therefore, are related to very significant shortcomings of our times. In recent times, humankind has disregarded the spirit completely, while attempting to understand nature, and our souls have moved toward abstractions. In one sense, dealing with abstractions is extremely comfortable. because we do not need to learn to submerge ourselves in objects and events. It is easier to think in terms of space and time than to immerse ourselves in qualitative aspects, or to realize that whatever we can think of as real in connection with something else can therefore be thought about in real terms. Editor's note, not abstractly. You need not believe what I am about to say, but it is true nonetheless. It is a torture for a person who has cultivated a capacity for thinking and a desire to understand reality to read Einstein's theory of relativity. Because even though all the ideas Einstein presents are mathematically very consistent, they are literally unthinkable for someone with any sense of reality. It is impossible to pursue such thoughts to their conclusion. What does it mean, and what kind of sense does it make, when Einstein presents a whole complex of thoughts about someone who is sealed up in a box and journeys through space at high speed and returns to find a new generation of people in totally different circumstances? When we think about such a situation, of course we are thinking only in terms of space and time, and disregarding the outer bodily nature of the person or object, which would be destroyed while undergoing the experiment. Although this objection may seem naive to fanatical thinkers on the subject of relativity, it inevitably comes into consideration with regard to reality. Anyone who has a sense for reality cannot see such thoughts through to the end. Suppose that we are traveling in a car, for example, and have a flat tire. Let's assume that it makes no difference whether I think that the car, with me in it, is speeding over the ground, or that the car is standing still while the ground moves out from under me. If in fact it makes no difference, why should the ground suddenly go on strike because of a minor breakdown that concerns only the car? If it makes no difference how we conceive of the situation, the outcome should not be affected by the outer change. As I said before, although such objections are terribly naive as far as relativity theorists are concerned, they do reflect current realities. Anyone whose thinking is grounded in reality rather than in abstraction, even an abstraction that can sustain consistent thoughts, is forced to point out such issues. Fundamentally, therefore, we are living with a theoretical form of astronomy. A classic example is our disregard of the third Copernican law. We push it aside because it is uncomfortable. When we study it, we learn to feel uncomfortable about our customary calculations. What do? We apply the second Copernican law, but our calculations do not come out even, and noon falls in the wrong place. So we introduce the daily corrections known as Bessel's corrections. If we realize their full implications, however, we see the need to take the third Copernican law into account. That is, we begin to deal with realities. The point here is to acknowledge the principles behind such issues. The way we presently deal with such principles permits us to go astray in many different directions. Mr. Stephan did an excellent job of presenting three such tortuous paths in a specific field of knowledge. Such misleading paths are easy to encounter today, and they influence real life. We have trained ourselves to think in ways derived from a mathematics that lacks reality, and this type of thinking gradually has become almost a touchstone of genius. In fact, a sense of reality is sometimes much more helpful than genius, because if you have a sense of reality, you must abide by the realities of the situation. You must immerse yourself in objects and events and live with them. If you have no sense of reality, you can impose all sorts of abstractions onto space and time in the most ingenious way, simply by manipulating mathematical formulas and methods. You can rise to truly terrible levels of abstraction. These abstractions sometimes can be very seductive. I am thinking of modern set theory, which has been used as the basis for explaining infinity. Set theory dissolves number, the very principle of mathematics, because it no longer sees a number as an ordinary number, but merely compares one arbitrary set with another classifying individual entities with no regard to their qualities and essence. Set theory makes it possible to develop certain theories of infinity, but swimming in abstractions all the while. In concrete reality, it is impossible to perform such operations. It is important to note that we gradually have become accustomed to disregarding the need to immerse ourselves in reality. In this connection, spiritual science really needs to set the record straight. I am now going to present two opposites. This appears to have nothing to do with theory, but in truth it has a great deal to do with theory, because all of these matters deal with much more than a theory, which can be corrected if our thinking about it is sound. The real issue is the need to develop sound thinking, thinking that is not merely logical, because logic also applies to mathematics. We can incorporate logic into mathematics, and the result is a completely coherent structure that nonetheless need not apply to reality at all. By now we have reached the point of being able to show how things look to an undisciplined way of thinking that lacks any true sense of reality. Here you have on the one hand a book that attempts to summarize everything that modern science has to offer. Thousands and thousands of copies, 70 or 80,000, I believe, of this famous book have already been sold. It is Oswald Spengler's book titled The Decline of the West. As you know, this means that 4 or 5 times that number of people have read the book. So we know what a tremendous influence it has had on modern thought, simply because it emerged from modern thought, in a certain sense. The author of this book had the courage to formulate the ultimate consequences of modern thinking. In this book, Spengler looks at everything that astronomy, history, the natural sciences, and art have to offer, and we are forced to admit that he has amassed a huge body of evidence. Because Spengler really thinks in this way, he has the courage to draw the ultimate conclusions from the thinking of truly modern astronomers, botanists, art historians, and so on. As clearly as we can prove the second law of thermodynamics, for example, Spengler's book also proves that in the beginning of the third millennium, Western civilization will have degenerated into complete barbarity. We must admit that this book not only has shown us the decline of modern civilization, but also has proved a future event as clearly as any scientific statement can be proved today. In terms of the methods of modern science, Spengler's proof of the decline of the West is certainly as good as any astronomical proof or the like, and much better than any proof of the theory of relativity. His conclusions can be circumvented only by those who see factors that Spengler himself does not see, namely by those who will provide completely new impulses for humanity from now on. Impulses that must be born out of the inmost core of the human being, and that are invisible to any science based solely on contemporary thought. But what is Spengler's thinking like? Unlike the relativity theorists, Oswald Spengler thinks in categories that correspond to reality. Not everything he thinks fits together, however. The concepts he develops about astronomy, biology, art history, architecture, sculpture, and so on do not always mesh. They form a structure that I would like to compare to crystals that have grown together. They are all confused, and they destroy each other. If we maintain a sense of reality while reading Spengler's book, we find that his concepts are very full, reference to a drawing that has not been preserved. Oswald Spengler certainly knows how to think and develop concepts, but his concepts destroy each other. They blow each other up and cut each other apart. Nothing remains whole because one concept always negates another. We see terrible destructive actions when we apply a sense of reality to the development of Spengler's ideas. Spengler represents one pole in modern thought, the pole that constructs a unity out of concepts drawn from all different fields. The philosophers associated with this trend neatly defined everything on such an abstract level that all of the concepts they derive from individual sciences can be gathered together and united into a system of sorts, in an attempt to come to a point. They fail to come to a point, however, but simply splinter and obliterate each other. Spengler is a much better philosopher of modern science than many other philosophers, whose concepts do not destroy each other because their formulators lack the courage to define them precisely enough. In their philosophies of science, these other philosophers always confusing tiger claws with cat paws, as it were, resulting in comical constructs that are said to be the philosophical consequences of individual scientific investigations. If we consider these philosophers seriously, we see that Spengler is experienced in all the sciences and knowledgeable about anything scientific that can result from the customs of philosophy. The other pole is represented by a philosopher who is also popular, though not revered to the extent that Spengler is, namely Count Hermann Keyserling. Keyserling differs from Oswald Spengler in that none of his concepts have any content. While Spengler's concepts are meaty, Keyserling's are empty. They never contradict each other, because they are basically only empty husks of words. Keyserling's only thought, which is also an empty husk, is that the spirit must unite with the soul. Count Keyserling attacks anthroposophy vehemently. In the periodical title Zukunft, for example, he accused me of splitting the human being into various members, ether bodies, sentient soul, and so on, while in fact the human being is a unity and functions as such. The thought that the spirit must unite with the soul seems fiendishly clever, but in fact it is no more clever than saying that a suit is a unity and should not be broken down into component parts such as a vest, a pair of pants, boots, and so on. It's all a unity, so I should not have the tailor make the jacket and pants separately and then go to the cobbler for boots to match. Of course, all of these things form a unity on the human being who is wearing them. But it makes no sense to say that jacket and pants, and probably the boots as well, should be stitched together into a single article of clothing, even if Count Keyserling, in his abstract idealism, insists that they are a unity. This is the opposite pole. We have on the one hand Spengler with his concepts that destroy each other, and on the other hand we have Keyserling with his totally empty concepts. For anyone who has any sense of reality, it is a torment to read Spengler, and to see all his concepts colliding with and crushing each other and forcing their way into each other. You really are compelled to experience all this, especially if you have any artistic sensibility. Spengler's book is a totally inartistic construct. But when you read Keyserling's book, you stop and gasp for breath after one page, because his concepts have no air in them. We want to form a thought, but there is nothing there, which makes it very easy for people to understand these concepts and feel comfortable with them. This is especially true if this impotent non-thinker also tells them that while there may be some truth to the facts that spiritual science confirms, he himself cannot corroborate them, and therefore will not assume that they are true, since he is not one of those people who has intuitions, and so on, and so forth. Of course, people lap up this kind of talk, especially if they themselves cannot supply the necessary proof. Especially today, such people much prefer a writer who admits to being unable to confirm the facts to one they have to struggle to keep up with. Keyserling's scribblings, on art in particular, are enough to make your hair stand on end, but they are very popular. That is all I have to say on this subject. By now you may have developed a sense for what it means when Goethe says, quote, "Consider the what, but consider how more seriously." Close quote. You can consider the what when you read Spengler, because he has a lot of what to offer. But Goethe knew that a worldview depends on how we see the whole in the coordination, organization, and inherent harmony of ideas. That is why we can say, referring to Spengler, consider the what. Spengler does consider the what as it should be considered, but he fails to consider the how at all. Above all else, Goethe challenges us to consider how ideas are arranged. With regard to Keyserling, we might say that he appears to possess the how. In fact, his work is teeming with how, but there is no what, no content. The end of section 11. You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at rudolfsteiner.podbean.com. Please consider becoming a patron. As well, there are two publishing houses, steinerbooks.org in America and rudolfsteinerpress.com in England, which are the sole publishers of Steiner into English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works, Volume 324A by Rudolf Steiner, entitled The Fourth Dimension. This is the Section 12, or Lecture 12, collections of questions and answers around the fourth dimension. Translated by Catherine Creeger. Questions and Answers, Stuttgart, January 15, 1921. A question about the need for the anthroposophical position on the Einstein problem. Why must we suddenly reverse the sign when we leave the realm of the tangible for the ether? Steiner's answer. Of course, this also can be done without taking a specifically anthroposophical position, simply by studying the phenomena, as is done in many other scientific fields. I illustrated an unbiased view of the phenomena of so-called heat theory in a course I gave to a small audience here a few months ago. We then must attempt to express this phenomena in mathematical formulas. The peculiar feature of such formulas is that they are correct only when they correspond to processes we can observe. That is, when the results of the formulas correspond to and can be verified by reality. If you want to understand what happens when a gas contained under pressure is heated, it is artificial to apply the formulas worked out by Clausius and others, although it can be done. As is officially admitted today, however, that the facts do not correspond to the formulas. In connection with Einstein's theory, it is strange to note the experiments that have been conducted. These experiments were set up on the supposition that a certain theory was correct. Because the experiments did not confirm the theory, another theory, based exclusively on experiments that exist only in thought, was then developed. In contrast, if you attempt to deal with the heat phenomena by simply inserting the relevant positive and negative signs into the formulas, depending on whether you are dealing with conductive or radiant heat, you will find that reality confirms the formulas. Admittedly, when we move on to other imponderables, simply changing the sign to negative is not enough, and we must include other considerations. We must imagine that forces in the tangible realm work radially, while those belonging to the etheric realm come from the periphery, have negative values, and work only within a circular area. Thus, when we move on to other imponderables, we must insert the corresponding values differently. We then will find that we arrive at formulas that are verified by actual phenomena. Anyone can take this approach, with or without becoming involved in anthroposophy. I would like to emphasize a different point here. You must not think that what I told you in these 4 lectures simply stems from my anthroposophical approach. I have told you these things because they are true. The so-called anthroposophical approach does not anticipate phenomena. It results from them. It is simply the consequence of an appropriate overview. If we attempt to recognize and understand objects and events without bias, an anthroposophical approach can result. The prospects for what I have told you would be poor if we had to take a biased view as our starting point, but that is not the case. we must pursue the relevant phenomena on a strictly empirical basis. Although I still maintain that the anthroposophical approach can be the best approach, it is only the end result. After answering other questions, Rudolf Steiner says in conclusion, I can emphasize repeatedly only that the anthroposophically oriented spiritual science that is developing here in Stuttgart is not a sectarian or amateurish movement. Although its forces are still weak, it is striving for real, authentic science. The more you test spiritual science, the more you will realize that it is a match for any scientific method of testing. The many misunderstandings to which spiritual science is subject today are not the results of a truly scientific approach. The opponents of spiritual science battle it not because they themselves are too scientific, but because they are not scientific enough, as further investigation will show. In future, however, we must become more scientific, rather than less so. Science must make real progress. Namely, it must lead us into the spiritual realm as accurately as it leads us into the material realm. Questions and Answers, Dornach, April 7th, 1921. Question. It has been said that the three dimensions of space differ in structure. Where does this difference lie? Rudolf Steiner replies, this statement was never formulated like that. Quote, the three dimensions of space differ in structure, close quote. You are probably referring to the following thought. First, we have mathematical space, which we imagine, if indeed we imagine it with any precision at all, as consisting of three perpendicular dimensions or directions, which we define by means of a coordinate system on three perpendicular axes. When we consider this space from the usual mathematical perspective, we treat the three dimensions as if they were exactly the same. We make so little distinction between the dimensions of up and down, right and left, and forward and backward, that we even can believe them to be interchangeable. In terms of merely mathematical space, it ultimately makes no difference whether we say that the plane of the y-axis, which is perpendicular to the plane formed by the x and z axes, which are also perpendicular to each other, is, in quotes, horizontal or, in quotes, vertical. We are equally unconcerned about the boundedness of this type of space, which does not mean that we ordinarily get so far as to imagine it as limitless. We simply do not worry about its limits. We assume that from any point on the x-axis, for example, we can continue to move along the axis indefinitely without ever reaching the end. During the 19th century, meta-geometry presented many ideas contrary to this Euclidean concept of space. Let me simply remind you, for example, how Riemann distinguished between the limitlessness of space and the infinity of space. From the perspective of purely conceptual thinking, too, there is no need to assume that limitlessness and infinity are identical. Take the outer surface of a sphere, for instance. When you draw on such a surface, you never encounter any spatial limit that prevents you from continuing your drawing. Eventually, of course, you will intersect your previous drawing, but as long as you remain on the sphere's surface, you will never encounter a boundary that forces you to stop. Thus you can say that a sphere's surface is limitless with regard to your ability to draw on it. This does not mean, however, that anyone claims that such a surface is infinite. In this way, on a purely conceptual level, we can distinguish between limitlessness and infinity. Under specific mathematical conditions, this distinction also can be extended to space as a whole. If we imagine that we never will be hindered from extending an x or y axis by continuing to add segments to it, this property of space speaks for its limitlessness, but not for its infinity. The fact that I can continue adding segments indefinitely does not mean that space is necessarily infinite. It might be simply limitless. We must distinguish between these two concepts. If space is limitless but not infinite, we can assume that it is inherently curved and returns to its starting point in some way, just as a spherical surface does. Certain ideas in modern metageometry depend on such assumptions. It is not easy to raise objections to these assumptions, because we cannot conclude that space is infinite from our experience of it. It equally well could be curved and finite. I cannot carry this train of thought to its conclusion, of course, without explaining almost all of recent metageometry. Treatises by Riemann, Gauss, and others are readily available, however, and will provide you with plenty of food for thought if you are interested in mathematical ideas of this sort. These are the purely mathematical arguments against the fixed, neutral space of Euclidean geometry. All of the arguments I have mentioned so far are based purely on the concept of limitlessness. Your question, however, is rooted elsewhere in the idea that space, the space of our calculations, and the space we encounter in analytical geometry, for example, when we are dealing with a coordinate system of three perpendicular axes, is an abstraction. And what is an abstraction? This question must be answered first. It is important to know whether we are restricted to an abstract idea of space. Is abstract space the only space we can talk about? To put it better, if this abstract concept of space is the only one we are justified in speaking of, only one objection is possible, and this one objection has been raised adequately by Riemann's geometry or other forms of metageometry. Kant's definitions of space, for example, rest soundly on a very abstract concept of space. His concept is initially unconcerned with limitlessness or infinity. In the course of the 19th century, this concept of space was shattered, also internally, with regard to its conceptual content, by mathematics. It is impossible to imagine applying Kant's definition to a space that is limitless but not infinite. Much of what Kant presents later in his titled Critique of Pure Reason, his theory of paralogisms, for example, would begin to totter if we were forced to substitute the concept of a limitless curved space. I know that this concept of curved space poses problems for our ordinary way of imagining things. But from the purely mathematical or geometric perspective, the only possible argument against the assumption that space is curved is that it forces us to move into a realm of pure abstraction that is initially quite remote from reality. Looking at the situation more closely, we discover that a curious circular argument exists in the derivations of modern metageometry, namely that we arrive at them by taking as our starting point the ideas of Euclidean geometry, which is unconcerned with any limitations of space. We then move on to certain derivative ideas, such as those that apply to the surface of a sphere. On the basis of these derivatives and the forms that result, we can undertake certain transpositions and then make reinterpretations of space. Everything we say, however, presupposes Euclidean coordinate geometry. Under this presupposition, we get a specific rate of curvature. We arrive at the derivations. All this calculation presupposes Euclidean geometry. Here we come to a turning point, however. We use ideas such as the rate of curvature, which we developed only with the help of Euclidean geometry, to arrive at another idea that can lead to a new view and an interpretation of what we have gained from the curved forms. Essentially, we are functioning in a realm remote from reality by deriving abstractions from abstractions. This activity is justified only when an empirical reality forces us to align ourselves with the results of such abstractions. Thus the question is, where does abstract space correspond to our experience? Space as such as Euclid imagined it is an abstraction. Where does its perceptible empirical aspect lie? We must take our human experience of space as our starting point. We actually perceive only one dimension of space, namely the dimension of depth, as a result of our own active experience. This active perception of depth is based on a process in our consciousness that we very frequently overlook. This active perception, however, is very different from the idea of a plane, of extension in two dimensions. When we look out into the world with both eyes, these two dimensions are not the result of our own soul activity. They are there as givens, while the third dimension comes about as a result of activity that usually does not become conscious. We need to work at recognizing depths, at knowing how distant an object is from us. We do not work out the extent of a plane. Direct perception provides us with that knowledge. We do, however, use both eyes to work out the dimension of depth. The way we experience depth lies very close to the boundary between the conscious and the unconscious. But when we learn to pay attention to such processes, we know that the never fully conscious activity of estimating depth, it is at most semi-conscious or one-third conscious, more closely approximates a rational activity, an active soul process, than does seeing objects only in a plane. In this way, we actively acquire one dimension of three-dimensional space on behalf of our objective consciousness. And we are forced to say that our upright position contributes a quality to the dimension of depth, that is, forward and backward, that makes it non-interchangeable with any other dimension. The fact that we stand there actively experiencing this dimension makes it non-interchangeable with any other dimension. For the individual human being, the dimension of depth is not interchangeable with the other dimensions. It is also true that our perception of two-dimensionality, that is, of up and down and right and left, even when these two dimensions are in front of us, is associated with different parts of the brain. This perception is inherent in the sensory process of seeing, while the third dimension arises for us in parts of the brain located very close to the centers associated with rational activity. Thus we see that even in terms of our experience, the third dimension arises in a way that is different from the other two dimensions. When we rise to the level of imagination, however, we leave our experience of the third dimension behind and see in two dimensions. At this level, we must work to experience right and left, just as experiencing forward and backward in our ordinary consciousness requires work of which we are not fully aware. And finally, when we rise to the level of inspiration, the same is true of the dimension of above and below. As far as our ordinary nerve-related perception is concerned, we must work to experience the third dimension. When we exclude the ordinary activity of this system, however, and turn directly to the rhythmic system, we experience the second dimension. In a certain respect, this is what happens when we rise to the level of imagination. I have not expressed this very precisely, but it will do for now. And we experience the first dimension when we rise to the level of inspiration, that is, to the third member of our human organization. What we encounter in abstract space proves to be exactly what it appears to be, because all of our mathematical accomplishments come from within ourselves. The mathematical consequence, threefold space, is something we derive from ourselves. When we move down through the levels of suprasensible perception, the result is not abstract space with three equivalent directions, but rather three different values for the three different dimensions of forward and backward, right and left, and above and below. these dimensions are not interchangeable. We can then conclude that we also need not imagine the three dimensions as having the same intensity, which is essentially how we imagine the x, y, and z axes in Euclidean space. If we want to abide by the equations of analytical geometry, we must see the x, y, and z axes as equivalent in intensity. If we make the x-axis larger, stretching it with a certain intensity as if it were elastic, the y and z axes must grow with the same intensity. In other words, when I apply a certain intensity to expanding one dimension, the force of expansion must be the same for all three axes, that is, all three dimensions of Euclidean space. That is why I would like to call this type of space, in quotes, fixed space. Fixed space is an abstraction of real space, which is developed from within the human being, and the principle of equivalent intensity does not apply to real space. When we consider real space, we can no longer say that the intensity of expansion is the same for all three dimensions. Instead, it depends on human proportions, which are the result of spatial expansion intensities. For example, take the y-axis, the up-down direction. We must imagine its expansion intensity as greater than that of the x-axis, which corresponds to the left-right direction. The formula that is an abstract expression of real space, we must be aware that this formula too is an abstraction, describes an ellipsoid with three axes. Suprasensible perception dwells within the three very different expansion possibilities of this triaxial space. Our physical body provides direct experience of the three axes, and such experience tells us that this space also expresses the relationships among the effects of the heavenly bodies within it. Visualizing space in this way, we must also consider that everything we think of as existing in the three-dimensional universe cannot be accounted for if the expansion intensity of the x, y, and z axes is the same, as is the case in Euclidean space. We must imagine the universe with a configuration of its own, corresponding to an ellipsoid with three axes. The configuration of certain stars suggests that this idea is correct. For example, we usually say that our Milky Way galaxy is lens-shaped, and so on. We cannot possibly imagine it as a sphere. We must find a different way of imagining it if we want to accommodate the facts of physics. The way we treat space demonstrates how poorly modern thinking coincides with nature. In ancient times and cultures, the concept of fixed space did not occur to anyone. We cannot even say that the original Euclidean geometry incorporated a clear idea of fixed space with three equal expansion intensities and three perpendicular lines. It was only in fairly recent times, when abstraction became an essential attribute of our thinking and we began to apply calculations to Euclidean space, that the abstract concept of space emerged. The knowledge available to people in ancient times was very similar to what can be redeveloped now on the basis of suprasensible insights. As you see, concepts that we depend on heavily and take for granted today assume a high degree of importance only because they work in a sphere that is foreign to reality. The space we reckon with today is one such abstraction. It is far removed from anything real experience can teach us. We are often content with abstractions today. We harp on empiricism, but we refer very frequently to abstractions without even being aware of doing so. We believe that we are dealing with real things in the real world. You can see, however, how badly our ideas need correction in this respect. Spiritual researchers do not simply ask if every idea they encounter is logical. Raymond's concept of space is thoroughly logical, though in a certain respect it depends on Euclidean space. It cannot be thought through to its conclusion, however, because we approach it by means of highly abstract thinking. And in this process our thinking is turned upside down because of one of the conclusions we draw. Spiritual researchers do not simply ask whether an idea is logical. They also ask whether it corresponds to reality. For them, that is the decisive factor in accepting or rejecting an idea. They accept an idea only if it corresponds to reality. Correspondence to reality will apply as a criterion when we begin to deal appropriately with such ideas as the justification of the theory of relativity. In itself, this theory is as logical as it can possibly be, because it is understood purely in the domain of logical abstractions. Nothing can be more logical than the theory of relativity. The other question, however, is whether we can act on it. If you simply look at the analogies presented in support of this theory, you will discover that they are very foreign to reality. They are simply ideas being tossed around. The proponents of relativity theory tell us that these ideas are there only as symbols to help us visualize the issues. They are not merely symbols, however. Without them, the entire process would be left hanging in the air. This, then, is what I wanted to say in reference to your question. As you see, there is no easy answer to questions that touch on such domains. Questions and Answers, Dornoch, August 26, 1921. Question: Are we meant to understand that the sun moves through space in a spiral, and that the earth also moves in a spiral as it follows the sun, and therefore does not revolve around the sun? Steiner's reply: In a longer lecture series, it would be relatively easy to discuss these issues in more detail. I have referred to them only briefly here. It is almost impossible to explain their foundations in a few words. Let me begin to respond to your question by simply summarizing the results of spiritual scientific research. First of all, any conclusions we draw about spatial relationships in the universe on the basis of observation and from specific perspectives are always one-sided. The Ptolemaic solar system represented a one-sided view, and so do all other models of the solar system, including the Copernican model. Our conclusions about the relationships of moving objects are based on our specific vantage point, and these relationships are invariably supplemented or altered by movements that cannot be measured from that perspective. Having stated this cautious presupposition, I ask you to consider another spiritual scientific finding that will help us develop a view of the relationship of the Earth's movement to that of the Sun. We must imagine that the Sun moves through space on a curved path. If we trace this curve far enough, it proves to be a complicated spiral form. A simplified version looks like this, figure 65a. The Earth moves along the same path, following the Sun. When you consider the Earth's possible locations in relationship to the Sun, you discover that when the Earth is here, an observer would have to look to the right to see the Sun. See figure 65b. Now let me sketch another possible location. The arrow indicates the direction of view. In the first instance, we saw the Sun by looking in one direction, and now we see it by looking in the opposite direction. As you will easily understand if you visualize this model correctly, the consequence of the Earth following the Sun is that we see the Sun first from one side and then from the other, and the Earth appears to move around the Sun in a circular or elliptical orbit. The primary component of this movement, the fact that the Earth follows the Sun, is differentiated still further by certain other relationships that would take hours to explain. The truth of the matter, however, is that only our direction of view rotates. As I said, this summary represents the results of lengthy spiritual scientific investigations and is complicated even more when we take other relationships into account. We must realize that as we gain a better overview of the sun's movements, the simple lines we use to describe the Copernican system to school children become increasingly complex, until ultimately they can no longer be drawn at all and fall out of the spatial realm altogether. This is what I wanted to say from the perspective of spiritual science. From the perspective of the history of the physical sciences, I would like to comment that what we find so striking today about the research results I outlined above is inherent in the Copernican view. Copernicus postulated 3 laws. The first states that the Earth rotates around its own axis, the second that the Earth revolves around the Sun, and the third that the Earth's movement around the Sun provides only a provisional explanation on the conceptual level, while in fact the Earth stands in a fixed relationship to the Sun. This third law proves that Copernicus was truly convinced that the second movement he describes, the Earth's revolution around the Sun, was merely a convention assumed for the convenience of certain calculations, and that he did not intend to state it as a fact. Today we consistently disregard this third law and believe that the Copernican model of the solar system encompasses only the first 2 laws. If we were truly to study the entire Copernican view, however, we would quickly conclude that this third law is indeed necessary, simply on the basis of astronomical calculations. You see what often happens in the history of science. And that's the end of section 12. You are listening to RudolfSteinerAudio.com. If you are listening to the podcast of this, it is located at RudolfSteiner.podbean.com. Please consider becoming a patron. As well, there are 2 publishing houses, SteinerBooks.org in America and RudolfSteinerPress.com in England, which are the sole publishers of Steiner into English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works, Volume 324A by Rudolf Steiner, entitled The Fourth Dimension, Sacred Geometry, Alchemy, and Mathematics, translated by Catherine Creeger. This is the last section or lecture. I've been calling them sections 13 of the book. Questions and Answers. The Hague, April 12, 1922. Question about higher dimensional space. Steiner's reply. We can say that the ordinary axial coordinate system describes 3-dimensional space. Schematically speaking, we can proceed on the basis of certain algebraic assumptions, and on an abstract level repeat the process that led us from a plane to 3-dimensional space. The result is 4, 5, or n-dimensional space. We can even construct figures such as Hinton's tesseract. The tesseract, however, is not a real figure, but simply the projection of a true tesseract into 3-dimensional space. On a purely theoretical and abstract level, there is nothing wrong with such deductions. On a theoretical level, we also can move from 3-dimensional space to the 4th dimension in time, simply by using the formulas and calculations and taking into account the leap that we are making, because moving into time is different from moving from the 1st to the 2nd to the 3rd dimension. By refining this process, however, we can indeed make the transition to time. The result is an abstract 4-dimensional space. We can remain on the abstract, purely intellectual level as long as we do not need to visualize what we are doing. When we attempt to do so, however, we are confronted with the problem of elasticity, whereas our purely abstract train of thoughts led to a regressus in infinitum. We also can imagine initially that a pendulum simply will continue to swing indefinitely, but in dynamics we have oscillations. That is the reality of the situation. When we rise to the level of imaginative perception, we cannot simply repeat the process indefinitely, assuming the existence of a 4th and subsequent dimensions. If we use the notation plus A for the first dimension, plus B for the second, and plus C for the third, we cannot, if we are describing real space, write the fourth dimension as plus D. Instead, the reality of the situation forces us to write minus C. The fourth dimension simply nullifies the third, and only two remain. At the end of the process, therefore, we are left with two dimensions instead of four. Similarly, if we assume the existence of a fifth dimension, we must use the notation minus B for it and minus A for the sixth. That is, we come back to a point. Through the principle of elasticity, we have returned to the starting point. This phenomenon not only is present in imagination, that is, as a subjective experiment, but also becomes a reality in the way I described the day before yesterday. As long as we are looking at the Earth's surface here and plant roots here, see figure 66a, we are dealing with a specific manifestation of gravity and remain within the ordinary dimensions of space. When we attempt to explain the shape of a flower, however, these ordinary dimensions no longer suffice. Instead of taking the intersection of the axes as our starting point, we must begin with infinite space, which is simply the counterpart of the point. Instead of moving centrifugally outward, we must move centripetally inward. Again, see figure 66a. The result is a wavy surface. Instead of dissipating into the distance, pressure is exerted from outside, resulting in gliding and scraping movements. Such movements, which result from pressure, cannot be described correctly by taking the intersection of axes as the starting point for our coordinates. Instead, we must take an infinitely large sphere as the center of the coordinates, and the coordinates must all move toward the center. That is, as soon as we move into the etheric realm, we need to apply an axial coordinate system that is the opposite, also qualitatively speaking, of the ordinary coordinate system. Ordinary theories about the ether of physics err in not taking this difference into account, making it difficult to define the ether. It is sometimes seen as a fluid and sometimes as a gas. It is wrong to apply a coordinate system that radiates from a central point to the ether. As soon as we enter the ether, we must take a sphere and construct the whole system from the outside in, instead of the other way around. Such issues become interesting when they are traced mathematically and enter the domain of physics. Developing our theories, which begin to seem very realistic, would contribute a great deal to solving problems of limits. At present, however, such theories meet with very little understanding. For example, I once attempted to introduce this subject in a lecture to the Mathematical Society of a university. In this lecture, I said that if these are the asymptotes of a hyperbola, and these its branches, we must imagine that the part on the right is dissipating, while the part on the left is becoming concentrated. That is, a complete reversal takes place. See figure 66b. Such considerations gradually lead us to a more concrete treatment of space, but this treatment finds little acceptance. Purely analytical mathematicians often are somewhat biased against synthetic geometry. Modern synthetic geometry, however, permits us to move away from purely formal mathematics and tackle empirical problems. As long as we apply only purely analytical geometry, we cannot approach the domain of reality. Analytical geometry allows us to establish only the end points of coordinates, their geometric locations, and so on. When we restrict our constructions to lines and circles, we need the help of images and are forced to turn to visualization for help. What makes synthetic geometry so beneficial is that it allows us to leave behind the formal aspect of mathematics It shows us how we must conceive of the mathematical element in nature. Question about the theory of relativity. Steiner's reply. The discussion about the theory of relativity is endless. This theory cannot be refuted from our vantage point as observers of cosmic events in three-dimensional space. That is, it is impossible to refute the theory of relativity on the basis of perceived space. As far as our perception is concerned, of course it makes no difference whether a sphere flattens out or space as a whole expands inward in the direction of the sphere's flattening. Thus, as long as we are dealing with the perspective of three-dimensional space, Einstein's theory of relativity is absolutely correct. This theory appeared at the very moment in humanity's evolution and in the history of science when we first managed to think in purely spatial terms. That is, to take Euclidean space as our starting point for further thinking, whether in the sense of non-Euclidean spaces or in the sense of relativity theory. It is impossible to refute Einstein's theory in three-dimensional space. We can begin to discuss the possibility of refuting this theory only when we discover how to make the transition to the etheric realm. That is, the transition from the three-dimensional spatial body to the ether body. The ether body is centripetally rather than centrifugally formed. In your ether body you dwell within the totality of space. For example, your inner perception of the distance between point A and point B is sometimes this and sometimes that. See figure 67a. Having recognized this phenomenon, you can say that one or the other of the points must have moved in absolute terms, but to do that you yourself must stand within the totality of space. At this point, discussion becomes possible. For this reason, I am convinced that all of our discussions of current concepts about the theory of relativity must end in the question, quote, well, how do you know that? Close quote. In contrast, as soon as we make the transition to inner perception, a domain where absolutes can be discovered, we are forced to realize that issues such as the theory of relativity show us that we have arrived at what Nietzsche calls the observer's standpoint, of which the theory of relativity represents the most extreme version. For anyone who accepts this standpoint, the theory of relativity is simply a fact, and no arguments against it are possible. It can, however, be eliminated from practical considerations. A fanatical relativity theorist in Stuttgart once explained why it makes no difference whether we make a movement in one direction or the opposite direction. If I hold a matchbox in one hand and a match in the other, the result is the same whether I move the match past the box or the box past the match. Of course, in such cases, the theory of relativity is absolutely correct, but I would have liked to shout out, please try again with the box nailed to the wall. This in no way diminishes the validity of the theory of relativity. It simply shows that just as we can move from two-dimensional space into the dimension of depth, we can move into the spiritual element from any location in the world. Then and only then does the theory of relativity cease to be valid. That's why I said that discussions about the theory of relativity tend to go on ad infinitum, because it is irrefutable from the observer's standpoint. Any arguments against the theory can always be disputed. As an observer, you stand outside what you are observing. You must make a radical distinction between subject and object. As soon as you rise to higher levels of knowledge, subjectivity and objectivity cease. There is much more that could be said on this subject than can possibly be said in the context of a question and answer session. But I would like to submit one more idea as a stimulus to further thinking. As long as we remain in the beholder's world, in the world of space, relativity theory as such is irrefutable. On first escaping from this world, we enter worlds where we are not mere beholders, but share the experience of the object, such as pain, for example. As soon as you learn to shift from mere relationships with other beings, and it is understandable enough that a theory of relativity is possible only within relationships, to the pain of shared inner experience, to use an example, it is no longer possible to speculate about whether this experience is relative. Thus you cannot construct contradictions and then say that because a contradiction exists, the situation is not real. In life, contradictions are reality, because the beings that constitute life belong to different but intersecting spheres. As soon as you make the transition to reality, it is no longer permissible to say that any contradiction that exists must be resolved. If it is real, it cannot be resolved. My point here is that the theory of relativity is a natural development in the world of relationships. No arguments could be raised against this theory if the beholder's standpoint were the only possible perspective. As soon as we become involved in beings, however, and in pain and pleasure, the theory of relativity is no longer tenable. Question. Dr. Steiner, what do you mean when you say that the physical body is a spatial body, while the body of formative forces is a temporal body? The physical body is also active in time when it grows and declines. Steiner's reply. Yes, but your statement is based on imprecise thinking, if I may say so. To give it a more exact foundation, you first would have to analyze the concept of time. Consider this. In the reality we usually encounter, space and time intermingle. We can conceive of the physical body as spatial and the body of formative forces as temporal only when we separate space and time. In our usual objective knowledge, time is not present as a given. As you know, time is measured in terms of space. That is, changes in spatial units are our means of knowing about what we call time. But now, imagine a different way of measuring time. You no longer measure time in terms of space when you shift to a true experience of time, which people usually do unconsciously. Our thinking actually becomes conscious through imaginative cognition. You have a true experience of time, for example, if you examine your soul life on April 12, 1922 at 4:04, and however many seconds. You see a temporal cross-section of your soul life. Although you cannot say that this temporal section contains any particular spatial section, it includes all of your immediate earthly past. If you want to draw it schematically, and the stream of your experience flows from A to B, you must draw the section AB. See figure 67b. You cannot avoid interposing your entire experience into this section, and yet there is a perspective in it. You can say that events lying further back in time are reproduced with less intensity than more recent events. All of these events, however, are present in the single section. As a result, the connections are different from what they are when you analyze time. We can raise time to the level of a mental image only when we refrain from analyzing it as we do in physics, according to methods of understanding space, and instead reflect on our soul life. As long as you have only abstract thoughts, however, your soul life remains stuck in the time body. It is important to be able to see this time body as an organism. As you know, when you have a digestive disturbance, for example, you may find that other parts of your spatial organism also are affected adversely. In the spatial organism, individual areas are spatially separate from each other, while in our time organism, in spite of the fact that we differentiate between later and earlier, different times are related organically. I sometimes use the following example. When some very old people talk to younger ones, especially to children, their words seem to bounce right off. They mean nothing to the children. This is not the case with other old people. When they talk to children, their words seem to flow straight into the children's souls. To find the origin of the power of old people to bless others, you sometimes have to go back to their early childhood. Parenthesis, we usually do not study matters such as this because we very seldom look at the whole person. We do not focus our attention long enough to observe such things. The scope of our present powers of observation is inadequate. That is a task of anthroposophy. Close parenthesis. If you go back far enough, you will find that those who possess an unusual spiritual power to bless others in their old age, whose words flow as blessings into young people, learned how to pray in their own childhood. Metaphorically speaking, we can say that the folded hands of childhood become the blessing hands of old age. Here you see a connection between a person's influence on others in old age and the pious sentiments and so on that were present in that person's early childhood. Earlier qualities and later ones are connected organically. There are an infinite number of such connections in each person, but we see them only when we understand the whole human being. Today our whole life is external to this reality. We think we are steeped in reality, but we deceive ourselves. In today's culture, we are abstractionists. We pay no attention to true reality and therefore disregard qualities such as those I mentioned. We also pay no attention to the fact that when we teach children, especially in the elementary grades, we must avoid giving them sharply defined concepts. The effect of such concepts on later life is similar to that of binding limbs and not allowing them to grow larger. What we communicate to children must be an organism, and it must be flexible. I hope that you are gradually becoming able to see what I mean by an organism. Of course, imagination alone makes it possible to grasp this meaning completely. Nonetheless, it is possible to gain an idea of the nature of an organism simply by realizing that the temporal course of events in the life of a human being is related to the time organism rather than to the space organism. You see, time possesses an inherent reality, as you can infer from mathematics. I believe it was Ostwald. In any case, it was not an anthroposophist, but simply someone who is not a materialist, who pointed out in a wonderful discussion of this subject that unlike mechanical processes, organic processes that take place over time are not reversible. In fact, ordinary calculations always remain external to temporal processes and do not allow us to approach them. For example, if you insert negative numbers into a formula for calculating eclipses of the moon, you get instances in the more distant past, but you do not move away with the things. You move only in the sphere of space. Thus we develop a correct idea of the actual physical human body only when we are able to separate the temporal element from the spatial. This is fundamentally important with regard to human beings, because we cannot come to any understanding of human beings if we do not know that the temporal element in humans runs its course as an independent entity, and that the spatial element is governed by the temporal or dynamic element. In machines, however, the temporal element is only a function of activity in space. That is the difference. In humans, the temporal element is a real entity, while in mechanical devices, the temporal element is only a function of space. Question. Einstein says that the time-space continuum is four-dimensional. If I understood correctly, you said that the fourth dimension becomes two-dimensional, because the fourth dimension is a negative third dimension. Should this be interpreted to mean that there is a connection between the imaginative world and Einstein's continuum? According to conventional scientific thinking, I would have to conclude that such a space is a plane. Consequently, the imaginative world would be a very specific plane in three-dimensional space. It would not have to be straight, and it would not have to remain in the same place, but it would have to be possible to confirm its presence at any given moment. My thoughts on this subject are probably not in line with anthroposophy, but I would like to know what anthroposophy has to say about it. Steiner's reply. With the exception of a few comments, your thoughts are quite in line with anthroposophy. I would like to add that it is absolutely correct that when we attempt to shift from the 3 dimensions to the 4th on a real rather than abstract level, we must use a negative sign to describe the 4th dimension. That is, the transition to the 4th dimension simply eliminates or cancels out the 3rd, just as debt cancels out savings. There is no other way of imagining the situation. But if we simply hurry on abstractly, we come to the regressus in infinitum that assumes the existence of more and more dimensions. This, however, is an abstract way of continuing and is not based on actually looking at the situation. When we enter the imaginative world, we do indeed confront a plane world, to use an expression borrowed from geometry. We confront the world of the plane of time. One peculiar feature of this world is that it can no longer be referred back to the 3rd dimension of space. This is difficult to understand, but you will find an analogous situation in synthetic geometry, which is forced to consider the boundary of 3-dimensionality. If, in fact, we impose boundaries on the 3-dimensional world, as a surface and as a plane surface rather than a spherical surface. That is, synthetic geometry assumes that 3-dimensional space is bounded by a plane. When you reach the boundary of 3-dimensionality, you find a plane whose limit, in turn, must be imagined as a straight line rather than a circle. And this straight line has 1 rather than 2 endpoints. At this juncture, your thinking and your perception cannot completely coincide, no matter how consistent it is to speak of a plane as the boundary of 3-dimensional space, of a straight line as the boundary of a plane, and of a single infinitely distant point as the limit of a straight line. To synthetic geometry, these ideas are real. Synthetic geometry plays into the perception that develops in the imaginative world. But when we say that the imaginative world lies in a plane, we cannot refer this plane back to 3-dimensional space by defining its coordinates. It is lifted out of 3-dimensional space and is anywhere and everywhere. This is difficult to imagine, because we are used to visualizing in 3-dimensional space. The imaginative world, however, does not lie in 3-dimensional space, and the definitions of 3-dimensionality do not apply to it. We find another analog for the imaginative world in art, when we practice painting on the basis of color. When we do so, we are working on a flat surface, or if we work on a curved surface, its curve does not originate in the painting, but in other circumstances. When we paint on a plane, our possibilities are not limited to drawn perspective, which is a relatively recent discovery, as you may know. Perspective appeared very late in the history of painting, only a few centuries ago. In addition to drawn perspective, however, we can utilize the perspective inherent in color. We have been using such principles in our painting in Dornach. On the basis of feeling and color, rather than thoughts, yellow appears to come toward us so strongly that it is almost aggressive. In contrast, when we use blue paint, the color recedes, yet both colors lie on the same surface. Thus, it is possible to express 3-dimensional phenomena, even though only a 2-dimensional expanse is available to us. This is simply an example to help you visualize the situation, because the imaginative world is not the same as the world of painting. Although the ideas you expressed in your question are very true to anthroposophy, we cannot really say without qualification that the imaginative world has a connection to Einstein's continuum. Einstein's continuum is based on abstraction rather than perception. Its 4th dimension is constructed as an analog to the other 3 dimensions, which is not acceptable when we move from objective cognition in space to real suprasensible cognition, which manifests first as imagination and can be expressed in spatial terms only by allowing the third dimension to be cancelled out by its negative. What I am going to say next will seem very daring to some. Nonetheless, it is my experience. In reality, the situation looks like this. When you function in the objective world with healthy common sense, your orientation is derived only from the three dimensions of space. The first dimension is inherent in your own upright posture, the second in your left-right dimension, and the third in the focusing of your eyes. You do not dwell in these three dimensions when you are in the imaginative world. There you dwell only in two dimensions. If I had to locate these dimensions in space, I would have to take a vertical section through the human being. In imagination, we can speak only of the dimensions of up and down and right and left. When you move in the imaginative world, these are the only dimensions you carry with you. For this reason, I cannot say that they relate to a coordinate system in space. I cannot define them in terms of Euclidean geometry. To our perception, however, they are real. It makes no sense to talk about three dimensions in the context of the imaginative world. We must realize that we are dealing with an experience of two-dimensionality, an experience we cannot have in the objective world. Two dimensions are a reality in the imaginative world, and a single dimension is a reality in the inspired world. All inspirations move vertically, if indeed we want to assign them a location in space. Intuition is point-like, but it too cannot be referred to a coordinate system. In these higher realms, we cannot revert to Euclidean space. Questions and Answers, Dornoch, December 29, 1922. Discussion. As you will have gathered from the lecture, we must make a distinction between tactile space and visual space. This difference can stimulate us to move beyond considering mathematics on the one hand and the physical world on the other. As you may know from my lectures, it remains true that mathematics is a product of the human spirit or of the human being in general, and that as we move further into purely mathematical domains, that is, domains that are delineated in mathematical terms, we become less and less able to apprehend reality. You have all seen the difficulties that have arisen repeatedly in modern times, when people have attempted to use mathematics to describe reality. For example, if you consider the transition from an infinitely large sphere to a plane, you scarcely will be able to reconcile this cornerstone of projective geometry with our ordinary ideas of reality, which are based on empirical interaction with the world around us. Consequently, our task, and many people with the appropriate educational background would have to work very hard at it, is to attempt to use mathematical ideas to apprehend reality in very concrete domains. At this point, I would like simply to present the problem. It can be solved successfully only if mathematicians really begin to work seriously on it. I have provided a theoretical explanation of tactile space. Now, try to handle this space in a way that necessarily incorporates all of our earthly experience of touch. In fact, that is what we are dealing with. We must incorporate all of our tactile experience, including its inherent dimensionality, into our relationship to gravity. We are subject to gravity, and the various centripetal forces coming in different directions from the periphery make it possible to set up differential equations. With regard to tactile space, we must handle these equations in the same way that we handle equations for determined movements in analytical geometry and analytical mechanics. It then becomes possible to integrate these equations, which gives us specific integrals for what we experience in tactile space, whereas differentials always lead us out of reality. Integrating these differentials results in the diagrams I told you about the day before yesterday. If you want to return to their reality, you must do it as I indicated in that lecture. You must work with the integral equations in the domain of real touch. It will become evident that with regard to touch, the vertical dimension has a certain differentiation, so that the variable x in this equation must be preceded by a plus or minus sign. This makes it possible to set up integrals for our experiences of tactile space. Let me formulate it like this: the integral of f of x dy. The result would be integrals for our experiences of tactile space. Now let's move on and apply the same principle to visual space. Once again, we set up differential equations that we must handle in the same way that we handle equations for determined movements in analytical geometry and analytical mechanics. We will see that when we integrate, we get very similar integrals, but ones that must be thought of as negative, taking into account that the variable x was positive in the last instance. When we handle the integration in this way, I'll dispense with all the trimmings, we get a result that leads to other integrals, the integral of f of x dy. But when I subtract the two from each other, they almost cancel each other out, and the result approaches zero. That is, when I integrate with regard to visual space, the result is integrals that cancel out those for tactile space. And the integrals for tactile space remind me very much, though they are more extensive, of all the formulas I need for circumstances and relationships that refer to analytical geometry or mechanics in general. The only difference is that gravitation must be included in the mechanical formulas. I get integrals for visual space that seem applicable if I simply can find the right way to express the spatial aspect of vision in mathematical terms. It is always the case that we begin with a trivial instance and set up constructions about vision, and fail to note that we must count on inevitable vertical movement when we consider visual space. We must accept that vision is always forced to work in the opposite direction from gravitation. Taking this fact into account, it becomes possible to relate the integrals to mechanics on the one hand and optics on the other hand. In this way, we formulate mechanics, optics, and so on in usable integrals that encompass the reality of a situation. It is not quite true, however, that the difference between the integrals is zero. In actual fact, it is a differential, and instead of writing 0, I must write dx equals positive integral minus negative integral. If repeated searches for such integrals and the resulting differentials lead to differential equations corresponding to dx, I then will see that when I take dx to be positive here and negative there, dx is an imaginary number in the mathematical sense. If I integrate the resulting differential equation, however, the result is astounding. You can experience it for yourselves if you solve the problem correctly. This step leads to acoustics, to acoustical formulas. Thus you really have used mathematics to apprehend an intrinsic reality. You have learned that we must write mechanics down below on the vertical and vision up above on the vertical, since light is equal to negative gravitation, while hearing, in reality, takes place horizontally. When you set up these calculations, you not only will observe discrepancies, mathematics on the one hand and physics on the other, as a result of the Lagrange equations, but you also will see that the work that can be done on this basis in the realm of mathematics and physics is just as productive as the work I pointed to earlier in the domain of phylogenetics. Along these lines, by working things out, not through merely descriptive considerations, we discover the differences between modern natural science and anthroposophy. We will have to demonstrate that our calculations are firmly rooted in concrete realities. And that is the end of the last section believe it is section 13 of the book, and the end of the book, The Fourth Dimension, Sacred Geometry, Alchemy, and Mathematics by Rudolf Steiner, Collected Works, volume 324a, translated by Catherine Creeger.